Hey guys, welcome to this session by Intellipaat. JavaScript has come such a long way in adding so much value into the world of web applications and websites today, right? And of course, when you think about JavaScript, I think the biggest library whenever someone talks about JavaScript is ReactJS because it is extremely popular. It is used by thousands and thousands of people out there, and everyone realized that you can build amazing user interfaces with React.js. So keeping this in mind, we here at Intellipaat have come up with this full course video on React.js to make sure we can help you guys to learn and master React.js as well. Well guys, before we begin with the session, make sure to hit that subscribe button and that bell icon so that you will never miss any updates from us. And on that note, to check out the agenda of the session, we'll start out by taking a quick introduction to understand what React.js is. After that, we can check out all the features of React.js and the advantages itself of making use of React.js. And now, after that, we're going to check out in detail the components that are involved. You have the virtual DOM, you have lifecycle methodologies, you have class components, you have functional components, and a lot more things there as well. And then talking about React hooks are very important and you should know about that. So we're going to be discussing that in detail, and of course forms in React as well. And then at the end of it, we have two more components where we'll be discussing a thorough end-to-end project where you guys will be taught how you can build a chat application based on using React.js. And of course, it's going to be a hands-on session with a lot of detail and practical knowledge there as well. And lastly, the last item on the agenda we have is a complete set of top React interview questions and answers that you guys can use to ace your interviews as well. And guys, if you're looking to become proficient in React.js, make sure to head to the Intellipaat website and check out the React.js training course. You can use this course to gain in-depth knowledge about React.js and of course become proficient in all of the concepts involved as well. And now without further ado, let's start the session.
Now let's take a look at what is React.js. We'll try and demystify what React.js is and why is it important for us to understand what it actually means. Why React.js is so popular is something we'll take a look at afterwards, but firstly we'll have to understand what React.js is all about. So React.js is a UI library. UI stands for user interface. So it's a user interface library that allows developers to build small self-contained UI components which can be used to build a user interface. So whenever you take a look at a user interface of any application, whether it's a web application, mobile application, desktop application, you will see that it's built using some components. These components are repeated all over the platforms. So even on an Android mobile, these components may be repeated. So the components could be a button, it could be a text field, an editable text field, a table view, it could be an image carousel in which you can take a look at all the images that are available by swiping on them or clicking on the arrow buttons. It could also be some image gallery and all of that. And many of these components are built by grouping together smaller components. So a good example of this is a form. A form which is used to collect users information is built by grouping smaller components together. Components such as text field, input field, submit button, and labels and things like that. So React.js allows us to write JavaScript code that allows us to build these components. These components can then be arranged in a hierarchy structure in which we define where does a particular component go declaratively, and using that we can build up the entire user interface. The user interface built using React.js is built completely using JavaScript. So we don't have to understand and define how you can use these components. We just need to define what these components look like, what their styles is going to be, and how they are going to interact with the events that the user dispatches. So when the user clicks on a particular component, what should happen and should something happen or not, things like that. So React allows developers to write really declarative code in JavaScript to efficiently assemble together a user interface. So thing is that what React allows us to do is that it allows us to declare our user interface rather than imperatively dispatching commands that lets the browser know how to piece together the user interface. So React allows us to just declare, okay, I need a button, I need inside the button I need some text, and the text should be this, instead of us having to create a button from scratch and then assigning some text to the text field and stuff like that. If you have dealt with the old school DOM manipulation way, which we'll cover in a few moments, is how it works in DOM generally is you have to create these components or elements yourself. Then you have to edit their attributes, and you have to add the children attributes. Once you've done all of that, you have to assemble them together in a tree-like structure, which is the DOM tree or document object model tree, in which you have all the child components and parent components efficiently rendered together. So you have to create like a form. Inside a form, you have to attach all the text fields and labels. You have to associate labels with the text fields. You have the input fields. You have to associate types with them. So for instance, some input fields can have passwords. Some input fields can have email. Some input fields can have numbers in a particular range, and so on and so forth. So that's how we're supposed to do that. Keeping that in mind, when we declare our code using React.js, it feels like we're writing HTML, but that's not what we're doing, which we'll cover in a later segment. But that was one of the major controversies with React when it released. So if you've seen some code in React, you can see it as being written HTML with CSS and JavaScript, which is not exactly how it's supposed to. So we'll cover that as well. So it allows us to create user interfaces using just JavaScript and writing the user interface code very declaratively. We do have to create the markup for our components so that our components understand what is it we're trying to display, fancy button or something like that. Also, React.js is maintained by Facebook and were released in 2013. Sorry. So as you can see, React.js has been out for quite a while, and there have been some massive advancements in the development of React. Currently, React.js is in its 16th version and 17th version is being released. React.js is by far one of the most popular user interface libraries. It has overtaken Angular and Vue in popularity and in job requirements as well. React.js is very popular because it's very simple. It's very easy to understand, and it's very easy to learn and use as well. Now, when I say easy, I don't necessarily mean simple. There is a sufficient mental model shift that you need to understand. If you worked with the old school way of creating DOM elements and then updating those DOM elements and then inserting the data, that is going to be difficult in this scenario. So we'll have to take a look at that. But overall, it works fine. So in conclusion, what React.js is that it's a user interface library that allows us to build user interfaces by declaratively writing JavaScript code. The JavaScript code is maintained by React. So if any changes happen to the thing that we have rendered, all the components, React will take care of assembling those components, re-rendering the changes, and making sure everything is done as efficiently as possible. If React was not there, then we would have to write the code to figure out what are the things that we have to change. And once we do change, then we have to display it to the user, and that's about it. And that's how it's supposed to work. And now let's take a look at what else we have. We'll take a look at why you should use React.js. So this will give you a good foundational understanding of the reasons that you should pick React.js, or what are the things that people consider when trying to use React.js in their project. As we have already seen what React.js is, it's basically a user interface library. But why would you use it over just plain JavaScript and HTML? Let's take a look at that. Well, although we can use plain HTML and JavaScript to build user interfaces, React offers many benefits over them. So if you're using plain HTML and JavaScript, you can use it, and for simpler applications, it's much more efficient and much more better to not include other libraries. When you build libraries that are not trivial, when you're building applications that are not trivial, that could be difficult to implement with plain JavaScript. This is where React comes into play. So let's take a look at the problems that are overcome using React.js. The first one is performance. React.js is much more performant than plain JavaScript DOM manipulations, as it only updates those nodes that need updating. In case you've ever worked with React.js, it's only going to update the things that need to be updated. It's not going to update things that don't need to be updated. So if you've used React.js before, React.js only takes care of all the things that are needed in order to update your components. So for instance, if you have created the entire user interface using plain DOM manipulations, then a really big problem that you need to tackle is how to keep the changing data in sync with the user interface. One way would be to just re-render the entire thing, but suppose you have only changed one thing. Suppose you have only updated the count of likes on a post from 6 to 7, then it doesn't make sense for you to just re-render the entire component tree, because it could be very expensive. You could have a lot of images that you have gotten from server, and you have a lot of data that you need to parse in order to build the user interface. That could be really inefficient. So what React does is that it just tell React where you want to display some data that could change, and React will from then on take care to monitor that place, and when the data that is being displayed on that page changes, it will just change and update that point in data. and nothing else needs to be updated there. And that's how React takes care of everything else. The second advantage is declarative. Now, declarative basically means that it allows us to use declarative syntax to describe our user interface, which is very easy to read, understand, and share. Declarative basically means that instead of us having to write all the instructions of how to piece together, how to create elements, how to piece together those elements, how to insert data into each of those elements, which could be really cumbersome and really difficult to understand. Declarative basically means that it allows us to declare what our user interface should look like. So if, for instance, if I'm creating a form, instead of me having to create a form element, then create an input element, setting the placeholder text, setting the IDs, classes, and then nesting them into one another, what I can do is I can just describe, okay, declaratively write, okay, I want a form tag here, and inside the form tag I want an input tag, and on the input tag I want this placeholder, and when I click on the input tag this should happen. That's all I want to do. So this is why we use declarative syntax of React. React makes our applications really easy to read and understand, because the declarative nature of React components allow us to just take a look at the user interface that has been declared and allows us to keep everything in mind, because it's not that difficult to understand. If we have each line containing a single instruction on how to build the user interface, that could be really difficult. But if we have a declarative markup that just declares what the user interface should look like, then it's really easy for us to understand. Then comes component based. So React allows us to describe our user interface into self-contained components that can be shared and reused in other applications. So if you have ever worked with user interface libraries before React, what they used to do is they used to describe modules, they used to describe the user interface as these large monolithic chunks that could be really difficult to wrap your head around. On the other hand, React takes a different approach. It takes a look at your user interface as a series of components that can be nested together and formed a tree of user interface elements, which makes sense. So if you have a web page, if you take a look at that, it's basically a nested components. So you have a web page, that web page has a form, that form has a submit button and a few input tags. That input tag contains some validation and some styling. That button has its own validation and styling, and that button gets repeated into other places in your system as well. So you can use it in that regard. This is why components are so useful, because you can reshare and reuse the components that you have created so far. If I've taken a component that takes care of getting data from the user and in a form, then I can just create another form using that component. I don't have to write the code for it entirely. I don't have to copy paste it again as well. All I have to do is import that component into my front-end application and then declaratively describe, okay, I want to see this code take effect into my front end. And that's one way I can do it. So ReactJS allows us to write code that are self-contained components, and self-contained components contain everything that we need for that component to work: its markup, its styling, and its behavior, which is HTML, CSS, and JavaScript. And all we have to do is just describe it, make sure that it works the way we expect it to work, and then ship it. Then other people can use it. Finally, we come to data binding. So data binding is one of the most crucial aspects of any front-end library, but React takes a very different approach. So if you ever worked with Angular, they provide the ability to have a two-way data binding. This has always been one of the critical features that Angular provides. So two-way data binding basically means that you can do things in the user interface that changes the data, and you can internally change the data that will in turn change the user interface. Both ways of changing the data and user interface are applicable. In React.js, it's a little different. Although there's only one way data binding, and that data binding only means that you can only change data from the user interface. That user interface, or if the data changes from the backend, that's also fine. But what happens is you can't just link those changes together, because the updating of the data is taken care of by React. So React combines data with markup, and it takes care of keeping the user interface in sync with the changes made to the data. So if you ever have data that's constantly changing and your user interface is updating constantly, like for instance in stock market, in movie trading, and other kinds of things, if you're doing things like that, then React is a good choice, because what it does is that it will take care of updating the data from the connection that it has already. And that way you don't have to worry about creating more and more complicated logic to keep your data in sync with your server-side database. Now, many other ways of doing things are available as well. But if the data is changed, then React will take care of updating that data everywhere where it's displayed, and you don't have to worry about it being displayed on one changes or one place and not being displayed on the other place. So React takes care of a lot of the heavy lifting for you. So you can only worry about how your application should look and how it should behave when certain events occur in your system and when some data change. Alright, so now let's see what else we have to do. Let's take a look at what is DOM. We've been talking a lot about DOM and how React.js keeps everything in sync with the DOM, but we'll try and understand what DOM actually means. DOM stands for Document Object Model, and it's the tree structure of our HTML components, but we'll try and get a bit deeper into it. So DOM actually stands for Document Object Model. That I think we all knew. It is a tree-like structure that is used to represent the structure of all the elements of an HTML document. So when we create an HTML document with all the markup, the tags, the attributes, and all of that, it creates a tree-like structure in which HTML tag is at the top. Then we have the body tag, which is its child node. Then we have the head tag, which is also the child node of HTML tag, and it has a lot of information about the content of our website, such as the SEO related stuff, the style sheets, and so on. So these are all arranged in a tree structure. Now, why in a tree structure? Because it makes it very easy for us to navigate from the top of our HTML tag to the particular element that we're interested in, and we can manipulate it in Java. We can manipulate it by getting a reference to it. We can manipulate it by, after getting a reference to it, we can manipulate it by changing its attributes, its content, its type. There could be a number of things that we can do. And that allows us to manipulate it on the fly. So when we click a button and we want to make some changes to our page's HTML content, we can do it using manipulating the DOM. So DOM creates a hierarchical structure. As a tree structure is a hierarchical structure that we have parent and child and sibling and grandparent and all that. And in that, what it does is that DOM can be used by programming languages like JavaScript to interact and manipulate. Now, it can be used by JavaScript, but that's not the only language that can use it. For instance, if you're into web scraping, then you can take a look at Python, Beautiful Soup, and they also understand the document object model. And you can just traverse the structure of the tree once you understand the structure. And with that structure, you can pinpoint to the content that you want to manipulate or save, and you can do that. Now, DOM is a standard interface for interacting with web pages using programming or scripting languages. So it's not that DOM is something that people haven't used yet. People use DOM all the time, and it's a standard programming interface. So anyone who interacts with the web page, who tries to get data from a web page, converts the HTML string into the DOM structure and then manipulates it the way they want to. The reason why JavaScript does it is because exactly the kind of thing that it was built to do. JavaScript was created so that it can manipulate and add functionality to web pages. As times grew, though, JavaScript's reach of what it could do became even more, and now JavaScript can do a whole lot more than just manipulate the DOM. But it's still one of its major features and one of the major reasons why we use DOM, right? So now let's take a look at what else we have to do. Now let's take a look at ReactDOM. We've taken a look at what DOM is, but when we're working with React in the browser, we need to also work with ReactDOM, which is one of the libraries that React uses underneath the hood. Let's take a look at what it is and why do we need to use it. So React is a user interface library, but it's built with the purpose of building user interfaces. It's not limited to web. It could also be extended to be used on mobile applications or virtual reality applications such as React VR or React Native, not in that order. But you can use React to build applications for the web, for the mobile platform, which could be cross-platform such as Android and iOS. And you can also use it to build applications for virtual reality apps. Now, that being said, how can you build such applications for such different platforms when you have a single library? Well, the answer is that they have separated the essential parts from the variable parts. So when we're using it on the web, that is when we're using it to build the front end of the web application that we are going to be building, then it needs to interact with the DOM. To make that interaction easy and make that integration seamless, we use ReactDOM. So what ReactDOM will do, it will take a look at our component tree and it will take care of converting that component tree into DOM elements and keep track of managing that component. So we can create the components using React, and then when it comes to integrating our components with the actual web DOM, we can basically just use ReactDOM and it will take care of it all for us. That's what ReactDOM actually is. ReactDOM is nothing more than just a library. Now, it's basically just a package that contains DOM specific methods used by React to enable itself to interact with the DOM. So if you're using React and you want to build applications for the web, then you use ReactDOM. Other libraries such as React Native and React VR have their own bridging system, so you don't have to worry about that at all. All you have to worry about is how you can build user interfaces using DOM or React DOM in that specific scenario. So all React DOM does is that it bridges the gap between the React user interface library and the web DOM platform. So if you want to build React applications by creating components that can then be translated into DOM elements and managed by React, we use React DOM specifically for that purpose. Now let's take a look at UI without React.js. So when you're building user interface without React.js, what are the kinds of things that you need to tackle? The first thing is decomposition. So we can quite easily build user interfaces without React.js. So if you want to build a user interface without React.js, you can do it. Especially for smaller applications, it's also a recommended way that you go without React.js. But for any reasonably sized application, it involves some really difficult challenges. One of those challenges is decomposition. So when you're using React.js, we can create small isolated individual components which can then be composed together to create the entire user interface. So if you have a user interface that you want to create using React.js, you can do so. But without React.js, creating smaller components, combining which you can create a larger user interface can be really difficult. Whereas with React.js, decomposition is really easy. So that's why React.js is much more preferred over other component libraries. So without React.js, we would need to create the HTML tags, then use the JavaScript to add event handling code and wire everything up. So without React.js, what we do in plain JavaScript is firstly we create the HTML code for our user interface, style it using CSS. Then we get a handle to each of the components that we're interested in, such as if we are interested in knowing when a button is clicked and all of that. We get those user interface elements, and then we add some user interface elements, add some event handling code to it. So if we have a button that we want to respond to when it's clicked on, what we can do is we can just create an on-click handler, which will run when the button is clicked on. Now the browser takes care of it all. When the user clicks on the button, the event code that we have associated with the event handling code will run. This is quite easy in theory, but in practice, it's really difficult because when we have multiple user interface elements and their interaction needs to be configured simultaneously, separating these concerns can be really difficult. How do you separate the event handling code of a button from an event handling code of another button, which are two different buttons, such as the submit and the reset buttons of a form? So that could be really difficult. And when that difficulty is something that we need to manage on medium to large size applications, it could be really difficult as well. So that is why decomposition comes into play, where we can just create self-contained isolated components, and those components will take care of their own logic. They don't need to worry about how other components are working, and we don't have to go through the entire DOM hunting for each element and then assigning the behavior that needs to happen when the user clicks on a button or some other aspect of the application happens. Then comes state management. State management is one of the most important aspects in any application, not just front-end applications. But it is especially important when we are dealing with front-end applications or applications that the users can see. The reason being that state refers to the data that our application stores in the memory. So that data can be used to display things later. For instance, when we are building a chat application, the messages that you have sent so far and the messages that you are going to send right now that you have typed into the chat box, all of these are part of the state of the application. This is managed by your application. And now your application needs to take that data, save it to the database, send it to the user. The user needs to be able to see it. When the user sees it, that notification needs to be sent out to all the other users who are associated with the messages as well. And that could be a really complicated task. With that in mind, what we can do as developers is we need to firstly understand how to use state. So state management is really difficult. Mainly because if you have an application that has some data that is useful for one component and some data that's useful for other component, and then there's some data that needs to be shared between those components, that is really difficult because now we have to figure out where to put that data so that it can be easily shared by child components and so on. So that's really difficult, especially in an event-driven design such as the one that we saw earlier with plain JavaScript and HTML. Because if you're doing things like this, then what's going to happen is we're going to be able to just do state management. We're going to be able to do state management based on user interfaces event system. So when we get a click, then we are going to update something. Then we're going to make some changes to the state. But all the data that we need is going to be stored eventually in a larger global context, in a global object. All the variables that live on a global object, that's going to be really difficult to manage because some part of our application not knows what are the different names of the variables that are giving the information that we need, will end up overriding those variables, and all the other parts of our application will start breaking. And that will be really difficult for us to figure out how that is happening. So that's why state management is really important. Now, sometimes when data is being displayed, it gets changed or updated. So if you have data, let's say you have chat application, the data that you have is all the messages that you have so far when you load the application, and new data will be when the user sends a new message, updates previous messages if they have the ability to do so, and so on and so forth. So the total price that is shown on a shopping cart when another item is added also changes the total price of the entire cart. So when you add new elements, the total price needs to change as well, and many different aspects of the application need to update the data, and that is all very difficult. So this is where state management comes into play, where we can specify local state. Local state basically means just the piece of information that only one of our components is interested in, and they only need to know. So for instance, if we have an application that fetches data from the external web APIs and displays images, well, the individual components are only responsible for fetching data from each of the user interface elements and getting the images from the web server and then displaying it into the user interface element. So this is why state management is important, and simpler user interfaces without React.js, managing state, defining local state so that if we define some other state variable with the same name doesn't get overridden, can be really complicated, which is why we use React.js instead of plain user interface without React. Now, React takes care of keeping all the data and the display in sync with each other. So if the data is changed, all components being displayed are updated automatically. So if you are not using React, then you have to take care of where all the state that we are using is being referenced, and then we need to update it one by one, and that could be difficult. So adding and removing elements from a DOM tree is very performance intensive task. Now, this is what causes a lot of performance hit in a lot of our applications that we build. Whenever we add and remove or completely delete the entire DOM tree structure and then rebuild all the components that haven't even changed, that could be difficult. Unless we are very smart about it and we keep a track of what is being rendered. If that is the case, then it's not really difficult. So in situations like this, we end up using ReactJS because it gives us a massive performance boost. What React does is that it takes care of rendering the user interface without us having to muddle through the entire user interface's code, without us having to figure out what are the things that need to be removed and what are the things that need to be added and what is the best way to do it. React will just do it automatically for us. That's why React.js is so popular. Now, React solves this problem by something called a virtual DOM, which we'll discuss later on. Now, virtual DOM allows us to make updates to the components, and then the React will take care of matching the updated virtual DOM with the current actual DOM and figure out what are the things that need to be changed. It basically diffs the entire DOM and figures out what are the differences. The differences that are found are updated, and only the differences are updated. Other things are just left as they are, and that's the way it works. Finally, it comes to debugging. Whenever we're building an application that is using the user interface, it could be really difficult to us to debug this application. Debugging basically means if you run into an error, how are we going to solve it? The way we solve it usually is by going through console log statements, figuring out where the error has come from, taking a look through stack traces, but they are not really reliable ways of debugging an application. There are advanced ways as well, and you can use IDEs for that, but the tools for debugging JavaScript applications are not that good. Keeping that in mind, in React, we have React developer tools. And what they allow us to do is they allow us to, once we're in development mode and we have installed the React developer tools extension, greatly simplifies our component debugging. We can display components, we can take a look at the internal state, we can take a look at the props, where they are being passed from, at what level are the state, at what level are the changes to state are being dispatched. There are many things that we can do, and all of that is very useful. So as you can see, React is so popular because it allows us to do these many things. Now let's take a look at some of the ES6 features that are necessary for us to use in React.js, or in order to learn React.js we need to know. So let's take a look at that. So React.js recommends using ES6 features to create more readable and more concise code. Now a few of the most important ES6 features are the ones that we are going to discuss now, ES6 basically refers to ES 2015. ES stands for ECMAScript. It basically is JavaScript, but it has been standardized. So new recommendations are proposed, and then browsers implement those recommendations, and that keeps evolving. And those recommendations are given by the ECMAScript Recommendation Society. So that's how we do that. So this is why we use the ES6 features, because new recommendations were proposed in 2015. Those have been implemented and are now widely supported, and they let us write really clean and concise code. So the first thing is variable declaration. Now in ES6 we can use let or const variables and to describe variables and constant values in JavaScript. Before ES6 we would have to use the var keyword, var, which allows us to describe variables, but there were certain issues with var. If we were to define a variable inside a loop, it would still leak out to and be available outside the loop inside functions. That was really difficult for us to understand, and that led to a lot of issues. This was called variable hoisting, and that led to a lot of undesirable effects. This is why we ended up using let and const, and that's why they are most important. Then comes arrow functions. So arrow functions are used to write anonymous functions in a very concise way without using the function keyword. So when we're using arrow functions, all we have to do is we have to use the simple syntax. Instead of writing anonymous function with the function keyword and just not giving it a name, but the whole single brackets, all the element names, and then double brackets, double curly brackets, what we would have to do is we would, for arrow functions, all we have to do is create arrow like syntax, and that will work. And we'll take a look at the syntax just in a moment. Then came classes. Now, classes are the fundamental construct of an object-oriented programming language, such as Python, Ruby, Java, C Sharp, C++. All of them have the keyword class associated there. But in JavaScript, the keyword was not present. In order to create a class, you would have to firstly create a function, which is called the constructor function, then create a new object out of that function and add things to its prototype. That was really difficult for people to understand. So what they have done is they have created, instead of creating functions, we now can use class keyword and just use classes the regular way. And that works just fine. And then comes array destructuring. So what destructuring allows us to do is it allows us to get the variables out of objects and arrays. So if we have an array with three elements that we know are going to be three, and we want to get these three variables out into three variables, instead of assigning them one by one, we can do it all in one line using this destructuring. Same with objects. So if we have objects that are key value pairs, we can do the same thing with objects as well. So that's why we do restructuring, and it's a concept that's available in many other languages as well. We'll take a look at the advantages that you can use to use ReactJS, the advantages that you get when you're using ReactJS. What are the advantages that you should be looking for when you're using ReactJS? So when we're using ReactJS, it provides us with several advantages. The first one is scalability. So ReactJS works well with applications of all sizes. If you've built ReactJS applications, you've built simple small applications like to-do list applications to really giant e-commerce applications. A really good example of this is going to be Flipkart, because they have built their entire front end using ReactJS, and it's scalable because we can see that their front end is working quite well. So you can build applications using ReactJS for smaller applications to applications that are of giant size. Another example of this advantage would be Facebook. The company that has created ReactJS has built more than 100,000 of UI components that are being used in Facebook. Instagram also uses ReactJS, and many other front ends of the online websites that are of the giant scale use ReactJS. So it's quite scalable in that regard. When it comes to compositional UI, compositional UI basically means that it allows us to combine our user interface elements or smaller user interface elements that are usable into other user interfaces, and then we can modify the things that can be modified and replace the user interface elements if needed. So we can just pick and choose the user interface elements that we want to combine in our front end, and we can easily do it by importing the component, then rendering it, and then changing its behavior if it's possible and if necessary. So that's why we use compositional UI as one of the advantages. Then comes portability. Portability is one of the major advantages of ReactJS, mainly because a component can be ported from one project to other project without much hassle. If I have a project in which I have created a button component and I want it to be used in my other project as well, All I have to do is just import the button component and then display it on the screen, declaratively creating the markup. Nothing more than that I have to do. If I want to configure it, then there's a bit more work to be done, obviously. But for simple usages, it's very easy to do. So that's why portability is one of the major advantages of using React.js, and that's why many people use React.js because it's very, very portable. Portability also helps across devices. So if you're using React.js in on the web and you want to use it for your native mobile application, there are some components that you can carry over. Not all, because the environments are so different and the platforms are so different. But if you want to, you can just create the styles for one component and then at least can share the styles for those components across different user interfaces. So that's usable. And then comes performant. So React.js is very performant. What it allows us to do is it allows us to, instead of accessing real browser DOM, allows us to use virtual DOM. That virtual DOM can then be used in order to boost the performance when it comes to DOM manipulation. If we were doing it with the virtual DOM, then there would be a lot of issues. The performance would be really cumbersome, it would be really clunky, the user interface would lag at certain points, and that would be really difficult for us to get started with. So we don't have to worry about that. That will work just fine. And now we are done with the advantages. Let's see what else we have. Now let's take a look at some of the disadvantages of using React.js. So React.js is a library, but it's not free. So there are going to be some consequences of using it. So it's better to be advised of what the disadvantages might be. The first thing is its learning curve. Although it's quite easy to pick up the learning curve, the number of things that you have to learn in order to become a React.js developer are going to be quite a large number. Also, there's a there's a big mental shift in the way you look at applications. So earlier we used to build applications by creating the markup, then getting the user interface elements, and then attaching event handlers to perform some tasks on it. Now we need to change that kind of thinking to applications being a function of our markup and our state. So the markup will be what our application should look like, and state would be the data that our application holds. So if the user logs out of the application, what are the things that need to change? If the user deletes a particular message, what are the number of things that need to change? That's the kind of thinking we need to adopt when we're building applications, and that could be a little difficult to understand right at the beginning. So a lot of practice is needed in order to get understanding how to build applications like that. And comes documentation. So React.js rolls out updates and new features quite fast. So every now and then new features, new updates, new experimental features are available as well, and old features are removed, new features are added with different syntax than the experimental one. Lots of changes are happening quite fast. So because of this, online documentation tutorials might not be up to date. Some new ways of doing things that are much more efficient might have come out. Maybe there are patterns that allow us to build our applications in a much more robust way, but we can't use those patterns right now because we don't know those patterns because they have been discovered recently and we're not aware of them. So documentation isn't always up to date. The tutorials aren't always up to date. There are new things that are happening every now and then. So it could be really difficult and frustrating, especially for a beginner. Then comes JSX. So JSX is the extension to the JavaScript language that allows us to write HTML6 tag, which allows us to declaratively describe our user interface. And React will take care of creating that user interface and displaying it to the user. So what happens is, to work with React, we need to learn how to use JSX. JSX is not the easiest thing to learn, especially when you come from plain JavaScript background where you're supposed to separate JavaScript into a separate file and HTML to a separate file. When you look at JSX code, it looks a bit funny. It looks a bit difficult to understand. It looks like we're breaking some commonly used good patterns, like not mixing your JavaScript and HTML. That could be tough. Then comes state management. Now, depending on how your application is structured, managing the state of your application is among one of the most difficult aspects of React applications. If you want to manage state, you need to understand where does a particular piece of information needs to go in your component tree. So if you, for instance, if you have some list of users that need to be displayed and they have certain properties, but those properties are needed by other components as well, you need to find the lowest possible common ancestor and put the data there. It's called lifting up the state. So these are the kind of things that we need to understand. We need to be very cognizant of where a particular piece of information is going to live in our application component tree and how we are going to be able to use it. So that could be a little tough. Again, it's also a shift in the mental model, which could be very difficult to understand right at the beginning. But overall, it's quite easy to understand once you get the hang of it. So now let's take a look at how we can create our own applications that performs DOM manipulation. So I have an empty folder here. What I will do is I will open it up in my code editor. You can use any code editor that you want. I'll create two files. Just close this one. First one is called index.html. Alright. So this is an HTML file. Alright. And inside the file, the first thing I want to do is I want to right, and there's a button with the ID of add button, and finally an unordered list. Yeah. And it should have an ID of list. So I save it, and after saving it, I have it saved and created in my application or in my Explorer. Now all I have to do is I want to open it up, and this is what it looks like. So I need to add some text in the button. So this is what it looks like. Now if I want to create a new file, I can just create it, name it script.js, and finally I have to add it in my HTML code. So now that is done and we have our script. Now I need to get all the things, right? Firstly I need the list. So I just use document.get element by ID, and the ID that we gave to the list is list. Alright, that's done. Now I need the button, so I need to do the same thing. Now what I want to do is I want to create a variable named index. I'll show you why. Now button, which is the button on our page, dot add event listener. So when I click on the event, what I want to happen is I want to create an element. So I'll just create equals to document dot create element. That element needs what kind of element I want to create. It's just an li, which is a list item. Now element dot text content is going to be task hashtag plus index plus plus. So it will be task 1, task 2, task 3, and so on and so forth. And now all I have to do is I have to append it as a child element to my list. So I save it, go back, fresh, yeah, click on add, and as you can see, I'm able to manipulate the DOM. And to make sure that this is what's happening, I open the source code. As you can see, there are no list items inside the list. I can open my developer tools here as well. Click here. This is the body tag. This is the list. It's empty. Click on add. Something's added to the list. This is the task with the new tag. Add new, and as you can see, I can add them one by one, and it's working completely fine. So that's how you can do that. Now let's take a look at what else we have. We will now build a user interface without React. So this would be us performing DOM queries on ourselves, and we'll be using plain JavaScript, and you can see how tedious it is. So this is what we have right now. And if I open the folder that I have created things in, this is what it looks like. I have a simple ReactJS application or a simple front-end application without ReactJS. All it has is a script file and an index.html file with the main tag. And now we want to build the user interface inside it. So we will be using the code that we write inside our script tag. So for that, we'll need to create a few functions. We want to display an h1 tag with the text UI without React as being displayed. So that you can understand how difficult it might be, let's take a look at that. So what we'll do is we'll create a function render. Render will take children, and what we will do is we'll create our app, and for that we need document dot get element by ID, and the ID is main. The main is basically a div inside which our entire application will live. App dot append child. Chalo. That's all we need to do here. Now we need to create a few functions that we can compose with each other. First function I'll create is for creating an h1. It will also take children, and what it will do is it will first create an element. H1 is what we want to create, so we do that element dot, and what we want to do is we want to append the child and then return element. Finally, we want some text content to be displayed, so for that we need to create function named text. This will also take some content that we need to display. So now all we have to do is we need to return document dot create text node with the content that we have provided. And now all we have to do is we need to compose these functions with each other. We need to call the render function. We want to create an h1. Inside the h1 we need to pass in the text. The text would be UI without React. Save it. After manually writing all those functions and creating everything, if we rerun our app, I think we've run into some issues. We run into the console and everything is working fine. Inside the body tag, we have forgotten to link our script file as far as I can see. So all I have to do now is just type script src script.js, and since it's the same file, and now it's working completely fine. So as you can see, if we don't include our JavaScript, then it won't work. And we have a div tag with an h1 tag, and the h1 tag contains the text content UI without React. So that's how you can build a user interface, a really simple one without using React. However, as you can see that we have to plumb together all these components and figure out how to get things done. That could be really cumbersome. Now let's see what else we have. Now let's take a look at some of the new ES6 features that we have discussed thus far. We'll try and understand what these features are and what they look like and how they compare to the old syntax. So for that, all I've done, I've created an HTML page. I have created this is the HTML page. It has nothing but a reference to a script file and a console that I have opened. This is the HTML page. It has nothing, just the basic HTML skeleton and the script.js reference. And every code that we write will be written here. So let's first understand our variables using let and const. So the things that we have to understand are let and const are the first one. So what we do is if I create a block, so if I create variables inside a block, inside an if statement, let's say, so x is equals to 1, y is equals to 2, and z is equals to 3. If I try to console log them outside my if statement, although I've declared them inside the if statement, they should not be available outside. Look what happens. As you can see, they are available. In fact, I can put them inside my console as well. So the reason why that happens is because of a feature in JavaScript called hoisting. What hoisting does is that it takes all of the variables and the function declarations that we have created, no matter how deeply nested they are, and it gets bubbled up to the top. So now it's available everywhere we want to use it. The reason that happens is because if we declare a function, let's say I declare a function named function a app, right? And inside it I have written whatever I want to do, and I call it before I have declared it. Now that would have been an error because my application knows nothing about it. But if I have done it using hoisting, then it knows that, okay, this is a function, I'm going to bring it when it tries to interpret it, brings everything at the top, and then tries doing things. But it doesn't make sense with the variables, and that causes a lot of issues. So to solve this scoping issue, developers of these languages came up with an idea. The variable is going to be there. We can create one for let and we can create one for const. Now if I run this, as you can see, y is not defined. If I remove x and y here, sorry, y and z, just use x, it's available. Now what is the difference between let and const? Both of them are scoped to a particular scope, but what the difference is this. dot log, and let x is equals to 10, const y is equals to 11, right? And now if I print x plus plus, it works. So now the value of x is 11 after I printed it. I can also do it the other way, plus plus x, and that works. Now if I were to do it this way, it's going to give me an error. Assignment to a constant variable. So I can't change the value assigned to a constant variable. That is the only difference. So which one should you use? I recommend that you choose const as much as you can, because if you use const, then there's no way that someone who is using your code can end up changing it and changing variables that your application depends on if they are not allowed. Only when you explicitly need to change a variable, use let. So with that, we have come to the other part of it, which is us creating arrow functions. This is done. I'm going to delete it all. Now comes arrow. Arrow function basically allows us to create functions in a single line. So if I want to create a function, right? And what that function is supposed to do is it's supposed to print something. So let's say that I'm creating a function. Perform. Okay. And then we have milliseconds, and then we have a callback function, right? This is pretty standard so far. Set timeout. I'm going to simulate a delay for the milliseconds and then execute callback. So handler and then timeout. So callback and then millisecond. Now what will happen is if I call the perform task function, pass in 1000 milliseconds, and I pass in the function, I have to create a new function with all the syntax, and then I have to write console dot log done. Run this, wait for a second, and then everything's done. But I can also do it in one other way, which is I can use arrow functions. Inside arrow functions, I can keep the function body to be the same, and I can remove these things. So now all I have to do is create an arrow. As you can see, I can do it in a single line, run it, and then it's done. So what's happening is I'm just defining the list of parameters that I want. If I have some parameters, I can pass it here as well. But since I don't, I'm not going to be passing it. And then a single line of function, I can do it this way. If, for instance, it's a multiple line function, then I can wrap it in curly braces and do it whatever I want to do with it. As you can see, it still looks more concise than using the whole function syntax. So that's why we use arrow functions. Arrow functions are a more concise way of writing code. Right. Now we move on to classes. So classes are, these are the classes. In old school JavaScript, we had to firstly create a function. Let me call it app. This would be my class. Inside my function, I would console log constructor. So this is the constructor function. And now I have to add things to the prototype. Prototype dot say hello is going to be equal to a function. And that function is going to log hello. Right? So I can create a function. Const object is equals to app. But since it's a class, I have to use new keyword. So I create a new class, which is an object. Now after creating the object, all I have to do is say hello. Now if I run this, first the constructor function gets called, then hello function gets called. Now same thing I can write by using class. The changes I have to make is just class app constructor and instead of doing it this way, all I have to do is wrap all of this, and this should work similarly. Refresh it, as you can see constructor and hello. So everything's working completely fine. This is just syntactic sugar. And now if I want to create subclasses and superclasses, all I have to do is I can just since base app. if I had a class named WhatsApp. I don't, but this is how you would do it. On the other hand, on all school syntax where we used function, we would have to do assigning the prototype, extending the prototype, and there would be a lot of tricky situations. So we don't do that. Finally, we have destructuring, which is one of the newest and one of the most used features. Destructuring, and what it allows us to do. So let's say that I have a variable names A, B, and C. Now I want A to be assigned to a variable named X, B to be assigned to a variable named Y, C to be assigned to a variable named Z. To do this, I would have to then go const X is equals to names of 0, Y is equals to names of 1, and finally Z is equals to names of 2. Now if I console log X, Y, and Z, and I run this, ABC is there. But as you can see, this is just a lot of code for something so simple. So instead what I can do is I can use the destructuring syntax. And now if I run this, it's working just the same. So what's happening is it's saying, okay, this is a variable. The variable at the first index goes in X. Second index goes in Y. Third index goes in Z. If there are other variables as well, they will be ignored. So that's how you can destructure an array. What about objects? So let's say that I have person, right? And they have name as John and country as England. Now, if I want to create two variables named name and country to be assigned with the variables with the keys of names and countries, what I want to do is earlier I would have to create const name is equals to person.name, that, and similarly for country. But here, all I can do is I can just use name, country, and now if I want to log name and country, I can do so quite easily. Fresh, everything's working as expected. That's how you destructure things. These are called syntactic sugars, basically because they just do things in a different way. They're not changing the performance, they're not changing anything underneath the hood. They just allow that with a more convenient way of describing the things that we want the language to perform. So that's why we do that. So with that in mind, let's see what else we have. Now let's take a look at virtual DOM, or VDOM as it's called. Virtual DOM or VDOM is one of the fundamental concepts that React uses to keep the application performing. How does it work and what does it actually mean to use a virtual DOM? So let's take a look at that. In ReactJS, virtual DOM is just an ideal. So it's just an idea or virtual representation of the user interface. So to give you an idea, this is just basically how your DOM should look like. This is just an ideal or a virtual representation of what the UI is supposed to look like. That is kept in memory and synced with the real DOM. So the real DOM is the browser DOM, or the tree structure that we have discussed earlier in module 1. That structure is what it is then mapped onto. The real advantage of using virtual DOM is something that we'll see in a moment, but the real reason why we use a virtual DOM is because the actual DOM is quite expensive to work with. Whenever you make changes to it, there are going to be a lot of changes that you have to make here and there, and that leads to a lot of performance degradation. A good idea of getting over it is to use virtual DOM. In virtual DOMs, what we do is we create inline similar structure, and what we do is we use that structure in order to make sure that what we are doing is taking effect and then mapping those changes over to the real DOM. So a virtual DOM is used to encapsulate things, and it is encapsulated in the ReactDOM packages. So if you've taken a look at the module previously, what that taught us was that React was supposed to be, it's something that is supposed to be used with multiple platforms, ranging from the web to native mobile applications to virtual reality applications. So in order to abstract away all the DOM related functionalities from ReactJS, we use ReactDOM, and the virtual DOM is a concept that has been encapsulated in ReactDOM. so that it can only be used on the web. Virtual DOM is not a concept that gets carried over to React Native or React VR because these are different environments. They don't have the concept of DOM. So React uses virtual DOM to improve performance, as we've heard many times. But the real question is, how does it do it? Well, React uses a virtual DOM as in to improve the performance so that the real DOM is updated only when it's needed and all the necessary updates and the transitions are made in the virtual DOM, which is in memory and it's really fast. This process of updating the real DOM from the virtual DOM is called reconciliation. It's a concept that basically means that once we are done making changes with the React DOM, we try and figure out what are the changes that need to be persisted to the actual DOM, what is the current state of the actual DOM, and how are we going to do those changes. So for instance, if I have 3 nodes in my actual DOM and 3 nodes in my virtual DOM, and only one of those nodes in my virtual DOM change, we'll go and look through all the DOM nodes that are available, figure out what are the DOM nodes that have changed, and update those only, so that we do the minimum work required for DOM. That this is mainly because DOM is very expensive. The document object model, it has a lot of issues in itself, which is why we don't like to use simple plain JavaScript. Because if we do use it, then it's going to lead to a lot of problems in terms of performance. And the performance issues really degrade the user experience, which is why React is so popular, because it takes care of managing the performance behind the scenes. So we don't have to worry about how to manage the performance. React will take care of all of that. And the way it does it is using virtual DOM. So you don't have to actually deal with the virtual DOM yourself. React does it itself. But this is a concept that is used throughout the React community, and we have to understand what it actually means and how React does the actual performance optimizations that it needs to. And now that we have done that, let's see what else we have to learn. Now that we have taken a look at virtual DOM, next is we have to understand JSX. JSX is the syntax extension that allows us to use ReactJS much more declaratively and efficiently. So under the hood, React uses the create element method to create a new DOM node that need to be attached to the nodes. So React at the end of the day is creating DOM nodes, but for us to tell React that we want to create a DOM node of this type, we can use plain React, which will involve us writing react.createElement, and inside the function will pass in 3 parameters, and that is going to be really cumbersome. The main reason why React was not really that popular at the beginning was because it was really verbose. So as you can see that it's very difficult to use, especially when we have components nested into each other. So this can make our code really unreadable. So if you have react.createElement calls going from start to end of your code, it's going to make your code really unreadable. It might be fine for smaller applications, for smaller elements when you only have 3 or 4 DOM nodes that you need to add and manipulate. But it could be really difficult for the other parts of the application when you have like multiple applications or multiple DOM nodes interacting with each other, keeping the data in sync with the DOM nodes. It could be really problematic. So to solve this in React, we use a special syntax. That syntax is called JSX. So what JSX allows us to do is that it ultimately compiles to react.createElement calls, but it makes our code easier to read. So underneath the hood, once you've written your code in JSX, you just run your application, and JSX's compiler will take care of everything else. It will take your code, compile it to react.createElement calls, and it will be interpreted by the browser, which in turn will use the React library and build the DOM nodes. Or so that you can build applications much more easily and much more effectively, and you don't have to worry about making the calls that need to be made in order to create DOM nodes. Now, React does not mandate the use of JSX, which is to say that React doesn't need you to use JSX. You can reuse plain React in order to build your applications, and if you choose to do so, that's fine. But do understand that once you use JSX, it makes your code easier to read and understand, and it is thus far the recommended way of doing it, unless they come up with a new way. But so far, this is the recommended way, mainly because it makes your code more readable, more concise, more understandable. So because of these features that React JSX provides, we use JSX throughout our React code. Most of the developers currently using React will use JSX as their primary syntax. In case you wish to use some other syntax, you are more than welcome to, but JSX is by far the most popular way. If you don't want to use JSX, then you would have to use the plain react.createElement calls, which are going to make your code much more unreadable and really not that concise. Could be difficult to parse through a large DOM structure. So that's all about JSX. Now let's see what else we have. Now let's take a look at props is an important concept in React.js. It's one of the two ways through which you can store data for a component. So props stands for properties. Props is the short form of properties, and they are arguments passed to a component by a parent component for it to use. So one of the differences between the other ways of using internal data and props is that props is not internal. This is data that is passed from a parent component. So if I have a component that is rendering other components, I can pass in some data for those components to render. And that's how the data should flow from in a React app from a parent application from a parent component to a child component, and props allow us to do that. Props are read only and should not be modified by a component on its own. So if you have a component that has some data being passed into it via props, you should not modify it. They can only be modified by the parent passing those props. So if you are a parent component that are rendering a few child components and you're passing some data, you have the ability to modify that data. But the component that is receiving that data as props cannot change the data. This is one of the concepts in React in which you cannot change the data that is being passed to you. The reason for that is because if all the components that are being passed the data, some components pass data downstream. So anywhere down the stream, if some component ends up changing some data, then it's very difficult to reason about and it's very difficult to debug. So in order to overcome this, these are the few guidelines that we have to follow in order to make better decisions about the code that we write. And change in prompts from the parent component will lead the child components being updated and re-rendered to the DOM. So if you have some data in your parent component, since that is the only place where you can change it, and that is the only place where you're supposed to change it. When you do change it, it will lead to a re-render, which means updated data will be merged with the current representation in our DOM node, and the reconciliation process will happen, and anything that needs to be updated will be updated in the child components. And nothing in the child components could actually change the props, so that would not lead to a re-render. So this is why when you get something from props, make sure that you know how to change it, and the only way to change it or the access to change these things or the code that needs to change it needs to exist in the parent component. If for instance you have some reason to make your data be changed by your child components, or you need some way to access the code that changes the props in your child component, then you can pass in functions that do the same, and we'll take a look at that in a moment. So that's how you're supposed to do it. Right, so now we're done with props. Let's take a look at what else we have. Now we come to state. State is the other way that we can change data in a component. So props were passed from parents to child component. State is the internal data. So if you have some component that needs to have data that's only localized to itself, and the parent component doesn't know about it, doesn't care about it, and doesn't have access to it, that's state. So let's take a look at it. State is similar to props, but it is private and fully controlled by the components. So if I have a component and it needs some internal data in order to display something, that data is something that needs to be stored as state. If it's something that the component that is rendering my component needs to be able to pass in, for instance, the color of the border or something like that, then that is something that needs to be turned as props. But if it's something like a behavior when the person clicks on the button and I want it to be just one thing, then I use state. So this is where state and props come into play. State holds data that is internal to the component, that is required by the component, and the parent components need not know about it. The state is used by components to determine what is to display on the screen, and has been managed by the component itself, as other components do not have access to the state. As we have discussed earlier, that once we're building a component, we need to be able to understand that that component, if it has a state, that state is not visible to outside components. That's its state only. So that could be passed down to child components as props, but still, so you are the one who is able to manage it. You're the ones who are able to figure out how to manage the data and how to change the data. The other components don't have access to it. So that's why we use that. So what exactly is child components and parent components? We have all taken a look at that. That's just the hierarchy, and that's how we create components. So in React, a component state should not be changed directly. It should be done via a special setter method, because React keeps track of the state. So if you want to change the state, you don't just go and fiddle with the variables and mutate it, which is to change it. So if you have a state that's containing the name of the currently logged in user, if that needs to change, then you don't to just reassign the variable to the new name, what you do is you call a special setter method. Depending on what kind of component it is, usually the method is called set state. So inside set state, you pass in an object. That object contains the key and the value. Key is the variable you want to change, variable is and the value is the value that you want to assign to it. In React, the state is kept as a JavaScript object. So that's how you can do that. In functional components, which we'll take a look at in a moment, we use hooks, and we'll also take a look at that in a moment. So that is a little different from the set state function, but the idea is the same. You have a variable and you have a setter function. The function's only job is to set the data and let React know that something has changed, re-render the thing that needs to be updated, or at least be aware that things have changed, and the next time you re-render, make sure that you change these things. So that's how state works. State are quite the opposite of props, in the sense that you don't have to get it passed from parent components. You derive the data yourself and you take care of the data itself. So those are state and props. Now let's see what else we have. Now let's take a look at lifecycle methods. Lifecycle methods allow us to hook into important events in our React component lifecycle. Let's take a look at what that means and how you can use it to your advantage. React manages the lifecycle of the components. So tasks such as adding or removing the component from the DOM, all of that is taken care of by React. So you just need to declare the component, and when the component is mounted, when the component mounted basically means added to the DOM, when the component is removed from the DOM, all of that is taken care of by React. Now that presents some challenges to us, because there are tasks as web developers that we need to perform when the components are being added and when they're being removed from the HTML page. So some of these tasks may include fetching some data and displaying it to the user. So only after the component is displayed on the screen, then do we want to update the data onto it. If it's not on the screen and we're updating the data, we're wasting time. Also, with that, another issue is that event handling is something that we need to take care of. If we are on a page where a component is mounted and it has an event handler attached to it, once we move away from that component, when that component is removed from the screen, we need to disassociate those event handlers. The reason being that that could cause a memory leak. These are the kind of things that we need to be aware of when we're using React components. And this is why lifecycle methods are such an important aspect. There are many other things that you can do with lifecycle methods, but these are some of the things. Let's take a look at a few lifecycle methods. So to allow developers to execute code during these lifecycles, React provides them with lifecycle methods, which you can override. So these are component did mount, component did update, and component will unmount. There are many other lifecycle methods available, and sadly we can't cover all of them, but these are the most important ones. So the component did mount lifecycle method is something that you can override when you want to execute some code after a component is added to the DOM. So you want to, let's say you want to propagate an event that the component is available on the screen, and so that other components can manipulate it. It could also be that after the component is mounted, you want to make sure that it has a particular style. You can only do that once it's been mounted. Whether or not it's being displayed, that's a completely different thing. Now, this is ideal for when data is fetched and we want to add it to the DOM. So if we have a component such as an unordered list, and we have a lot of list items in our components, and we want to add them to our unordered list, that can only happen when the list is added. So to do that, what we do is create list items. We wait for the component mounted. When the component does mount, we write the code in component did mount, which will get executed. And that's the code that will add all the things into the components, and our code will work just fine. Then comes component did update. This is a lifecycle method that allows developers to execute code after a component gets updated. So these components may get updated due to props or state change. And if that's the case, if the props of your component change and you want to propagate those changes elsewhere depending on the props, then you can use this lifecycle method. You can also do this for state as well. If you want to pass some data down to child components as props, you can use the state components or use state, and that will work just fine as well. And then comes component will unmount. This is a lifecycle method that gets executed before the component is going to be removed from the DOM. So right before the component is going to be removed from the DOM, if a developer wants to execute some code that can be run at that point specifically, then we use component will unmount. This is ideal for removing event listeners from components to stop memory leak. So if you have an event listener attached to all the DOM nodes, of your component, and that component is going to be removed. You want to make sure that all of those event listeners are being removed as well, so that your component don't leak things to memory. And if we have removed it, then the JavaScript garbage collector will execute, take everything away, and we can move on and with a clear of memory. So with that, we have come to the end of lifecycle method. Let's see what else we have. Now let's take a look at components. Components are the building blocks of any React application. We use components to encapsulate our UI logic of a particular element of our web page or web browser's front end. And what we want is for those components to be reusable. But what are they? In React, a UI is built using individual independent pieces called components. These pieces are used to encapsulate logic, markup, and styles, and then they could be reused into other places. The user interface is built as a tree of components that are managed and converted into native DOM elements by React. So what React does is that it allows us to write components that can then be used by other components as well. And for ReactDOM takes care of changing those components from React.createElement calls to the native DOM elements that need to be displayed on the web page. And all of that is taken care of by React. So all we have to do is understand how to create components, how to make data flow through our components, and how we can use those components in order to work with our application's internal data representation. And all of that is then extremely useful. So components allow us to build single, reusable, and isolated piece of UI, which can be used to efficiently render the user interface. If you have components, then you can use those components, use simple components to build complicated user interfaces. Because if you have a form that needs to be displayed on the screen, it is built up of very small components such as the text field, a button to submit the data, a button to reset the data inside the form, and many other things. So that's where you can use components. Components are really useful in that regard. Now in React, there are two types of components which are created: class components and function components. So these have their own distinct advantages and disadvantages. These have their own distinct reasons to be used and not to be used. Just take and understand what they are and how they compare against each other. Now let's take a look at class components. Class components is one of the way we can create components in React. So class components are created by creating classes that we have seen in the previous module, how to create classes in JavaScript using ES6 syntax. And those classes need to be extended using the react.component class. So there's a class named component in the React package, and we need to extend that class and override its render method, which we'll take a look at. The class name will be the same as the name of the component. So if you have created a class with the name of login component, that is going to be the name of the component that is going to be rendered on the screen. So a class component needs to override the render method using JSX to describe the markup of the component. So if you have a component that has a form and you want to display that form, you need to firstly you need to use JSX syntax, or you can use react.createElement as well, but JSX is the preferred way. And inside the render method that you are overriding from the react.component class, we return the JSX. That return JSX will then be compiled to react.createElement, which will then be converted into the real DOM by our React application. So we don't have to do a lot here. We just need to know how to write JSX and how to extend a class and create a component using that class. That's the entire gist of what we have to learn. Now, class components are still supported in React, but it is preferable to use functional components to React boilerplate code. The reason why is because, and we'll take a look at that, but in essence, it allows us to reduce boilerplate code, and React class component has a few problems, and we'll take a look at those in future. But right now, all we have to understand is that there are class components, there are function components. Class components are still supported, and there are reasons to use them, but mostly it's preferred to use functional components, and we'll take a look at that next. So now let's take a look at functional components. Functional components are the second way that you can build a component in ReactJS. So you can declare how a component is supposed to look and function. So let's take a look at that. In a functional component, we create functions instead of a class. So as you can see, functions are something that are taken to that extreme in the React ecosystem when we create a functional component. The reason why we use a function is going to be cleared out in a moment, but since we don't have to use classes, we don't need to use constructors, we don't need to use class properties and all of that. It's simply a function. It's going to be very easy for us to build. That function is supposed to return some JSX to describe the component markup. That JSX may be littered with some function calls here and there, which also can hook into the React ecosystem and allows us to describe what should happen. Now, functional components take props as parameters and have state to keep track of the data to be displayed. It's very similar to the class components, but in class components, we take props in the render function, whereas here we just the component function takes in the props, and we'll take a look at that. That simplifies our code greatly. We don't have to write a lot of this boilerplate code where we write the class, then the class name, then the extends keyword, then react.component, then create a constructor, and binding those functions, and a lot of different tasks need to go right in order for us to create a class component. And functional component is simply a function that can have state, that can have props. Functional components can have a lot of different moving parts put to them as well. So in React, functional components are given preferences as they are less verbose and more maintainable. Now, the reason why functional components are given that preference now and earlier class components were given these preferences because of a new addition to the React ecosystem called hooks. We will take a look at hooks in future, but right now you need to understand that this change in the mental model is because we have introduced a concept of hooks that allows functional components to have state in them and have lifecycle methods in them. Two of the concepts that we have discussed earlier. Before that, what functional components were limited to do was to just take in some props and return some JSX. They were not allowed to have any internal data of themselves, which was a bit difficult and a bit tricky to get around. So we had to rely on class components. But now, since class components are not the only way you can do it, it's much more easier for us to use function components. With that, we have come to the end of functional components. Let's take a look at what else we have. Alright guys, so now let's take a look at class versus functional components. We have two ways of building components. Let's take a closer look as to when to use or what are the criteria you need to consider in order to build class components or functional components. So the first thing is backwards compatibility. If you have a project in React that's using an older version of React and it's not been updated and there's a lot of code that you need to update, then using functional components right at the beginning is going to be really tricky. Since class components have been supported since the beginning and are still supported in React, functional components on the other hand were always supported in React, but they could not hold any state until React version 16.8. So if you want to use functional components in previous versions of React, you need to firstly make sure that functional components can be used the way you want them to use. If you want some state, then it's better that you don't. If it's a really simple component that only needs props and displays the data and then that's it, then you can use React quite easily with that. How comes state and props? So in class components for state, we use setState function, which is something that we get by extending the component in our class. So we get a react.component is extended in our class, and now we get access to the setState function. And for the props, we use parameters passed to the render function. So all of that is useful and all of that is easy to use. But in function, the fundamental difference is that in functional components, we use the state hook. So instead of us having to extend the class and then use this dot set state, all we have to do is use the useState function, which is also called the useState hook. And using the useState hook function, we can create state, which when changed will cause a re-render of the component. This is how you can change the component in React by changing the state variables. Then comes lifecycle methods. Lifecycle methods are useful for class and function components both, but the way you implement them is different. So in class components, you have defined methods that you need to override, and that came with its own set of challenges. For instance, if you had a component that used the same code when the component is mounted and when the component is updated, in situations like this, you would have to use class component, you would have to duplicate some code, which was an issue. In functional components, though, you have other ways of doing this. We have the use effect hook, and the use effect hook allows us to just define the code, and then we can define the variables that the hook needs to watch. And if those variables change, then the effect needs to run again. So that's how we do class components and function components. We'll take a look at that in the demo as well. And then comes verbosity, which is one of the major drawbacks of class components. Class components are extremely verbose. There's a lot of boilerplate code that you need to get over in order to build anything useful. This is why developers prefer using functional components, but so many developers prefer using class components only when they are necessary. So if there are certain functionalities that we want to build that is only available in class components, then only we will use class components. Otherwise, we'd end up using functional components. And this is why we use functional components in React, because they are not very verbose. So functional components are really concise. Hence, they are the preferred way of building components in React applications. instead of classes, right? So now let's take a look at what else we have. Now we have come to prop types. Let's take a look at what prop types are. Prop types allow us to define the shape of the props that our components are expecting. So since props are something that the parents can pass, they can end up passing anything of any data type. Even if we are expecting an email to be of type string, they could pass in a boolean saying true, and we would have to take care of whether or not the props are being passed correctly. That could be a lot of issues. So in situations like this, prop types come to our rescue. Prop types allow us to define the shape of our props and the types and the whether or not a prop is required to be passed in or not. And with that, we'll come to understand, well, how are we going to use those prop types. So using prop types, we can define what is the data type of a particular prop, if it's required, if it's not required, and many other things that we can do. Using prop types, we can then understand how you can use we need to then define the shape of our props, different kinds of props. Props is data type. So if you're expecting a boolean, an integer, a number, or whatever, and then our React.js will take care of validating the props on its own. It'll throw a warning if the props are of incorrect shape and size and incorrect, and they're not following the standards that we have set, and that will cause some issue. So prop types are validated by React automatically. All we have to do is define the shape of the constraints. So React will throw an error or a warning depending on what the prop types library you're using is. React has extracted the prop types into a separate library. So if you want to use prop types in React, you have to import that script, and then it will work. And whether or not props are passed in correctly or not is what's going to determine the throwing of warnings. So we'll use prop types to figure out how to do that. If we're not using prop types, then we have to do the manual plumbing of figuring out what the data type of a particular prop is, whether it was passed or not, whether it's undefined. If it is undefined, then how we're going to use it, so on and so forth. So that's how we use prop types. So now let's take a look at what else we have to do. So now let's take a look at how we can create a React component. We'll take a look at how to create a React component without using JS6, so the plain JavaScript syntax. So let's take a look at that. Now let me just show you the setup that I have. I have an index.html file. It's empty. It doesn't contain any code relating to displaying anything on the screen. As you can see, there's nothing there. Let's just start writing some code. HTML React. Now I need main div tag with the ID of main, and I need these two scripts. So let me just explain what these scripts are. This is the React development version. This is the ReactDOM development version. If you're building for production, you need to change this to production, as you can. But right now, since we're building for development and we want to see the errors and warnings, we want the development version. Now I'll just write the code needed for React in order to show our component. So the component that we have is going to be called greeting. I'm going to use a function to create the component. Right. So for that, I'll have to firstly write function. We'll be using the simple JavaScript syntax in order to write the code. So we need to write greetings, and this is going to return a React component. So it's not taking any parameters. Return React dot create element React dot create element. Inside it, we need to pass three things. Firstly, the kind of element we want. We want an h1. Do we want any attributes to attach to it? No. And what are its children? So we just want a text node which says hello world. Right? Save it. It's done. Now we need to render it to the DOM. So we need to use react.dom dot render. We use the greeting function, which in turn returns the React component we want, and we want to render it inside the element with the ID of app. That is done. I've saved everything. Refresh it, and if I open it up inside the console, as you can see that target container is not a DOM element. That's because .app it's main, and now it's done. As you can see that it's also being shown in our console that download the React dev tools for better experience. Right now we're not using the create React app version, which comes in with a local server. We're just importing it in a file and using it. from there on we can expand, and if we're building applications that are much more complicated, then we can set up create React applications, and we'll take a look at that in future lessons. The reason why we're not doing it is because that's going to be a little complicated and it takes time to set up any application that way. So that's why we're not doing it that way. But if you are doing it that way, then you can take a look at React Dev tools as well. So we have done this. If I go to my code, this is what it looks like. We have a React development version. We have the ReactDOM development version. Using react.create element, we create a h1 tag. As you can see inside the div, nothing's there right now. But if I open up my console, go to elements, and you can do it in your browser as well. It's dynamically added new data. So that's how you can create an element in React. Alright, now let's see what else we have. Alright guys, so now let's take a look at how we can create a React component using JSX. So earlier we had taken a look at how to create a React component without JSX. Now let's see how easier the process is with JSX. So again, I have an index.html page, no code to display anything on the page yet. All I have is the previous setup. Now I need to just add these three scripts. So earlier you'll remember I had two scripts, right now I have three. First is the React development version, second is the ReactDOM development version, and third is the Babel compiler. This is what will compile our JSX code into our JavaScript code. Now for that we need to write the script. Now one thing you have to do when you're displaying using JSX is you have to describe the type of script. Text/Babel. This instructs the browser that whatever I'm about to write in here is not just plain JavaScript. It's something that needs to be compiled using Babel, and Babel will take care of the rest of it. Babel is the compiler that will compile it from JSX to react.create element. Now all I have to do is create a component. So create a functional component because it's going to be easier. I don't need any state right now. And I will do the same thing. As you can see, it looks like I'm writing HTML, but I'm not. And now all I have to do, react.dom.render, and here I have to render it as greeting. As you can see, again, this is the name of my component, greeting, and I have to render it as if it's an HTML page or an HTML component. I can, for instance, instead of doing it this way, I could have just done it this way. This is how you open and close a tag in HTML, same as you can do here. But since I only want to render this component and there are no child components, I can do a self-closing tag. So it opens and closes in one tag only. I don't need to create an opening tag and then a closing tag. Now I need to pass in document.getElement by ID, and it's going to be main. Save it, refresh it. It'll take some time because it's downloading 3 giant files. Take a look at if we have gotten any errors. We have not, and we have a hello world element. As you can see, here it is, hello world. And if I take a look at the code, it's just 3 lines of code. Essentially, it's just 3 lines. Not even 3 lines. It's it's just 3 lines. 3 to 4 lines of code, and it's not really difficult to understand as well what we're doing. We have a greeting component that needs to return this markup. Instead of us having to specify the h1 tag, its attributes and children's in 3 specific stages, all we can do here is just write it as HTML. It'll get compiled to JSX. JSX will compile it to pure JavaScript. And then all we have to do is say, okay, when you compile this, whatever return you get, whatever response you get returned, display that within this element, which is this one. That's how we do that. Now that we are clear on how to use JSX with React, let's just recap what we have learned. Need a basic HTML page, need somewhere to display our code. If I didn't have div main, I could have just written get element by tag name, and here I can just type in body 0, and that will work just fine. 0 would mean, because since we're getting a tag name and we could enter a tag that says p, and p can have many elements on the page such as a paragraph, so we can do it that way. But that's not very useful, so we have this. This is the preferred way, by the way, to have a single div element that contains your entire application. And now we just After creating this, we import all the required libraries, React, ReactDOM, Babel. We describe to our script tag. This is an important bit. You should not forget this. If I remove this and then I run this, my browser will try and interpret it as plain JavaScript and will run into an error. If I refresh this and I see nothing on the screen yet, and it just runs and I get an error. It doesn't understand why do I have a less than symbol in my in my browser. If I change it and then if I refresh it, it works just right. So you have to unfortunately do it this way here. Then we just describe a function that will return this. You can also describe it as a class, which we'll take a look at in a moment, and then we can display it. Now that we have come to an end to the JSX portion of our hands-on, let's take a look at what else we have. Now let's take a look at how we can pass props to a component. We'll create a component and then we'll modify its behavior by passing in some props. So for that, all we have to do is follow along with the previous hands-on. I'll just show you. So I have the same index.html page. It has no code to display anything on the page yet. Everything is just boilerplate HTML, and we have a div tag with the ID of main. We have the React development version. We have the ReactDOM's development version. We have the Babel compiler, and we have a script tag that is going to contain some JSX code. All I have to do now is create a component that we had created earlier, and it's going to have the same code, but I'll show you what I have done differently this time. So and the semicolon is not required in JavaScript, but many developers like to write it. So do I. So inside the React DOM, we now document.getElement by ID. This should all be familiar since we had done it earlier. Not add, it's supposed to be main. So after I've saved it, I'll refresh it. It'll take some time because it's downloading these files, and now we have it. But let's say that I want to, when I'm rendering it, I want to change things. The way I can do this is by changing it here. So if I want to say hello John, I can do hello John, and if I want to say hello Jane, I can do it this way. But that's really cumbersome. I want this to be dynamic. I want this to be able to be changed by the person who's rendering it. So the way I can do it here is by accepting some props. Props. I can call it anything I want, but I like to call it props here. And now if I want to dynamically display anything inside my JSX code, I have to wrap it inside a curly brace like this. As you can see, the syntax has changed, props dot, and I will call it name. I'll save it. So just to recap, all we have done is we have passed in some props. I have hello, and I want to display anything that has the value of the name contains inside our props object. So how do we pass in the value? Basically, when we're rendering the component, all we have to do is pass in name to be equal to, and it's supposed to be a string. So let's say I call it John. Save it, and a very load. Let's hang on for a moment. It's rendering everything. Just take a look at all of it. Since it's downloading the file, and yeah, sounds done. So we have hello John. But you might be wondering, why do you have to use it? I mean, you could have just written hello John and save it, go back, refresh it, and the answer is the same thing, right? What's the reason for using a prop? So the reason why is, let me just show you, because this makes our component dynamic. Now our component is not just limited to John. Let's say that I want to have 3 components, and I'm just going to create them here. Function demo, and this is going to return a div with greeting. And whenever we're returning a component, we can't return 3 components as it is. We need to have them wrapped inside some component. So here we have div. We have John, we have Jane, we have Johnson. Save it, go back, refresh, and we have run into an error because if I go back to my code, oh, demo, demo, and this should work. So we have a demo component that's returning our JS export. It's wrapped inside a div, so this should work. Okay, we've run into an error. Oh, that is because we have to pass in props.name. And now as you can see, we have hello John, hello Jane, hello Johnson. Now, in case you want to use hello John, hello Jane, hello Johnson, and you can even create more of these components by themselves, right, just as an HTML markup, this is the power of props. So I'll just remove it and bring it back to the normal state with greeting name John. And since it's working fine, all I have to do now is just reload it again and see if it's working, and it is. So with that, we've come to the end of props, understanding what props are and how to use them. As you can see, we did not change them anywhere in our code because that's not allowed. Now let's take a look at what else we have to do. Now we'll take a look at using state in a React application in React components. State is local to a component, so we don't need to pass it to a particular component. And we'll take a look at how that works. All right, so let's take a look at that. Again, we have our simple apps setup. We have an index.html file, displays nothing on the screen. The code is quite simple as we had earlier. And now all I have to do is create some state, right? And since we're using a functional component, I can just, don't worry about the syntax right now. We'll take a look at that in a moment. Just understand that this is how you define state. And from here, we have to just return an h1 tag, name being printed, and nothing more. And all I have to do now is render it to screen. So greeting, we don't have to pass in the name. Right, so everything's done. If I open it up and if I refresh it again, as you can see, it's showing John, which was the name. And if you want to make it completely compliant to what we had earlier, hello, save it, refresh it, as this. Now, where does state matter here? Because we were clearly able to do it using props. Well, sometimes what happens is we get some data not from, we don't get the data from external services or external components. We want to get it from our web server. For instance, if it's a user-based application and we're logging in a user, we want to display the username. So for one instance, let me just show you. I'll just simulate a network call instead of getting a network call. Function get user info. This will return a promise that resolves to username being John and age being 28. Right. So now what I can do is at the beginning it's supposed to show nothing, but when I get user info, this will return a promise, and I can use the then function to get the user. And now all I have to do is set name to user dot. As you can see, we're not using age right now, so we don't have to do that, but we could very easily do it. Now, if I refresh it again, as you can see, it says hello John. Now, but this is something that we have gotten from an external component. So if this is something that only my component needs and other components don't, then this my component can get it from the user's internet and make a request to a web server, get the data, pass the response, and then paste it onto the user screen using this syntax. So this is how we do this. Now that we have covered state as well, let's see what else we have. Now let's take a look at how to create a class component. So again, we have our same setup. We have an index.html page. It's not displaying anything. And we have our code. We have a div tag with the ID of main, React, ReactDOM, and Baby. So we're going to create a class component. Now for that, let's take a look at the anatomy of how do you create a class component. You start with the class keyword, then the name of the component. Earlier, we would have, for the ES6 class syntax, we would have to use function, greeting, and do a lot of complicated tasks for something as simple as creating a class, but now you can do it this way. This will extend the React component class, and as you can see that now we have to type in the constructor function because we want some initial state, and it takes in some props. We have to call the super function, pass in the props. This is why the class components are not so preferred over functional components, which we'll take a look at that in a moment. But the reason why is because there's a lot of boilerplate code you have to write. We have written 1, 2, 3, 4 lines of code for not any reason, because these are not the kind of things that you would have to write. They don't have anything pertaining to our business logic. Now let's set up a state. This is something that we would have to do. And I'll write a greeting to be hello. This is something that's going to be internal. I can create a render function. That render function is going to return. And again, because it's a class, I have to use this keyword, greeting. Here, I'll just get the name from props. That's it. So now, if I want to see something happen, I would have to render it to the page. ReactDOM.render greeting. I have to pass in the name to be John. Document get element by ID. Wait. Save this. Refresh it. And it displays everything. But as you can see, that just for a simple component like this that takes one bit of content from state, other bit from prop, and displays it on the screen, we have to write 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. So by creating one component, it was 9 lines of code. That doesn't have in much. It needs something from the state, something from the props, and needs to be displayed here. That's basically all that needs to be done. So that was an issue. And so this is one of the issues with class components. Now let's take a look at what else we have. Alright guys, so now we'll take a look at how to create function components. Earlier we've taken a look at class components, and we saw that although it was relatively easier to do creating class components, but there are a lot of verbosity involved. We had to write a lot of boilerplate code. Let's take a look at how function components can solve that. So again, the same setup. We have an index.html file, displays nothing. Here's the code. Now we'll create the same component, but here we'll be using function. So as we know, it was called greeting. It will accept some props. When we need a greeting and we need a function to set greeting, that needs to be something that we need to use using React. Have to use state inside it. Default value is going to be hello, and now all I have to do is return h1 tag that prints out greeting as well as the name from the props. Yeah. So finally, now all we have to do is just ReactDOM dot render, pass in greeting, pass in name, pass in John as the name, and document dot get element by ID. The element is going to be me. So now as we have this, let's see if this actually works. So we refresh it, and as you can see, everything works correctly. Now, the thing to notice is that we didn't have to write a lot of code. Even from a purely aesthetic point of view, we only had to write 3 to 4 lines of code in order to create a component. There we had 9 lines of code, and to be quite honest, each line of code was really long. we had to write how to get state. For accessing the greeting, we had to write this dot state dot greeting. For accessing name, we had to write this dot props dot name. And for small components, it's fine. But for larger components, these things really do matter because you'll be writing thousands of components. So you'll have to write thousands of 10,000s of more lines of code. And that's really the kind of code that you're writing is something of a problem, because if you're writing more code, that means more code that you need to maintain, more code that you need to manage, and more code that you need to keep in your mind in order to understand what's going on. So this is why functional components are more preferred. So let's take a look at what else we have. Well guys, now we'll take a look at PropTypes. PropTypes is an external library, so we'll firstly have to import it, and then we'll have to make it use with ReactJS. Let's see what the implications of using PropTypes are and how to use them. So again, the same code. This time I'd also like to open up my console. As you can see, nothing's being displayed right now. We are using the Babel transformer in development. Everything's fine. So let's just take a look at that. Here's our code. Firstly, I'll have to import the PropTypes library. This is what the current version is. You can import any other version. And from here on, I have to create components. So I'll create a greeting component that will just return hello in the props name. So function greeting takes in props, returns an h1 tag, which is hello and name. So that's done. We render it to the DOM using ReactDOM. To document.get element per ID. The ID that I want is the main. The name is going to be John. I refresh this. Hello John is being displayed, but there's an issue with this. If I'm someone who has exported this into a library and another person wishes to use it, what they can do, instead of John, they can pass in 5 is a number, and we want it to be a string. It's going to display it nonetheless, that's fine, but still it's a problem. Also, if I type in true, and then I refresh it, nothing's going to be displayed because true and false are not something that is displayed in JSX. So the user has the liberty of passing in something that's completely useless for us. So in order to prevent that, or at least have the developers or people who use this component some idea whether or not they're doing things correctly or not, we can PropTypes. It's equals to, and this is going to be an object that has the name of the prop, which is the name, and it is going to tell us that inside it we want string and it is required. Now if I save it, go back, refresh it, as you can see we're getting a warning. Failed prop type. Invalid prop name is of type boolean supplied to greeting expected string. Another thing that's important is that if the user doesn't pass in a prop, which they are at the liberty of doing, we will again raise an error. And it will say failed prop type, the prop name is marked as required in greeting, but its value is undefined. So as you can see, we have ways of now a lot more control over how our props are being passed into our components. There are other ways as well, such as Flow and TypeScript, but they are a bit advanced. And for smaller applications, prop types are a great way. They check our props at runtime and they make us understand how we can use our props and how we can use props in other libraries. If we don't find it, then we'll have a warning issued in our console. So with that in mind, let's see what else we get. Alright guys, now let's take a look at problems with class components. There are several issues with class components, and that's what led to developers using function components with hooks. Hooks were there to provide function components the same capabilities that class components have. So with that, we will take a look at the problems that class components have. So class components have several issues with them, and we'll discuss them one by one. First one is constructor. So when using class components that uses state, we have to create a constructor that just isn't optional for us anymore. We have to have a constructor function, and in that constructor function there's another bit of functionality that we need to add. That is, we have to call the super method and pass in the props that are passed into the constructor. The issue with all of this is that although this is something that we would have to do on every classes. This is something that takes up a lot of work. We don't want to do all of these things specifically, mainly because when we're using constructor functions, when we're using class components, we have to write this lot of boilerplate code, which we don't intend to write at all. And this leads to really clunky and messy code and a lot of and there needs to be a lot of boilerplate code for us to write. Then comes binding. So if you've ever worked with JavaScript's event system, the problem with event handling in classes is that when you have a class and you create an event handler function inside a class, the value of this keyword inside the class changes. And we'll take a look at that in the demo, but the main problem with that is that if to solve this, we would have to always, after creating a function that's going to be used inside an event, needs to be bound to the current class, and we need to in the constructor write this dot method name equals to this dot method name dot bind, and in the brackets we have to type in this. That's really annoying and that's really cumbersome. We don't want to do that because that takes a lot of time, that takes a lot of effort, and that's not something that's necessary for us. Then comes sharing non-visual logic. So sharing non-visual logic is one of the major reasons why we like to use React, but the problem is that when we have non-visual logic, it would have to use a lot of complicated patterns like higher order components or render props. Don't worry if you don't know about them. It's just a little difficult to get started with it. It's going to be really difficult to understand what this means. So because of this, we have a lot of mental overhead in order to use class components. And finally, there's duplicated lifecycle logic. So in lifecycle methods, if we want to use the same code in different lifecycle methods, what we would have to do is we would have to copy and paste the code. Mainly because this is how classes function. You could extract it to a function, but still that function needs to be copied to multiple places, and that leads to a lot of problems as well. So with that, these are the kind of problems that we reach in class components. Specifically in the lifecycle methods, we would have to duplicate the code between different lifecycle methods, and that's one of the major reasons why React is not in React community. Lifecycle methods and all of this is used using hooks, because functions, these problems are not there. Alright, so now let's take a look at what else we have here. Now let's take a look at what are React hooks. Hooks are, as we have discussed, there to solve the problems of class components and add some new functionalities to functional components. But what are they exactly? Hooks are React's solution to all the problems introduced by class components in building React components. React components were predominantly built using classes, and while classes are quite good for what they do, for building React components, there was a lot of boilerplate code that we had to write. There were a lot of problems with using classes, as we have discussed earlier, and React allows us to use functions instead of classes and allows us to provide these functionalities in them. So before hooks, we can only use functional components if we had no state in or logic in a component. The only bit of logic that a functional component could have was related to the data being passed into it, and based on the data it had to display something. So if I had passed true as a prop, let's say if the prop was passed in to determine whether a user is logged in, all I could do with the functional component is determine whether or not to show the logout button or not show the logout button. That's basically all the things that we could do with React functional components before hooks. Now with hooks, we can create functional components that has state, that has lifecycle methods, as well as we can create our own hook and show non-visual logic. And that allows us to write code that doesn't need to be duplicated. It's all concise, co-located, clearly separated. Everything works completely fine using ReactJS. Now at the core, React hooks are functions provided by React to help it know about the app's internal state and lifecycle, which can be used by functional components. We have a functional component and we want to display something using that functional component. We use React hooks. React hooks are quite popular in that regard. React hooks are used especially for that, so you can use it for that as well. Now React hooks are basically just functions, and we'll take a look at that in a moment, but basically that's why we use React hooks. Now let's take a look at functional components with hooks. So before hooks, functional components were only used for presentational components, which are also called dumb components. The reason why is because these were components that contained no logic. Their only responsibility was to show and hide a particular HTML DOM element on the page. So they didn't have any state. We weren't able to query any data. All we had was some data passed in as props, and that data being displayed using the JSX syntax, and also using that data we could determine whether or not to not display something, and that was it. So anything relating to state, lifecycle, hooks, methods, and none of that was supported by functional components. But with hooks, we have the ability to incorporate state and lifecycle methods in our functional components and reduce the dependence on class components. As we have already discussed, class components are not something that was extremely revered in React world, especially with React developers not particularly liking the verbosity of the class syntax. We had functional components, but they had a certain bit of problem with them as well. So hooks is sort of the React team's way of discussing solving the problems. So using hooks, we can build our React apps more declaratively and more effectively. The reason why hooks are so popular is because they allow us to write code that is easier to use, easier to read, and easier to write, and they are allowing us to create code that is more declarative. So we can just declare what we want our components to look like, and then they will have that. We can declare the state, declare the lifecycle methods, and then we can just declare the markup using JSX syntax, and it will work just fine. All right. So now let's take a look at what else we have to learn. Alright guys, so now let's take a look at some basic hooks. So hooks are a new addition to React and are only available in React from version 16.8 and above. So if you want to use the hooks before that, then that's not possible because previous version of React had no concept of hooks. So make sure that you understand that when you're using React. If you're working with a code base that uses previous versions of React, then either upgrade them to the newer versions and then use hooks, or don't use hooks at all. So there are several hooks available in React, ranging from hooks that allow us to use local state in our component to creating state which can be shared globally among multiple components or at the same level of hierarchy. So state sharing is one of the important concepts, and we'll take a look at that in future modules. But right now, if you want to share state among different modules, you can using some of the hooks that are available. So two of the most common and the most useful hooks that are available are useState and useEffect hook. These are the hooks that are used most commonly because they serve the most basic use case that everyone needs to use, namely creating local state for functional component and using lifecycle methods in local state components. Functional components basically allow us to use these hooks and allow us to create our code. So with that in mind, let's see what else we have to do. Alright guys, so now let's take a look at the useState hook. In React, the useState hook is used in order to enable our functional React components to have internal state, which is managed by React. So in React, useState hook is one of the most basic hooks that is used all the time. So the useState hook allows us to enable our functional React components to have internal state. Before this, we only had functional components to display dumb logicless components. Here we have components that can have internal state, they can have behavior based on the state, and so we can use internal state and then using the useState hook. Now the useState hook is basically a function in the React package. So you import it, and to use it, you need to call the function, pass in some initial value. That initial value will be assigned to a state variable, and what the function returns is an array with two variables. The first one is the state variable, the other one is the function. So an array of size 2 in which the first value is the variable that contains the value, and the second one is the function that allows us to set this variable in future. Now state variable is monitored by React, and it will cause a re-render when it changes. It should be changed by the setter function returned by the useState. The reason why it returns two values is because React needs to take care of where and how these variables are being updated. What the React useState hook does is it gives us a function that will let React know that, okay, I'm changing this variable and the new value for this variable should be this. So you can do it that way. There are many other ways you can do things as well, but React specifically needs you to use the useState hook with the function to change the variable of the state. If you're not using the function, then you might not be able to get the full functionality out of the useState hook, and your components might not re-render when you change the variable offhandedly. So just make sure that you understand that. Right, so let's see what else we have. Alright guys, so now let's take a look at the useEffect hook. So in React, we use the useEffect hook in order to enable our functional React components to have lifecycle methods. So useEffect hooks take in a function. and in an optional array of variables. So it takes in two parameters. The first one is a function, second one is an optional parameter. Now what happens is when we get the use effect hook and we pass in the functions that we want to pass in, when the parameters inside the arrays change, it will cause the use effect hook to rerun. So that's the way you can think about it. So for instance, earlier we used to have use component did mount lifecycle method. Here we can just pass in a function with an empty list of variables and it will just update. And then it will run the first time the component is mounted and then nothing else. For the component did unmount effect, what we had to do is we just have to return another function from the function that we have passed in that will remove everything that we have set up. So every setup logic, every bit of cleanup thing, you can do it inside a use effect hook. And in the variables that are passed inside as an array are just the variables that the React will take care of. So if the variables inside the array that was passed in a use effect hook changes, the function will be re-rendered. So for instance, when the user is selecting some name from a list of names and you want to send a request to a backend server whenever that happens, you can just create a state variable that keeps track of the thing that the user has selected. When that changes, send a request. That's all you have to do. Instead of creating event handlers which then need to be re-rendered and then make sure that when the component is unmounted or removed from the component tree, we can just do it this way. Now, if an empty array is passed as a second argument, the component, the reuse effect hook will run only when the component is added to the screen, just like the component did mount lifecycle method. So that's the reason why we say that use effect hook allow us to share component logic, even if the component is not something that allows us to define different hook methods. Here we can just use the use effect lifecycle hook, and all that allows us to do is that write code that will be executed when the component is mounted, and we can configure this function in a way that it can be run when the component updates, and when the component is removed, we can change it in certain ways. It doesn't allow us to override all the different kinds of lifecycle methods. So if there are certain really niche lifecycle methods, you might be better served using class components. But here it works just fine. So we can use it that way as well. And with that, after taking a look at use state hooks, we also have an optionally we can pass from the function that you have passed into the use effect hook. You can return the function that performs any cleanup necessary, like unregistering any event handlers, etc. So these unregistrations can be done if you were taking care of doing these kinds of things in component did unmount, then you can take care of it here. So there are a lot of lifecycle methods that would have repeated code or logic that doesn't need to be there. So you can do it here as well. And that way everything is co-located and centralized. All right. So now let's take a look at what else we have. All right. Now let's take a look at rules to use hooks in our React apps. So there are certain rules that we must follow when we're using React hooks in our applications. The first rule is to use React app, you need to make all the calls to top levels. So basically what that means is that only call a React hook from the top level of a React functional component. That means that do not call the hooks from inside a loop or a conditional or something like that. So if you have a React component inside it, you can create a hook. But if you have a conditional statement such as if the user is logged in, don't create hooks that way. That will cause a lot of headaches and a lot of issues, and it makes it difficult for React to track the application state. So always make the calls on the top level. When you declare a React component as a function, make sure that the call is only one indentation away from the indentation of your parent function component. The second important rule is calls from React function. So calls to the hooks, it should either come from the React component or the functional component. So if you are doing a custom hook, then the calls can also come from there. But the thing is, when you're calling a React hook, you should only call them inside functions that are being managed by React, because otherwise React will have no idea about how to use those hooks. So for instance, if you're using the useState hook, call that function inside a React component or some function or custom hook that you have created that will be managed by React. So make sure that you're doing these two things and your React hooks will work perfectly fine. If you don't use them the way that we have described, then there could be some issues you run into that are a little difficult to tackle. So make sure that you understand what exactly is it that you're doing. Especially in the React hooks, we need to understand that they need to be top level calls and they need to be called from a function that is being managed by React. Those are the two things that you need to understand. All right, guys. So now let's take a look at some additional hooks. So we have taken a look at use state and use effect, but there are some additional hooks that we can take a look at. We won't be discussing them in depth because though that's not the focus of this module, but we will introduce you to those hooks and what they can do. You can explore them at your own time. The first one is use context. So as you have said that, as we have already seen, that we can have props injected into our components via parent components, and we also can have internal data as state. But what happens if you have some data that you want to be shared across multiple components, and those components are in a component tree at the same level but are very deep? One way you could do it is you can extract the data that you want to share up to a common parent and then pass them down each level until it reaches the desired component. That's fine, but it's really cumbersome, and especially if you have a lot of data that needs to be shared this way, you would have to do a lot of state relocation, which basically means you have to get the data, get it onto a parent component, then pass it down from components that don't actually need it to the component that actually needs it. That is really cumbersome. So in React, a context object is a special object managed by React, which can be used to share data between sibling components or components on the same level of component hierarchy. Or even if they are not on the same components, but they are below a certain parent in a hierarchy, they can still work with that. So this is what context does. Now, the use context hook allows us to use data from context object in our components much more easily. So you would have to create a context, feed in some data, and then render your entire component tree around a context. And you can take a look at that at the documentation, but basically you just use the context.provide component and render everything inside it. Now you have access to the data, and all you have to do is use context.consume, and you can use the use context hook in that regard and just extract the data to the nearest context that matches the one that you have passed in. You can combine multiple contexts, you can render each of them, you can have a lot of different ways of dealing with this data. Problem that context solve is sharing global state. In React, since we only have local state to share data, sharing data between components can be a bit tricky. You would have to look into some advanced event handling patterns, and that makes it really difficult to trace what data is being used and how. So in case of we want to share some data declaratively, using context is the best option. Then comes use ref. When we re-render a component, all the variables declared inside a component will be reset. So they will all be brought back to its original state, and we won't have any persistent storage of them. You could store them in local storage, but local storage might not be available on older browsers, and you just want to store some memory inside the memory, mainly because if the browser's local storage is then let it remain and then we re-upload it, we need to figure out whether or not the local storage has changed. There's a lot of maintenance tasks or maintenance overhead associated with it. The use ref allows us to create object which will be persisted even after the component re-renders and which will persist for the lifetime of the component. Use ref most commonly is used to create reference objects or refs that can allow us to access DOM nodes. You can use the refs if you wish to, but more importantly, the refs is for persisting data across re-renders or reloads, so that even if the component is removed and then updated back, you still have access to the data that was there before the component was reloaded. And then finally, use reducer. So reducer is a concept in state management, and use reducer can be thought of as an advanced version of use state, where you have a lot of data, such as let's say that you are submitting a form and you have a lot of data regarding the person's name, age, password, so on and so forth. And each a user action could lead to a change in state, and you want to make sure that you're keeping it all in one place. Instead of having multiple state variables, you can use a reducer. The job of a reducer is to have some initial state and some actions. These actions are tasks that can be performed on the state. So for instance, if you have a to-do list, the initial state would be an empty list, and actions would be add to do, remove to do, and mark to do as done. These are the three things that you can do with the state, and you can define it inside a switch statement inside a reducer. So basically, all you have to do is you have to define the initial state of your application and a reducer function. It takes in a state and an action and returns new state based on the action performed on the state. So reducer function is just a simple function that takes in the current state and an action and manipulates the state to create new state based on the action. And that's really useful for when you have a lot of state and you want to make sure that you have encapsulated your state and you want to disallow any illegal manipulation to the state. You can do it using reducers. All right, now let's see what else we can do. Now let's take a look at how you can build a custom hook in React.js. So hooks, as we've already seen, are very important. They allow us to use state and lifecycle methods and other properties of class components inside functional components. They essentially make it easy for us to write our entire application using functional components. Now, using functional components is all good, but how you can build your own hooks is the real challenge. Now we can create custom hooks which allow us to perform certain tasks and integrate them in React. We can build these custom hooks by using already available hooks such as useState and useEffect. useState hooks allows us to write code that allows us to introduce state variables, and useEffect hook allows us to use lifecycle methods. Combining these two and many other hooks that are already available, we can create our own hooks. These hooks will encapsulate the logic that we need to perform whenever something happens in our application, and we can use them in our functional components. Alright guys, so now let's take a look at class components and what are the problems associated with class components. Alright, so we have a basic setup. I have an index.html page. Click on it. It's not going to display anything. As you can see, there's nothing there. And I have the simple code that we have been working on. So let me just create a component first, a class component, and then I'll show you the problem. Firstly, I have to extend react.component. Now this being done, now I need to create a constructor function because I want to use state. Now inside the constructor function, I will have some props passed in, which I need to pass into super. Super is the super class's constructor. Alright, and now okay, so I have this state, and now I need to create a render function. Inside the render function, I need to return a button that will display this dot state dot name. Right. So if I open this up, if I refresh this, nothing will happen because I'm not rendered it on the screen. So let's do that. The app I want to render, and I want to render it inside the div with the ID of main. I refresh this again. Now it's showing it me here. But now what I want to show you, first things first, I have to always write this if I want to use state, which is a bit cumbersome. Secondly, I have to manage every time I want to use a state variable, I have to call this dot state dot name instead of being able to just use the name variable, which is a bit difficult because I just want to use this, but I'm going to have to type this entire thing. So after that, another thing I'd like to show you. Let me create a function called handle click, which will be called whenever I click the button, right? And all I want to do is log to the console the value of this. The meaning of what I'm doing will be clear in a moment. So when you want to handle an event, just name it here. And when I have been clicked, I want to call this dot handle click function. Save it, go back to my code, open up the console, refresh it first so that the new code takes charge. And now if I click this button, as you can see, I've gotten errors. Right? Console is not defined. So we remove that error, refresh the page again, and if I press it again, I get another error. Let's just okay. Now I'm getting undefined. So this is the issue with the entire class structure. If I want to access state inside my handle click function, I can't do anything. State, if I save this and if I refresh it, I won't be able to because this is not going to work. Click on it and I have no variable named state. If I type this dot state, if it console dot log that, refresh it, press it again, and I'm going to get an error. Cannot read state of property of undefined. So to solve this, all I would have to do is I would have to go to the constructor function, name the function, and type this bit of code, which seems like a bit of a hack. After saving this, I come back, I refresh this, I click on this. As you can see, it's showing me name and application. So everything's working just fine. The problem though is that if I have more handlers here, let's say it's not just handle click, I want to handle submit as well, and there I want to access state, I always have to bind this to the current this. This basically represents the current object. Now what I have to do is whenever I'm trying to do this, I have to write this dot handle click equals to this dot handle click dot bind this. If I have a new function, let's say that the function is called submit. If I have a form, then handle instead of handle click, it's handle submit, and I have to again remember to come up here. So as you can see that there's a lot of boilerplate code that I have to write. In functions, this would not be the case because there's no this variable to deal with, so it would be fine. Also in functions, you don't need to call the super function because nothing is being inherited, which is why React favors composition over inheritance, but this is one aspect where React has to use inheritance. So as you can see, there are a lot of problems with using classes in React. All right. So these are some of the problems. There are other problems that we have seen, such as sharing non-visual logic and all that. For instance, for lifecycle methods, if I had two methods, let's say component did mount and component did update. Now, if I want, whenever the component is mounted or updated, that is re-rendered, I want to console log done. This is essentially I would have to copy and paste it here, and that would be difficult, right? So I have to just copy and paste some code because I have no way of sharing this code among the methods in the same class. I just and also for sharing non-visual logic, we would have to come up with really complicated and advanced patterns like higher order components or render props. So for solving something simple, you would have to learn these really complicated things that would be really tricky to implement in real life. So with that in mind, now that we have seen the problem with class components, let's see what else we have. Now let's take a look at the use state hook. We'll try and understand how to use the use state hook. So again, we have our basic app. Here it is. So I have made some changes to the application. Now it shows nothing. And here it is. Now let's create an app. First, we'll use function. Create an app. Nothing will happen. And what it will do is it will return an h1 tag that says hello. We want to render it on document.getElementById, which is main, M-A-I-N. Save it, semicolon, save it, push it, and it works. Now, what we want to do now is I want to add some state to it. So earlier in class components, we would have to create a constructor, create some initial state, and so on and so forth. Here, all we have to do to create some state is, and since we are using array destructuring, we'll have two variables. I will create name, set name, react.use state. Initial value is going to be an empty string. Instead of hello, I can just display not state its name. As you can see, I don't have to type this dot state dot name. Everything works fine. Now that I've saved it, go up, refresh, and since it has no value, it has nothing. Now, what I can do is I can wrap this all in a div first of all. The reason why is because all React components need to have a single parent component. And here I'll create an input that will allow me to change the values. So the value of the input is going to be equal to name, and whenever a change appears here, what I want to happen is I want to execute a function in which I call the set name function, and I just pass in e dot target dot world. Right. So now if I open it up once again, refresh it, nothing's there. But if I type in, as you can see, it's updating in real time, keeping my state and my app in sync. So this is what the use state allows us to do. So what's happening is, let's just recap. I want to create an app component that needs to have some state. I use react.useState with some empty string as the initial value. It could be anything, it could be null as well. So here I have name, and I have set here inside name. What I have is I have the type set to text. The value is supposed to be the value of state, which is name. And whenever a change occurs here, I want to create an event handler, which is this. Now, when the change happens, call set name. Inside the set name, we want the value of the current target, which is our input, to be set as the name. So if I type in A, B, C, D, that should be reflected in the name. And I want to display the same as an H1 tag, which is what I'm doing. So with that, we have explored use states. This is how you use the use state hook. It doesn't necessarily have to be a string. You can name it 1, 15, true, or even an object if you want. But for our purposes, a simple string was fine. Alright, so now let's see what else we have. Alright guys, now let's take a look at the second hook. We'll take a look at the use effects hook. So let me just open up a basic setup, an index.html page which displays nothing. And here we have our basic setup. So let me just create an app first. And now that we have created a basic skeleton, let's see if it works. Yep, it works. So now all we have to do is this. So let's try and create an app that updates the value on screen every 1 second, like a timer app, right? So to do that, we need to have some state which keep tracks of the seconds that have passed, seconds, and subsequence is the function. Use state, and it starts with 0. So let me just display seconds. If I refresh it, it should say 0 here, and it works. Now I want to update it every 1 second, right? So to do this, all I have to do is I have to create a hook. So I need to create a react dot use. Instead of use state, I need to use effect inside it, because I want this to be managed by React. Pass in a function. That function will set up a few things and will return the things for cleanup. So here all I have to do is use the set interval function. This takes in two things. Firstly, a handler, and secondly, a timeout. Inside the handler, all I want to do is pass in a function. And what that function does is that it uses the set seconds function, takes in the original seconds, and seconds plus 1. So this is why this function is something that we should use, because if we have multiple functions trying to update the state, this will also synchronize them. Now I don't want to write seconds here, I can just write s, and that will work just fine, right? So this works, but a problem with this is that this will disallow us for cleanup later on. So if I remove this component, this timer will still be running in the background. How do I cause the timer to be gone or garbage collected once the component is removed? Firstly, I need to just save it inside the timer ID. And now all I have to do is prop my hook. I need to return a function. That function will clear up, clear interval, and the timer ID is what I'm passing. So what React will do is when this component is being shown, it will set this event handler and update it every 1 second. Once that update is done and we are removing the component, this ID will be cleared and we have successfully removed everything from the screen. So if I go back and if I refresh this, as you can see, it's running really fast. That's because we have to set the timer to be 1000 seconds. Refresh this. And now every second it's updating. 1, 2, 3, 4, 5, etc. But another problem is that when you're using React Hook, you just want to do this when the component mounts and don't want to add this again and again. Pass in a dependency array. This shows that whenever something changes, I want to display something. So if I had some user variable that was going to strike up this effect, I can just write it here. So when the user variable changes, this would affect it, but right now nothing should affect my timer, so it's working just fine. That's how you do it. If you refresh it again, it's going to work just fine. See, 1, 2, and there you have it. So every second it's being displayed and it's being rendered, and we don't have to do anything. All right. So now let's take a look at what else we have. Alright guys, so now we'll take a look at how we can build our own custom hooks. So custom hooks, as we have discussed, can be built using use state and use effect and other hooks that are already available in the React library or other hooks that we have built. So let's take a look at this. So this is the web page that we have been working on. I've again removed the code that doesn't need to be there. And I'll just create an app that will return an H1. Right now it's going to be displaying 0 just to see if everything's working correctly. Save it, go back, refresh it, and it's displaying everything correctly. Now let's build a hook that will allow us to add intervals to our application. So I'll just create a hook. Although it's not necessary for us, but usually it's considered good practice to prefix your hooks with the word use. So I'm going to use interval. Now what I want to do is I want to create some state. Seconds, answer seconds will be using use state, which begins at 0, and we want to add an effect as well. And inside the interval, set seconds, in which we take seconds and increment it by 1, and finally we pass in 1000. And now we need to return the ID. So we need to return a function that will clear the ID. Right, so everything's working fine now. And so it's working fine. Let's see if we have run into some errors so far. We've not attached the hooks back. So nothing's an error has been thrown. No error has been thrown. All I have to do now is use interval function. And what I want is I want access to this. So this is what I want to display. Right? So I've gotten the access. If I refresh it, and now as you can see that this is working. So what is the benefit of using the use state hook? Well, what this allows us to do now is we have created our own hook and we can change a few things, like we can pass in some arguments. We want, let's say, initial time and increment. So now I can modify it just here. So the initial time, instead of starting at 0 second, I want it to start at 15, right? So now I can just change it here, save it, go back, and now it's 45. I refresh it, it starts at 15, right? So I have added a bit of change there. And another thing I can change is change the increment. So instead of it being incremented by 1 second, if I wanted to increment every 100 milliseconds, I can just pass in 100, pass in the increment, press it, and now it's working defined, right? Now, if I don't want to pass these things, what I can do is I can just use, if the initial is available, then fine, else it's 0. If increment is available, then fine, otherwise it's 1000, right? So if I want to remove this, refresh it. Okay. Oh, So I might have to pass in some, instead of this, I can just do it this way as well, or I can just make some checks, but that's fine. Or I can just pass in some default values. Initial is supposed to be 0, and increment is supposed to be 1000. That's it. Okay, so I refresh it again. There you go. It's working fine. And another thing I can do is I can just go first, second, and we'll do it that way as well. For use initial interval, here I passed nothing, and here I can just type in initial to be, I can just pass in initial to be, let's say initial is supposed to be 5. So now I can just pass in a div, and inside the div I can just paste it this way. Instead of first and second, I'll just remove these, come back, refresh. Now again I've run into an error. Seconds is not defined. Okay, so I have to pass it second, refresh it again, and as you can see, both of them are working and they both have their own internal state. So this is why we create custom hooks. Alright, so we'll see what else we can do now. Alright guys, so now let's take a look at forms in HTML. We'll try and understand what are forms in HTML and why are they necessary for us to use in HTML. What are the main use cases and how we can use them in HTML. So forms are an essential part of HTML as they are used to collect information from the users. So if you're trying to build a form in HTML, the main intent of creating a form is to collect information from users. That information could be of several ways, of several parts, or for several use cases. So for instance, you could take information from the user to authenticate themselves, such as username, password, or email or password, or however we choose to do though. And then you could also take information from the users about any particular grievances they might have, any service request if you are providing a service-based application, or any other thing that you want. The main intent of creating a form in HTML is to get information from the users. Now, forms are important because they are the most intuitive way that user can interact and enter data into our application. If you have a form in HTML, the user immediately knows what to do, how to fill out the information, how to get the information from the user. If it's not a form, if it's some archaic way of getting information by clicking around and doing stuff, it might be a little difficult. Forms are also translated in real world. We have forms, so it's easier for us to understand how to use those in the digital world as well. Now, forms in HTML have several tags, such as form, input, label, button. They also have attributes, and all of those combine to build our own form. The reason for having so many tags is because a form has several elements. A form is really just like a mini component. We have forms, we have input labels, and we also have input fields. So the input fields allow us to create boxes in which we can get information. For instance, if you want information in forms of text, then we can do that. If you want information in form of password, we can do that. So when the user enters information in text, it will be displayed. When the user information enters information in password, it will only display dots so that the user can't see what's going on. And there are several other things as well. There are labels which allow us to define what a particular input is expecting. If you only have an input and no label, then the user might not have any idea what to put in that. It could be that you have three fields. First of all, the field is supposed to capture users email ID. The second field is supposed to capture users username, and the third one is supposed to capture the password. If you don't have a label, then the user might not understand. This is one of the important reasons why we have to understand form design and how you can create forms that are intuitive and easy to use. There are buttons as well. Buttons allow us to define certain actions, such as if you want to reset, you can create buttons as well. There are certain input types that correspond to a button as well, so you can take a look at those. There are checkboxes, there are radio buttons, there are radio groups, checkbox groups, there are drop down menus. There are a lot of different ways you can capture information, and depending on what it is that you're trying to capture, there could be several ways of doing that. Finally, each component in a form has its own attributes which modify how it looks and how it works. So for instance, if you have a form, you can submit it to a particular URL by pointing it to that URL in the action attribute. You also have method attribute which describes how you want to submit the form, whether you want to submit it via get or post. A GET request is simply a request that will be encoded into a URL and sent to a web server. So all the information that is not very sensitive will be encoded in the URL and will be sent to the user. Now the thing is, do not use GET request if you have some sensitive information like the username and password, because this will be displayed in the web browser's history. It will be captured in the URL. Anyone can just look at the URL and see what the username and the password of a particular user is. For that we use post request. Post requests are just basically requests that are not displayed to the user. They are sent behind the scenes. The web server will capture that request, will do whatever it needs to do, and then return a response on how the request processing worked. So these are several ways that you can use forms in HTML. The reason why we didn't discuss much of the code is because the forms are very simple and you are expected to know those. Forms are really easy to implement in HTML, but the problem is when your forms start getting complicated, you need to keep track of a lot of variables, you need to keep track of a lot of things that could be really difficult for you to get started with. Keeping that in mind, React.js has its own ways of handling forms, which we'll take a look at. Alright guys, so now in this module we'll take a look at creating a form in React.js. So how can you create a form in React.js? We've already taken a look at the different tags and attributes that are needed to create forms in HTML. Why do we create forms in HTML and all of that? So how you can create forms in React.js. But just like HTML, React.js can also be used to create forms which can capture users' inputs. So if you're trying to create a form, HTML and React.js are both good options for that. Although React.js does things a little differently, which we'll see in a moment. HTML is purely markup. So if you want to just display some things on the user and imperatively handle form submission by extracting information out of the form fields, validating them, sending them to the server, receiving the response, and then acting accordingly whether the response was successful or not, then you don't need to use React.js. But if you want to build a React applications in which your user interface is a product of your internal data, if you want to maintain and keep track of the data that the user is entering and how you are going to submit it and all of that, then React.js is a really good candidate. So with React.js, we can have forms that can manage their own internal state and keep them in sync with user interface. As we've already seen, one of the major strengths of React.js is that it allows us to create encapsulated standalone components. So if we can create a form component that keeps track of all the data that's inside it and keeps track of all the data that it needs to keep track of, and also keeps track of events like form submission, data changes, updating the data, and when the time comes to submit the data, you can do it on your own. So this is why React.js is so good for forms. In React.js, there are several ways of using forms, which we'll take a look at in a moment. The most prominent way is when we use data to be kept track of, and React will take care of keeping track of data. We'll just define some state variables. Our form will then be displaying those state variables, and any user input will change that data, and that will be displayed in the form as well. So these forms handle validation errors as well as asynchronous form submission. So if you are building a form in any modern application, especially in a JavaScript rich application such as React, using forms and validation errors are really useful. So for instance, if you have a form that you want user to be able to submit, but there are certain constraints that you want to put on it, such as the user cannot enter numbers in some cases. In some cases, the user cannot enter it cannot enter anything other than an email. It should be formatted as an email, as an example @domain.com, and that way it should work. And if the user fails to do so, then it should create some errors and display them on the screen. How do you go about doing that? That's where React.js takes care of all of this. And also it allows us to perform asynchronous submissions. Since we are keeping track of the data, creating asynchronous submissions is really easy. Asynchronous submissions, for those of you who are unaware, is basically just getting all the information from the user and submitting it to the server and waiting and getting back the response without freezing up the user interface. So asynchronous basically means in the context of a web application, non-blocking. If you're trying to create a form, submit something, everything is submitted to the user and you get the response back without you having to then wait for the response to come back. That's the way asynchronous communications work. Now, there are two ways of creating and managing a form component in React.js. It's controlled components and uncontrolled components. Both of them have different ways of keeping track of the data that is being displayed, how they do it, how you create some data, and how you are going to do that. All of that is taken care of by React.js. So we'll take a look at how React.js uses those. They both use different methodologies for keeping track of the data and how to extract data, how to validate it. All of that we'll take a look at now. Alright guys, now let's take a look at controlled components. Controlled components is one of the ways that we can create React.js forms. We can create forms in React.js using controlled components and uncontrolled components. Let's take a look at controlled components first. So in React.js, a controlled component is an element that contains the data that is handled by the state within the component. So when we have some form that needs to have some data submitted by the user, what we can do is we can use state in React.js. State, as we remember, is the internal application data that a component needs to have, or local state as we could call it. So in this example, we'll be taking a look at local state. So in controlled components, what we do is for each field we define a local state variable and have it manage and keep track of data inside a form field. So for instance, if we have three fields such as username, password, and after username and password, if there's another field such as confirm password, then we can keep track of all of those three fields using three state variables. And as the user changes those fields, we can change them using event handlers. Now, in other words, a component that contains data that is managed and controlled by its internal state is called controlled component. Internal state could also be called local state in this example. So a component that contains data that is managed and controlled by its internal state is called controlled component. So to give you an example, imagine that you have two forms. Both of them have their own internal state and internal variables, and both of them are keeping track and managing the data that is being submitted by the user using state variables. Now, these state variables are internal. Both of them cannot access state variables of each other. Both of them are completely encapsulated, so they are both controlled components. So controlled components are useful when you want to create data that is controlled by state variables, and you want everything to be managed by React. All you want to do is to wire up state variables and event handlers, and now React will keep track of everything. When the user changes some input, each data will be tracked, and when the user submits, that tracked data is going to be submitted, and if you want to validate it, you can do it yourself. So control component is especially useful when building a form, as each form element can contain its own internal state, which can be managed by React.js. If, for instance, a form element is a little complicated, like for instance a date picker, then you can create a component for that itself. And if it's not really complicated, then what you can do is you can just create a React.js application in which you can have a form component. Inside it you have normal form fields, and all of those have values that are associated with the state variable, which is managed by React. When the user changes data in those state variables, that data will be changed inside the state variables as well, and those state variables are what are going to be submitted to the user. In case you're using form components or functional components, then it's the use state hook that we're going to use to create state variables. If you're using class components, then we are going to be using the state property of any class component. Although forms are really easy to implement and functional components are the norm nowadays, many older libraries and older code bases still have forms that are written in classes, so you need to understand both of those. So in a controlled component, the state acts as a single source of truth. Now, what that basically means is that data flows in a unidirectional form in just one direction. So it can only be updated one way. One way to think about it is if you have some user input, that will create an event when you change some data, and that event will end up updating the data. There is no other way that you can change the data, and so since there is only one way that the data can change and will change, that means that the data at the end of every updation, every mutation, will be kept intact in the state. If you want to keep each of the changes as well as a history of form changes, you can do that as well. The reason why it's called the single source of truth is because at the end of the day, there is only one place where the data is stored. There is only one way that it can be changed. So we know what happened to the data that it got changed from previous state to the next state. And the single source of truth means since the data is not stored anywhere else, we don't need to update it anywhere else. We don't need to make sure that it's in sync with any other place. Data is only stored in one place, which is the state, and that state is then reflected by our form. Alright, so now let's see what else we have to do. Alright guys, so now let's take a look at how we can create controlled components. So in order to create controlled components, firstly we need to go back. Let me just show you the initial setup. We only have index.html page. We open it up. It displays nothing at the moment. This is because we have not created anything to be displayed on the screen. We will now create a form component that will have username and password, which will be managed by React internally as a controlled component. And we have the code that we want to show. So this is what the code looks like right now. Let us explain it from top to bottom. We have a doc type that basically explains to us that this is an HTML document, HTML5 document to be exact. The language is set to be English. We have a head tag that contains all the meta information and all the configuration about our HTML page. Its character set is UTF-8. It has a viewport with the initial scale set to 1 so that it's a little bit responsive and scales according to the device width that's available. We have a title, model for controlled component. In case you're wondering where does this show up, it's right here, as you can see. Now let's go back. We close the head tag. We have a body tag inside which we have an ID of app, a div with an ID of app. This is important because this is exactly where we'll be building our application. Now you can, for instance, just attach it inside body, but it is recommended that you keep your React applications in a DOM setting isolated. So in our case, we're keeping it isolated by keeping the our application to be embedded inside a div tag with the ID of app. It's not necessarily the case that you call it app. You can call it anything. You can call it my app or application or anything. App is just a standard that we use. We have script references for React's development version. The development version is being used so that we can get a look at the errors and warnings that are being displayed. If it's not the development version, if it's the production version, then only serious errors will be displayed and warnings will be ignored. In our case, we want the warnings since we are developing the application right now. We then use the ReactDOM. So since ReactJS is a platform that can be used on multiple things such as mobile applications, VR applications, and web applications, and we are trying to build web applications, we will be using the ReactDOM library to make React understand that we want it to be able to work with the DOM libraries. Finally, we have the Babel compiler. What it will do, it will take a look at our JSX code and transpile it to plain JavaScript. So in order for us to explain to Babel that the code that we're about to write is JSX and we want you to convert it, we have to create a script tag with the type as text/Babel. If you're using plain JavaScript components or you're using components without JSX, then you don't need to do this. You can just skip it. But if you don't, then our browser as well as Babel will take a look at it and think of it as being some script tag that contains JavaScript. It will take a look at the angle brackets, it will get confused, it will consider it as being a comparison operator, and it will throw an error. Make sure that you have written this all out. These script references are things that you can get from the React documentation, or you can search on the internet as well. Now let's start building our form. First thing we have to do is we have to create a component. We'll be creating a functional component. So I will write function. Now the name of the component is going to be form, F-O-R-M, and right now let's just return an h1 tag that says form. Just to make sure that everything is working, I will use react.dom.render. Render is a function on the React DOM object. Inside it, it takes two things: the component that we want to display, which is the form component, FORM, and where do you want to display it. So in our case, we want to display it on document dot get element by ID. The element that has the ID of app is the one that we're interested in. So I save this. Make sure that you save the changes that you make on the applications. If you don't save the changes, then the changes that you have made so far will be lost. We go back to the browser. Since the changes are saved, when we refresh our browser, it will pick up all the changes. Let me just refresh it. And it's displaying the form. So we know that everything is wired up correctly. We have created the dependencies ourselves. In the console, you can take a look at some information. If you want to use React Dev tools, you can download it from here. And it gives you a warning that says you are using an in-browser Babel transformer. Be sure to pre-compile the scripts for production. So if you're trying to build a production-ready application, then everything that you write in JSX must be pre-compiled to JavaScript so that this additional compilation step doesn't slow down your application every time the user accesses. So it's only a concern if you're trying to build production. Right now we're just learning, so it's not really something that you need to worry about. So don't worry about this point. Now we will create our actual form. So since we need the username and password, first we have to create state variables. Since it is a controlled component, I want username, and a function that we will be using is setUsername. Now we use react dot use state. This is a use state hook call. Inside it we can pass in some default value. I'm passing in an empty string so that it doesn't resort to null and cause any unexpected behavior. Save this. Again, we need password, so password, and the function for setting the state variable is setPassword. And again, we have the same empty variables. Both of them are strings, mainly because we don't want empty variables to contain anything other than empty strings, such as variables such as undefined, null. These could lead to a lot of errors in the future. Now it's time for us to create the markup. Now since the markup is going to be multi-lined, I have to wrap it inside parentheses. So we create a form right up front. We have to add a few event listeners, which we will in a moment. And now let's add two input fields. Input of type text would be fine, and the second input would be input of type password. Right. Now if I save this and if I go back, we will see a few issues with this. So all we have is two empty boxes. Firstly, we don't know what to type in here, and secondly, we have no way of submitting the data. So to overcome this, what we can do is, after going here, we can add placeholder. Placeholder is basically that gray text that is displayed behind the input field, which I'll show you in a moment. Enter username. If I save this, remember password doesn't have a placeholder text, but username does. As you can see, this gray text is being shown. If I click here and type something, that placeholder will disappear. If I remove that, placeholder comes back. This is inbuilt in any browser that you use. Similarly, to give users some indication of whether we want username or password, I'm going to enter password. Again, I save this. Always make sure that the changes that you have made are being displayed on the screen. Otherwise, you could make 15 changes and then come back and none of those work. And then you have to go through all the changes and understand what went wrong. And now we need a button to submit the form. There are two ways of doing this. One, you can just create a button, but in forms, there's a more intuitive way. And you can, this is how you do it. Or you can also call it login. The value here is what's going to be displayed on the button. Let me just show you. So I open up, refresh. As you can see, it's saying login. Had I not given it a value, it would show submit or any default text that is configured for a browser. For Firefox, the default text is submit query. For Chrome, it's default to submit. But since we don't want to take any chances and have cross-browser issues, we just give it a label of login. So everything's working fine. We have the input fields, but right now our state and input fields are not connected. So let's take care of that. First thing we have to do is let's just add a few breaking lines, or line breaks as you would call them, in our form component, so that each thing is displayed on a separate line. Okay, that's better. Now let us connect our form components with the usernames and passwords. First things first, I want its value to be equal to whatever the value of username is. So here we are connecting username and we are connecting password. As we remember, both of them were empty strings, so it won't cause any issues. If I run this, we run into an error that says you have provided value prop to a form field without onChange handler. This is expected and we'll take the care of that in a moment. What this is saying is that this is just some static value. There is no way for us to change it. So if I focus on a particular input, if I type something, as you can see, nothing is being changed. React automatically takes care of this and warns us because sometimes we may forget. So it tells us that if particular form field has a value prop that has been set without an onChange handler. So let's do that. Again, in React, basically we use events to manipulate state. We get the event, and now what we want to do is we want to set the username. And username has to be e.target, which is the DOM element dot value. If I save this, we go back, we will still get an error because password is the field that is not that does not have an onChange handler, but username I can change, and it is being kept in sync with the internal state variable. Password I cannot change right now, so let's fix that as well. As you can see, the lines are getting a little big for our screen to hold, so you could either scroll them, or what I like to do is drop them on individual lines. They are easier for me to read and I can see what's going on. So this is done. Let's do the same thing for passwords. As we did to our username, I have to type in onChange. This is done. Make it equal to something. This is going to be our event handler. I take the event. When we get the event, I want to set the password. Since this is the password field, I want to do the same thing, event.target.value. Now both of these things are being displayed and being kept in sync with the data. If I refresh this, hopefully there will be no errors. And as you can see, there are no errors. This DOM content loaded handler to 252 milliseconds is just an error because we are loading the entire libraries of React, ReactDOM, and the Babel compiler. That takes a little bit of time since we're doing it over the internet. So this takes a bit of time, and sometimes that time gets over 200 milliseconds or something. So that will cause some violations because it's not a very performant way of doing things. But since we're in development environment, it is fine. Now, if I type username, it works. And since we are not getting any errors, if I type password, it works as well. And as you can see, the password is protected. I can't see what I've typed here. Now comes time for form submission. This is the tricky bit because if I submit the form right now, things are not going to work the way I want them to. What if I want to just log it to the console? But if I log in, as you can see, it creates a full user request, which we do not want. So what it does is that it takes the passwords, it takes the username, and then it submits to the user. It submits it to somewhere. It submits it to the original HTML header. We don't want that. We want to log it to the console. So we want to remove the default behavior of submitting the data to the default URL. One way of doing this is when we go to form, there is an event called onSubmit. Again, we will use event and e.prevent default. Now if I save this, if I go back, refresh, new changes will be picked up. Type in the username, type in password, click on login, and as you can see, now it's not submitting. So now we have forbidden our form to submit, making it entire submit request. Now we have to create a handler. The job of the handler is to take the input data and then process it. It could be that you submit it to the server or something else. So I will call the function handle submit because it will contain considerably lot more code, and I don't want to display all of that. I don't want to call all of that inline. I can create a separate function for it so that it's easier to understand. So function handle submit, which will take in an event parameter since it's an event handler. We have to do the same thing, which is event.prevent default. Now that is done, if I save this and I check it again, it will be the same thing. So password, and I click on submit, it's not submitting. So it's working fine. Now When the data is submitted, we want to log it to the console. So there are several ways. The way I like to do it is username. It will print out the current username. Like I said, submit, and we get an error. Console is not a function. Oh, sorry. I have to type console.log. A mistake. Save this again. Refresh it. Type in save, and it says username is this. Now this is fine. Another way I could do this is by using template strings, in which I can just define a template variable using dollar and curly braces. And now as you can see, it's interpolated in the string, so I can just write username and it's showing the same thing. But what if I want not just the username but also the password? Well, I do the same thing. Password is going to be the same interpolated string. I save this, I refresh this. This is what is being shown, and if I submit it, as you can see, password is being shown here, username is being shown here. It's not necessarily the case that you just type in the username and password. For instance, what you can do is you can open up the case, and instead of doing it this way, what you can do is you can create a request object that has both username and password. Now if I log into the console, it will be a JavaScript object. So if I, as you can see, it's showing ASDFS, which is because I'm showing the username. I need to show the request. Save this again, refresh, type in the username, type in the password, login, and it's a JavaScript object. This is something that I can send over the internet to a web browser or a web server, and this will give me some information. So if I have some information that I want to be displayed to a web browser, what I can do is I can use the fetch method. Inside the fetch method, the first thing I have to do is show the, I have to give it the URL on which I want to submit. So let's say it's http example.com/. Here I will submit it, and I can pass in some options such as method being equal to post, and data or body being equal to my request that I have just created, and I can send it, and then when the response comes back, I can just handle this here. But since we don't have a server and we don't want to concern ourselves with it, we are not going to do that. So this was just an introduction to how you can create a form and handle it. Let's just recap what we have done so far so that everything is clear. Basically, we have created a form component, and we are on the application by attaching it to the element with the ID of app. Now, after that, we create two state variables for handling username and password. If we had multiple fields, then we will create multiple state variables, and we create a form on which we have a submission handler. What it does is that it prevents the default behavior of submitting information to the default URL, but instead of that, what we do is we create a request variable and we can log it to the console. Now we have an input with the type of text and a placeholder of enter username. Value is there. We want, when the username changes, we want the state variable to change as well, so we call the set username function, passing in the new value. We do the same thing for password, and the type is password because we don't want the users to be able to see what the user is typing in the password field. We make the value to be password. When the user changes it, we want this to be this password field to update our state variable. And when the user submits it, we want the submit action to go over. Then the onSubmit method is called. We prevent the default behavior. We create the request object and we log it to the console. Any other thing that you want to do when the user submits the form, you can do it here as well. As you can see, if I refresh it and I do it once more, as you can see, I have the output here. So with that, let's take a look at what else we can do. Now let's take a look at uncontrolled components. Uncontrolled components are the second way that you can create and manage forms in ReactJS. First one was controlled components. So in ReactJS, controlled components didn't act much like traditional HTML elements. we had to create state variables. It's more akin to how you use React. React actively discourages you to access underlying HTML elements and then manipulate them or access them, mainly because it is all taken care of by React. So if you make some changes that React didn't desire, then there could be a lot of issues. On the other hand, uncontrolled components act more like traditional HTML elements, so they're quite opposite to what controlled components do. In control components, we hand back all the control to React. We just wire everything up so that React takes care of everything behind the scenes. In uncontrolled components, we try to access the internal HTML elements so it's more familiar to people who use them. In uncontrolled components, we get access to the underlying DOM elements and we query their data instead of maintaining the state. So instead of us having to define multiple state variables, we just get access to the HTML elements or the input elements, or you can call them the DOM elements, and use data that is stored inside them at any point in time. So when the user clicks submit, the data that is stored inside these variables will be the ones that we access. It's more akin to how we use forms in actual real HTML code, where we create HTML inputs, assign them IDs, and then get those IDs using JavaScript. Then using the JavaScript we get, after getting the IDs, we get all the data from it by querying the DOM. Then we do whatever we can while validating and submitting the data. To get access to the underlying HTML components, we make extensive use of refs. So refs are ReactJS's way of allowing you to get access to an internal DOM element, which we'll take a look at in a moment. This allows us to get access to the DOM element that a ReactJS is managing, and using that we can simply get the data from the referenced element at any point of time, and then we can act with that data, or we can process the request using the data that is contained within the underlying components. Although uncontrolled components are easier to understand because they resemble more to the HTML way of doing things than React way of doing things, and if you have understood HTML, then you would think that React is easier to understand. They should only be used in special cases where you need to manipulate the underlying DOM elements. So one of the ways that you can do that is when you are trying to get focus to be on a particular DOM element. So to give you an example, if you have some input that when you submit the form, you want that input to be selected and whatever the user types should go back to that input, then you can use refs for that. There could be other ways of doing that as well, but refs are really good for that. But they are actively discouraged, mainly because refs access the underlying DOM elements, and that's one of the fundamental reasons what React discourages you to do. Do not access DOM elements when you don't need to. You can, but then React is not able to manage this. So now let's take a look at what else we can do. Alright guys, now we'll have a hands-on on uncontrolled components. So let's take a look at what we're going to do. Before we begin, let's take a look at the initial setup that we have. So we have an index.html page. If I open it, it's completely blank. There's nothing on it as of now. And the code here is simple. All we have is just a basic HTML page. And now we're going to start to create a form component. But this form component is going to be created using uncontrolled components. Now, as we have already discussed, uncontrolled components make use of refs to get access to the internal or the underlying DOM elements, and using those DOM elements we will get the data that we need, and then we will process it the way we wish to. So if we take a look at from the top, the HTML page is quite simple. There's nothing unique about it. There's just a doc type telling us that it's an HTML5 page. Language is set to English. Head, inside the head we have the character set, the viewport for responsive design if we wish to use it, and then we have a title which again shows up here, as you can see, on the title of the browser. Different browsers implement this feature differently. Then we close the head tag, open up the body tag. We have a div with the ID of app. This is where our application will live. We have a development version of React, development version of ReactDOM, and a Babel transpiler, and a script tag that uses text/Babel. All this is that these are the two libraries that we will use in order to write code that ReactJS can understand, and ReactJS You then transform it into DOM elements and then attach it to the DOM. On the other hand, this script tag, it contains a link to the variable compiler, which will scan through your page, look at any script tag that has the type set as text/variable, take a look at the JSX code, and transpile it into JavaScript code so that the browser can understand it. So now what we have to do is we have to create a form component. We'll be creating a function component. So I will just write function. Name of the function is going to be form, F-O-R-M. It doesn't require any props as of now, so I'm not going to be expecting any props. But if you want to accept props, this can be done inside the function's arguments. But since we don't need it, I'm not going to do anything about it. Now let's just check if everything is working so that we can move forward. Save it. Now it's not going to display anything on the page as of yet. If I refresh this again, as you can see, nothing is being displayed because we have not attached it to the DOM. For that, we use ReactDOM .render. Render takes in two arguments. First is the component markup. So we want to display a form. This is a self-closing tag, so we can also do it this way. But since and also it's form, not from. Yeah. But since this is just something that we have to do and it's only a single tag, we're not nesting anything inside it, so we don't have to do anything here. And second, the DOM element in which we want to attach this React component into. So use the get element by ID function. This element will accept an app parameter. I save it, go back to the browser, then I refresh this, and you can see the form being shown there. Now, one thing I can do is instead of returning the form, I can firstly return an entire form. But since this is going to be a since this is going to be a multi-line HTML or JSX code, I can wrap it inside a parenthesis. So we take in the form, close the form. Right now we're not doing anything. So again, I'm going to be building the same form that I had built over the previous hands-on. In case you have not watched the previous hands-on, don't worry. All we are trying to do here is create a login form in which we have an input for username, an input for password, and a button to submit the form. We'll learn more about what we're trying to do as we progress, but that's the basic outline of what we're trying to build. So first thing I have to do is I have to open up an input tag. Now type could be text. That's all we need as of now. And another one. I save this, go back, refresh. As you can see, form has gone by and we have two input tags. Now we don't know what to input in those. Perhaps entering some information could reveal. So here we can input some text. Here some password. But we don't really know if you want to enter the username or the email here. So how do we make it apparent to the user? In our forms, we can create labels that would work. But as of now, a simpler solution is at hand here, which is called placeholder. So I will just use that. Placeholder text is going to be enter username. I save it, go back, refresh it. And as you can see, there's a gray information at the background. If I type something, that disappears. If I remove everything, it comes back. Similarly, I am going to do the same thing for password. PASSWORD. Save this, go back, refresh. Everything is working. Always check whether the current change that you make is working, because if you don't, then you might end up making several changes which might not end up working, and then you have to correct all of them. Finally, we want some way of submitting. So I can, for instance, use a simple button, but since we are trying to submit something and it's imminently plausible that we want to just submit a form, we are going to use the form input tag of type submit. Here I can give it a value. I can call it login. If I save this, I go back and I refresh this. As you can see, the login button is here. Now it's vertically stacked, which is something that you may want. I don't like it that way. Also, login forms are supposed to be horizontally scaled. So, or sorry, vertically scaled, and right now they're horizontal. So in order to achieve that, I will just enter a BR tag.
self-closing BR tag because we don't want to close an empty tag. That's not really a problem, but it's not really necessary. Now everything is on its own line. You can style it if you wish to, but in this session, we're not really concerned about styling things. So this is what it means. I can open up my console here because it shows up certain things. As you can see, we have the same warnings and all as before. If you want to understand what these warnings mean, you can take a look at the previous hands-on where we have discussed this. So now we are going to use uncontrolled components. For that, we need to get access to internal DOM elements. So to get access to the DOM elements, we need to create a ref. I'm going to do this using react.create_ref. Username ref equals to react.create_ref, and let's just use the username ref for ref is equal to username ref. In case you're using class components, you have to type this dot username ref, but since we are using functional components, we can drop the this keyword here. So I save this, and now when the form is submitted, you can see something happening. Right now we're not having any state variables because this is an uncontrolled component. Again, if I submit it, as you can see, this submits and creates a full refresh, and we don't want that. So for that, I will firstly create another function, call it handle submit. This takes in an event. We prevent the default behavior, which is submitting the data and getting a full page refresh. Save this. Now if I go back, refresh, because we want the latest changes to occur on the page, click on submit. It's still submitting because we have not wired it up. So on submit, we want to call the handle submit function. Again, I save this, refresh it. It works, but we have misspelled the word submit there. Let's go back and submit. Now again refresh this. Now there are no warnings or errors regarding our form. So if I click on login, nothing should happen. And as we expected, nothing did happen. Now all I want to do right now is log our username ref to the console. Login, and as you can see, this is an object. This object has a current value. This current value has an input, and that input is pointing to an input tag. That input tag could have value. So if we go back, go down, we have a lot of event handlers here. Here's the value, and here's the thing that we're interested in. There are other things here as well, such as placeholders, any other thing that you wish to know, title, validation message, and anything. Most of these are not our concern. So I'm just going to clear the console again, and as you can see, we're interested in username dot current dot value. So if I save this, refresh it again, username, password, login, and we have username. So everything is working fine. Now if I save this again, okay, everything is working. I have to do the same for the password ref. Created the password ref. Now all I have to do is attach it to the DOM node, and this ref attribute is specific to React. HTML doesn't understand the ref attribute, but React, when it takes a look at the ref attribute, it understands. I have to attach the DOM node here because the user wants access to it. So here's going to be password ref. Save this. The reason why we're not logging it here is, let me just show you. The reason why we are not logging it anywhere outside also is, let me just show you. Console.log username ref. If I submit it, if I refresh it, as you can see right now it's pointing to null. This is because right now we have created the ref, we have created an event handler, and we are trying to log it to the console username ref, but it's not been attached to a DOM node yet. When we create the element, when we attach it to the DOM nodes, only then we can access the underlying DOM nodes. So this is why we do this. Now if you want some data, then I can just create a result object that will have two things, username and password. Username needs to be equal to username ref dot current dot value. Similarly, password needs to be equal to password ref dot current dot value. And if I log it to the console, save this, go back, refresh, so everything is working. Click on login, and as you can see, we have the same input. Now a few things to notice here. Firstly, as you can see that there is considerably less code. In the previous controlled components hands-on, when we wrote the code was quite large. It could be because of the formatting, because we put everything in the input on the next line. But the main reason why is because when we're using state variables, when we are using state variables, we use this. We create multiple state variables, then we attach them to the values, and we create event handlers that update the state variables. That's doable, but the issue with that is that it leads to a lot of code. On the other hand, we have refs that you can create, but a problem with refs that you might not have anticipated is that you have no value of controlling the input that the user makes. So if you want to, for instance, make sure that anything that user enters on the anything the user has entered in the form field is capitalized automatically. So everything is in capital font. As you can see here, I can enter small letters, I can enter capital letters. I can do this here, but if I want, as soon as I type D in small case, I want it to be capitalized immediately. That you can't do in refs. In refs, you only have access to the DOM element. So when you're submitting the data, you can uppercase it, but as of now, you can't. So that's one way to do. One way to think about it. You lose access to the data. You lose control over that data. One way or the other way of understanding that. If you use refs, then refs are also discouraged in React because they make your code less understandable, because it's not now declarative, it's imperative, which basically means we just create a bunch of instructions and then give it to the computer to process them. Whereas in React, we can declare what we want, and React will take care of converting that into imperative code. So make sure that you're choosing it for the right reason. One reason could be to manipulate underneath the hood the DOM variable. For instance, if you want to focus a particular element on the page when a button is clicked on the form or submitted, refs are a good candidate for that, because there we specifically need to interact with the DOM element. Anyways, that's the way we do it with ref. Hopefully this has been informative. Let's see what else we have.
Alright guys, now let's take a look at form validation. So far we have taken a look at how we can create controlled and uncontrolled components. Now it's time to understand how we can validate the forms that have been created either by controlled components or uncontrolled components. Validation really deals with data that is underneath the hood, whether you get it via a controlled component that is from state, or you get it from an uncontrolled component that is from the underlying DOM elements. So in ReactJS, since we can store data as a state on our component, we can also have validation of the same data in the same component. Since the data is co-located in one place, validation rules can also be co-located in that place only. When building a form, we can store validation rules, and when the form is submitted, we can generate error messages if there are any error messages that need to be generated. So to give you an example, if you are creating an asynchronous or a single page application in which the user submits some data, let's say the username and password for logging in, they enter the username, they enter the password, they click on submit. When they do click on submit, or they click on sign in, whatever the button is called, the information that they have submitted is first validated on the client. Basically what happens is that take a look at the information, take a look at what exactly is it that is being displayed here, and with that information we firstly validate that information, take a look at all the different ways that input could be mal constructed. Basically, if the input is not in the correct shape, correct format, correct data type, then it's handed back to the user with a particular errors. Now, it's not necessarily the case that all the errors get caught on the client side, mainly because many a times users can disable JavaScript. So server-side validation is also important. But in most cases, client-side validation will work just fine. So we can basically just create a JavaScript logic that will contain all the data. When the form is submitted, we'll take a look at the data, we'll take a look at the rules that we have set, and if the rules are violated, we create or generate error messages and then display them on the screen. So to validate the form, we need to keep track of the data as state variables and generate and display errors using state variables. Now, these state variables are basically just data. We've used the word state variables quite lightly here. You could, for instance, instead of using the word state variables, use just data. You could just get data from refs in uncontrolled components. That really doesn't really matter here. Uh, this is why controlled components are preferred, because data is in React state, so it's easier for us to understand and easier for us to use, easier for us to get access to, and also easier for us to compare to other stuff as we do. Finally, we just need to make sure that the forms are validated properly. And if they are, we can submit them asynchronously and deal with the result. So if the forms are not submitted or they are not validated, then we abort the form submission and display the errors. If the form is submitted, then we proceed with just business as usual. Now, you could, for instance, do all the processing on the client side as well, or if you have some complicated processing such as saving things to the database, getting back the result, and many other things, then simply getting that data to the server would be a better option. Now, let's take a look at what else we can do. Alright guys, now let's take a look at validating forms. So we'll be using ReactJS to validate forms. So open up the code that we have. Here we have the code, and here is the output. So we have an index.html page. What the page is about to do is we have some HTML code, that's the boilerplate HTML that we've been using so far. And with that, what we'll be doing is we'll be writing some code to create a form and then validate it. We won't be displaying the errors, that will be our next topic, but right now we need to just understand how validation works in general. So again, as from the start, we have a doc type of HTML. We have an HTML tag, head tag. Inside it, we have a character set tag that tells us what is the character set of the entire HTML page. We have a viewport tag. We have a title tag. And here we have the body, inside which there is a div with an ID of app, scripts, in which we have the React's development version, ReactDOM's development version, and then there's the Babel transpiler. The reason why we have React and ReactDOM is because ReactDOM is what is the library that allows us to combine together the DOM and the ReactJS library. It could be used in mobile applications and VR applications as well, where ReactDOM will not be required. So we use ReactJS, and inside the Babel transpiler, it will take a look at everything on the page, and will take a look at scripts with the tag or the type of text/Babel, and will transpile every JSX bit into HTML or plain JavaScript. Now let's just create a form first of all. So I will again create a function of type form, FORM. Make sure to spell it right, which will return, let's say, form. Now we have to display it on screen. So react.dom.render. As we already know, render takes two parameters. So we pass in the form, we pass in the document dot get element by ID. The element that we're looking for is something that has an ID of app. We save this. I go back. I refresh. It's not showing anything because in D hands-on HTML we are using react.dom.render. We are using React. It's the same thing here. D hands-on HTML. Let me just see. If we don't get an output, that means there has been some error, and the error is quite simply this.
If I save this and refresh it again, we again get an error that says from is not defined because it's form, and we have misspelled it. FORM, form, and then refresh this again, and now it works. Okay, so everything is configured correctly. This is a step that we take in order to ensure that everything that we're doing so far is working correctly. Now, we need to use controlled components. So again, I will use the username, set username, react, use state, and we will use password. We will use that password, and the state is going to be the same. And now we need to change the markup. Again, since we're using multi-line JSX, we need to return something that is enclosed within parentheses. So I'll just create a form. Action needs to not be there because we are going to be handling the asynchronous communication ourselves. If we had some URL that we wanted it to submit to synchronously, then we would use the action parameter. Right now we don't, so we are not going to be using that. So create an input type of type text, create placeholder, inside the placeholder type, enter username. You can keep the U capitalized, same with password. And now, as we all know, I need an input of type argument and value login. Go back, refresh to see if there are no errors. There aren't any errors. There's a warning though, but that warning is mainly because it takes a lot of time to download the scripts that we have. That could be taken care of on a later stage. Now, we go back, everything is set up. Now we need everything on a single line. Let's do that. Save this, go back, refresh. All the inputs are on the single or are on their own lines. So now it's easier for you to style them, easier for the user to understand which one to use. And I can tab over those easily as well. Now comes the time for us to wire everything up. If you remember correctly from the previous hands-ons, if you're not followed along with the previous hands-on, I recommend that you do. But basically we need to set the value prop to be equal to username so that it's always equal to what the value of username state variable is. And the same with password. Now, if again you have followed me previously in the hands-on, you'll see there's an error. It tells us exactly what the error is, that we have provided a value prop to a form without having an onChange handler. This basically means that now it's a read-only form and I can't change anything here. As you can see, I am typing something, but it's not working there. To fix this, I have to create onChange handler. Now, as you can see, the code is getting a little bigger, so I'll just drop everything on its own line. It's easier for me to manage. Now, onChange handler, I'll create an inline handler which accepts an event, and that event is going to just set the username to be event.target.value. Target will point to the DOM input element, which is the text input element that we have that is displaying enter username as placeholder, and its value will be set equal to our username state variable. Same I can do for enter password. Again, I would have to. So instead of set username, all I have to do is use set password. It works. Now I go back, I refresh, I see no error, type something, submit, but it's submitting and creating and refreshing the entire page. That is not what we want. So for that, I will firstly create a function called handle submit. This will take in an event, and all it's doing right now is preventing the default behavior. So here, all I have to do is on submit, handle submit, save it, and then we can just refresh it. As you can see, now it's showing up here. If I type in something, login, and it's not redirecting to any other page, so that's fine. So everything's working for our entire code right now. Now we need to add validation. So since we have built the application, all we have to do is just complete the validation part and it will work. The validation is going to be just, right now we're going to keep it very simple. And the validation that we are interested in is we are going to take a look at whether or not the username and password field has been left blank. If they have been left blank, then we won't do anything. If they haven't been left blank, then we will submit it. Although if it had been left blank, we want to log to the console that fields cannot be empty. So this is going to be done in the handle submit function. All I have to do is just take a look at the variables. So I just check if username is equal to and use triple equals all the time. This is checking strict equality with the data types as well. Take a look at password. Password is equal to this as well. Then just console dot error. You can type in fields cannot be blank. And now since we don't want to do anything else, we just return. Else we'll just log it to the console what the variables are. Instead of creating a request field now, I'll just username and password. Save this. Instead of console error, I'll call console log. Now there would be an issue here. I mean, it would work to an extent, but there would be an issue. Click on login, fields cannot be blank. If I enter empty spaces, login, and it works. So how do you remove this? Whenever you're building validation, you have to really think of all use cases, what the user can do to bypass validation and enter invalid data. What we can do is when we get the username, we call the trim function on it. What trim function does is that it removes all the white spaces from the beginning and the end, and you get just the trimmed down version. So if I refresh this now, login, fields cannot be blank. Again, fields cannot be blank. But if I type in something, now it's working completely fine. So as you can see, that's the way we are supposed to create username and password fields in any application. Also, there are many other things that you can do. For instance, if it's an email field, then you can create a regular expression and figure out whether or not it's working fine. Sometimes the validation logic can be a bit much. So for that, you can create a function. If it's a little more, then create each component as its own, such as an email component for email input, and let it validate itself and return the data to the parent form component. And there are many other things that you can do. But as of now, it's working completely fine what we had planned to do. Let's take a look at what else we have. Alright guys, now let's take a look at how we can display errors when they occur on our ReactJS applications forms. So once we have validated our forms, if we have some errors, then we need to give back to the user any feedback so that they can fix those errors. So for example, if you have submitted a form and it fails to submit and it says there were some errors, that's not very useful because the user doesn't know what exactly is it that has failed. It has no idea what are the fields that have failed, if there are multiple errors, if there's just a single error, if the user could do something, if it's just an internal error in the web server. The user basically has no idea how to fix any error that occurs. So in order to be able to get over those errors, the user needs some feedback onto what those errors are. So for this purpose, we need to display the errors and indicate that the data entered by the user is invalid and it needs to be fixed. We need to point out what exactly are the errors that needs to be fixed, what exactly are the errors that have occurred, and what exactly are the errors that they can fix. Now the issue here is that we can, if we choose to, just show a single error as the user makes correction. So for instance, if the user has submitted username, password and confirm password, and all three of those has errors, first thing we can do is just display error for username field. When the user corrects those errors and then submits it, we then show the error for password field. When the user corrects that error and then submits it, we show the error for confirm password error. And that way, that's not a really good user experience, but that's one of the things that we can try. Something else we could try is we can show all the errors on our own. Now that depends on the form that we're trying to build. If for instance it's a multi-screen form, for instance there are 3 fields on one page, then you click next and then 3 more fields occur and then you click next. We only want to show errors on the first screen, and that also needs to be accounted for. Also we need to remove the error once it is fixed, and
forms need to be submitted to the user. So when the error is fixed, we want to remove the error messages and we want to bring forms to its consistent state. In case the error is not fixed, we then need to, for instance, tell the user what the errors were so that they can fix it. And when the user fixes those errors and then submits them, if the errors are not there, then we can submit the form. Now, there are many libraries available for form validation and error handling in React.js, such as Formig, Hook Forms, and many others. But using them can make your forms really complicated. In case you don't have really complicated forms, don't reach out for complicated solutions, or your code base is going to get really tricky to manage. Our recommendation would be to use form libraries if and when your forms get really complicated, and keeping track of all that state or all those reps is going to be really difficult. And then you can take a look at a built-in or library for form solution such as Formic or use forms or use form hooks, or there are many other libraries available for form validation and handling the submission of forms. The important aspect is that form validation is something that you can implement on your own. You can display the errors on your own as well, which we'll take a look at in a moment. And finally, once everything is done, all we have to do is be able to understand how we can use the knowledge that we have acquired so far to build good forms. Alright guys, now let's take a look at how we can display the errors. So earlier we take a look at how we can validate forms, but now we need to generate the errors and then we need to display them to the user. Let's take a look at that. Right now we have some code that isn't going to be showing anything. We have index.html. So let me just change the title. Right. So it's the basic HTML setup that we always have. We have the doc type, HTML tag, head tag, meta tag with the character set of UTF-8, meta tag of the name viewport, and the content to be device width and initial scale is 1.0. We're going to be displaying errors. That's what we have set as the title. We have a div with the ID of app. We have included the three script types, React, ReactDOM, and Babel. Babel will compile our JSX code into JavaScript code, and we have React and ReactDOM to use React within a web application. Now let's just start with creating a form. Let's just first take a look if everything is working. We'll take in the form and then we will display it inside an element that has an ID of app. Save this, go back, refresh, it's working. Take a look at the console, no errors, so everything's working. Now let's just create a controlled component as we had earlier. So let us first, action need not be there. We need an input type text, placeholder to be enter username. Here we want it to be password, enter password, and then an input button or the submit button, and the value is going to be equal to login. Save this. Let's go back and see if everything is being displayed. So everything is being displayed, but we want everything on a single line. So save this, go back. Here we have it. Now we need to create username and password state variables, and we are going to be using the use state hook since we're using functional components. By default, they are going to be empty strings. Okay, we save it. We add the value to be username, value to be equal to password, and now we need to create on change handlers. Let me just drop everything to its own line so that it's visible. Inside set username, we take event dot target dot well. The same thing we'll have to do here. Let's set username, we have to use that password. Alright, now finally we just have to on verb terminal, and when this gets submitted we want to call handle submit. This is the function that we have to write.
I'll just write it above. It will take in an event and it will prevent the default period. So we've got our basic for controlled component, which are username and password, no errors. I can type in the username and password, click on login, nothing happens. Now what we want is we want to be able to display some errors. So for that, I will create another errors state variable, which is errors, set errors, react.useState. And by default it's null because by default no values are present, so there are no errors. And now comes time to handle things when they are submitted. So what I want is I want a variable named validation errors equals get validation errors with V capitalized, and since it has access to username and password, I'm not going to pass it here. Finally, when this gets validation errors, I want to check if validation errors, which means if there are validation errors available, then set errors to be validation errors and then return. Don't continue forward. If there are no validation errors, then we are going to set errors to be null, which basically means that if there were errors previously and the user submits the form again and now checking if there are no errors, we firstly set the errors to be null, and then we'll just console log username and password, and that will be that. Now the only issue is that we don't have a function named get validation error, so let's just make that. Okay. For good measure, I think we should pass in the username and password because it could be that we don't want it to be part of the component. So username and password is passed in. I will just write it here, and here's the validation errors. Now here we can do anything we want. Again, we're going to keep things simple, and we go username dot string is equal to an empty string, and I will create a validation error as empty. So right now there are no errors, but if this is the case, then validation errors dot push and username cannot be empty, right? Similarly, if password, then password cannot be empty, right? Now what we have to do is we have to check if validation errors dot length is 0, which means there are no validation errors. Return it like this using a ternary condition. Then we will return null, else we will return validation errors. So it's done. Now if I want to display the validation errors, first let me just go back and see if everything is working. It is working. If I type in everything's working fine here. Now I expect if I don't type in anything, nothing gets logged. That's fine because we're not displaying the validation errors. Now all we have to do is display some validation errors. So for that, I will just wrap everything inside a div tag, because inside React we can only have one parent element. We can't have two sibling elements. Let me just reformat or re-indent everything. Since we are handling things inside a div element, now everything's fine. And now all I have to do is create a UL, and here I just have to check if errors are present, then errors dot map, and I want to take the error and return an li, which is a list item inside the unordered list items. Since we are looping over this, we need to provide a key. Right now we don't have a unique key, so I'll just call it error, and it's working fine. And if we don't have any errors, then just display now. Save this, refresh it again. Login, we display the two errors. Type in the password, login, only one error, type in the password, login, no errors, and it's submitted. Finally, if you want to make sure that everything is reset correctly, instead of set errors, I can set username to be this one and set password to be this one. Right. Now if I were to refresh it again, type in some username, some password and submit it, the username and password disappear, and I have an object that is being displayed with password and username being shown here. So everything is working fine. So as you can see, everything is working. We have everything that we need to do. Let's just take a look at what we're doing. This is called conditional rendering, by the way. There is another way of doing this. If I just remove this and do it this way, and then now it's going to do the exact same thing, which is just check if there are errors, and if there are, then it will display. It's completely up to you which one you choose. I like doing this because it's more readable and more explicit. Here we are showing that, okay, if errors is available, which means it's not equal to null, which if you want to be more explicit, you can do it this way. So if errors is not equal to null, then map over the errors and convert each error into an list item, which will be displayed inside an unordered list. If, for instance, error is equal to null, then don't do anything. So basically, we're doing the same thing. For the and syntax, it basically checks whether the errors evaluate to true. So if it does, then we will, and null obviously evaluates to false. So we will not do anything. And if it does evaluate to true, then follow the next element, and here we will just map over the error and display it. So that's how you can. Now let's take a look at what we had done so far. We have created a form. We have inserted another state variable named error. We will, on submission, we'll get the validation errors. If the validation errors are there, we will set the validation error and we'll return. If not, then we'll set the validation error to be null, we'll set the username and password to be empty, and then process the form. For validation errors, we just create an empty array. We check our validation constraints. If there are no errors there, then we push the validation error inside the array, and we at the end we check if there were any validation errors that were pushed. If there were, then we return those. If not, then we return none. Finally, we have a markup in which we show everything is a controlled component. The only thing is the error list, which is conditionally rendered as being, if the errors are available, then the list items are shown. If not, then they are not shown. All right, so that was it for this. Let's take a look at what else we have.
Let's just understand a little bit of the React router, because we're going to be using it in our project today. React router helps us to set paths in the folder structure of our web application. So say you want to redirect yourselves towards a newer component, towards some different component, you can set that path inside your browser router element that we have here. Like as you can see in our syntax, we are declaring 3 paths, and we are essentially redirecting our client towards those paths upon a particular activity. Then we have socket.io. So socket.io is an external element that is pretty easy to use. It's a JavaScript library for real-time web applications. It enables real-time bidirectional communication between web clients and servers. So instead of the server constantly listening to your instructions, we can simply create a socket.io pipeline between the server and the client. And then as long as the pipeline has been created, then the server can listen to the client and interact particularly to it, because the server always listening is a pretty bad idea when it comes to the processing power that requires and the inefficiency in total allocated to it. So that is why we use this JavaScript library we call socket.io. As you can see, we are creating a connection in our syntax that we have over here. In the variable io, we are requiring the socket.io, and we are creating a new connection whenever a user is connected. So now with all of that done, let us begin with the project. So before beginning with this tutorial, I would recommend you to install Node.js, because that is quite essential to this project for the backend. So once you've opened up your favorite IDE, in my case I've opened up VS Code because it provides with a terminal. So simply create your project folder. I'm calling my project ReactJS chat. Once I've created it, I've opened it up using open folder on the file option over here. So simply open it up and then open up the terminal. So once you've opened up the terminal, we'll create 2 React apps for the client side and the server side. So 2 React apps in total. You type npx create React app client. So now an application, a folder structure with client will create inside of the ReactJS chat a directory. So we'll wait up for that. So once you've done that, once you click on refresh over here, you'll find your client folder created. We'll simply do the same for the server. So we'll bring up the statement again and write server, press enter. So this will take another bit of time for the server to initialize. So once you've created the server, simply open up the server from your browsing directory and open up the SRC folder. Remove whatever there is inside the SRC folder, like I have removed it beforehand, and then simply create new files. The first file that we would create is the index.js. Create that. The second file that we would create is users.js, which would be storing the template form of our users for our backend structure. And then finally, we would create the routing table, the routing.js file. So once we've created all of these three JavaScript files, we'll simply start coding with the users.js first. So inside the users.js file, we'll create certain functions to implement a functionality where inside a chat room, we are adding users, removing users, checking if a user with the same name already exists. So for all of those functionalities, we'll first need to create this users.js JavaScript file. So we'll create an array called users, and we'll create a function for adding a user. So all of these are the parameters for that: ID, name, and room. Whatever the prompt, whatever this request to the server is, so there will be an ID associated to that user. There would be a name, and there would be a room. This ID would be the socket ID. So we're also standardizing the name as well before we convert it to lowercase, so that if the user has entered their name in capital lettering, or if there are trailing spaces in the string of the input, we are simply trimming it up so that we get the same string again. Once we've done that, we will now check if the user exists in the room, and if that user exists in the room, we will not add that user, but if that user does not, we will add them. So this is a function for that. We'll first check if the room will first match the room, and for that particular room only we will check if the name exists or not, because if the user that is trying to access a chat room is not accessing the chat room where that name already exists, if that user is accessing another chat room, that shouldn't lead to the server rejecting that user's request. So for that, we will first check if the rooms are same. So in that room, we will check if the user exists. So the function template has been created. We'll now simply implement the logic for that. So firstly, when the user inputs, the client inputs their credentials, we need to be sure that they have entered both the credentials. So for that, we are giving an error message if they haven't entered both of the credentials. If not name or not room, even if one of those credentials are lacking, we'll simply throw an error message. Username and room are required. And if the function, we will first check if the user is existing. So in that case, we'll throw an error where we'll say that the username is already taken. For this particular room. Once we've done that, create the array structure for the user, store it inside this constant user variable, and then we'll simply push it onto the pre-existing users array we have for that particular room. So we're now done with the add user function that we have. Once we're done with that, simply create a function for removing a user. For this, we only need the ID, because the other details we have already input. So once the user disconnects their socket, we'll simply need the ID for that, and we'll correlate it with all of the other variables that we have, and we'll remove that from the array as well. So firstly, let's create the function for that. The parameter is only id. So we'll first run a search operation, find the index of that particular user, and we'll match if the ID matches the user ID present in that array for us to remove this user from our array. Once we've done that, simply create a function where we are splicing that user of this array that we already have. So basically index 1 0 would return that user from inside of the user's array, and we're simply splicing it off from that particular array whenever we find it on that index number. So once we've done that, we can move on to creating a function get user to implement all our other functions from the different JS modules that we have. Simply use it as a tool later on. The parameter for this would be id, and simply run it as a search sort of functionality whenever any of the server modules need to find a particular user by their id. Users.find user. So we'll check all over the array for that particular id. Once it finds it, it'll check if the id matches the user id. That is what this function will check. We'll close that up too. We'll also create a function if we ever need it to get all of the users present inside a room. Call this the parameter that we would take for this is room, and simply run a filter on the array and put in as the criteria for that particular array to have that room in its parameters in the mapped values that user's array has. So simply type user.room triple equals. So wherever the room is the same, you will return all of the users present inside that particular room in the user's array. So once we've created all of these functions, we can implement all our other backend functionalities pretty well. So we'll simply export this by using module.exports and all of these function names. So if you want to return multiple functions for a particular JavaScript file, you can use module.exports when you're using React. Simply type all of the functions that we've created just now. And we'll close this up with a semicolon. So that is about it for the users.js file. We'll simply save this. So once we are done with indexed users.js, we can open up routers.js. This will essentially tell us if the server is running or not, and it will update like every 300 seconds or something like that. So we'll just add a status bar to it so that it updates every set amount of time to tell us if the server is running or not. So we'll simply import Express for this because we're using some Express functionalities. Right, require Express, and then we would be requiring the router that Express has. So we'll simply type Express router. So we're storing that inside the constant router. So we'll simply type router.get request and response. Request response.send whenever it's prompted for this particular response, if the server is running or not. Simply type response would be server is running successfully, and simply type in the word status. So that would be about it for the router.js. We'll simply export this module. So finally on to the index.js. Here is where we'll be using our socket IO and HTTP protocols for the primary implementation of the server. So firstly we'll create a constant variable HTTP and we'll get the HTTP protocol by using require. Use this up. You get the express, because we need express for this. We need socket IO, simply write wire socket IO. So some of these dependencies we'll also have to build once we're progressing with the project, and we need cores as well. So simply write cores. Now we will be importing our functions that we just created in users.js. So we'll simply write const and all of the function names that we used, add user, get user, and get users. And once we create all of that, simply write wire and the location of our users file, which would be in the same directory as the index.js file. We write that and close this up. We have to put this in single quotes this moment. So once you put it in single quotes, that would redirect to that particular location whenever those functions have to be imported. We also require the router because we would need it for displaying our server status. That is why we use the dot status in front of router. And we'll close this up. And we'll use const app and get the express module inside this variable. Server has to be created on HTTP, so we'll simply use the HTTP module for that. HTTP route create server, one of the functions attached to that module, and this up. And the input output variable would be mapped to the socket IO, and the socket IO will use the server that we created using the HTTP module. We'll simply given the variable for that, which is server. Once we've done that, we'll associate this app that we've created with the express module and associate it to cores. Now if you're dealing with express connectivity middleware, you'll use cores for that. So we're using the connectivity right here, so we're using cores, and we'll use router. So upon connection request, we'll turn on the socket. So we'll type in io.on. io is the variable associated to the socket module, and function name would be connect. When the function name is connect, we'll simply declare that function's purpose, typing socket, and turn on the socket. This is whenever a user joins our chat room, any of the chat rooms that he may declare. Name and room are the variables that we need as the parameters for that function. These are the two parameters that are input by the user. We type in and callback. Callback is used for error message throwing. Say if that function doesn't work, it will call back to the statement that we will write in front of this. And simply use the add user function that we just declared in the users.js file. The ID would be mapped to socket ID, so that is the variable that we would send to the add users function, passing it as a parameter. The name would go just as name and the room would go just as room, because those don't need to be changed. Since the ID wasn't input by the user, we need to actually declare it by mapping it to a variable and using socket ID as the value for ID when we're passing it to the add user function. Close this up, semicolon. Once we're done with that, actually there's an error over here. I'll just put plus instead of an equal to. Now that error has been resolved. If there is an error, we will use the callback function. So as you remember before, when we were writing our users.js code, we had declared certain errors, like right over here. Look over this. So this would essentially be that if there is an error thrown, it would return the callback function. So the callback function would print the error message itself. In our case, we've mapped the error messages to the error variables that we've declared in users. Simply type an error as the callback parameter, and that will simply display that error if the error is thrown. We write socket dot join user. So for that user to be added, we need to implement the socket dot join, and we need to emit a message to the chat to welcome that particular user inside the chat room. That would be displayed as the user, that particular person, whoever is greeting that particular user inside the chat room. We'll simply call that as the admin. Text that is attached after that string would be that user's name, so we'll simply access it using $sign and JavaScript curly brace at user dot name, and we'll close this up. So this will fetch the user's name from that particular input, and simply type in the welcome message, which is welcome to the room, and then we will add the room name, whatever has been input by the user. It could be a room that has been created instantly upon request from the user, or it could be a room that is existing beforehand. So either way, simply type in user room, and we actually need to encase that in curly brackets, so round brackets. So once we've done that, we can close this up and broadcast this using socket, so that everybody knows that that user has joined. So this is for all of the people that are already existing in the room. That will give them a message that this particular user has joined in the chat room. Emit, and this will also emit a message like before, and the variables that we're passing to the message is actually user admin, which is the person that is giving them that message. Also, this is just a pre-designated string value. Simply type in text, and the text would contain this particular variable. Type in, open this up with a single quote, has joined the chat room. Now we don't need to add the room name right here because it seems kind of redundant, and we'll close this up. So once we've done that, we can close this up with semicolon. So both of the messages have been printed. Like the broadcast is to broadcast to all of the users present inside the room already to basically declare that a new user has joined the room, and socket.emit is specifically for that user who has just joined the room, because he doesn't need to see that message with the broadcast message. So once that is done, we type in IO. Although if it's a broadcast, then that user will see it as well, but the other users will not be able to see the welcome to the room message because they are not the ones who are joining the room for the first time. So when we type in user.room.emit room data, these variables would make sense when we start dealing with the front end. Room would be mapped to user.room because that's the input, and users would be mapped to get users in room. So this would display all of this function is essentially supposed to return all of the users that are present in the room. We imported this module from users.js, and the parameter that we pass to this is user.room. So obviously we need to pass the room to that function to know all of the participants of that room. Once we've done that, simply end the statement and write the callback function for any errors, although we haven't declared any, but we can still write that function in the case of any errors. It's always good practice to do that. So once we've done with that, simply close this up. Next thing that we will be doing is socket.on. disconnect. So the disconnect is triggered when a user disconnects from a room. So this would have the remove user function inside of it. If you're following me, if you've gotten the flow of this, simply create a function. This would not require any parameters to be passed inside of it, because we would be fetching the socket ID from ourselves, from the server's end only. We don't need any input for that. So we'll simply const user remove socket ID. So the socket ID is fetched by the server itself from the socket IO module. So that is passed as the parameter for remove user function. And the remove user function simply disconnects that particular user from the array that we have created in users.js. So now we're writing if user. So the user variable is essentially storing the value of remove user function. So the remove user function is essentially returning if the operation was successful or not. So if user, that means if the remove user's operation was successful, we'll simply display that message onto the chat room as well. So for that, we'll do the same as we did before for socket emit. Simply write io.to user room and .emit message, and the user for this particular message will type in as admin, like before. Simply type in admin. Although this admin is this imaginary character that is hard coded into the server itself, it's not an actual user. But just to display messages, we're typing admin as the user, and the text that would be associated to this would be, we can specify the user that has left. So we'll simply copy this user.name and paste it here and type in as left chat room and put an exclamation mark over there just for effect. Close this up. The second would be to update the users in the room, so that the list should get updated, whatever the view of that is. So for other people to see that user has left the chat room, they would have to see the newer updated list. So before we actually start the server, we need to resolve certain dependencies like socket IO and cores. So we need to install these packages. Simply type in npm install cores, press enter. Once that is done, we will install socket IO. Thirdly, we will be installing Express, because that is also a dependency. Simply type npm install Express. So wait for that to be done. Okay, that seems to be done because I had already, I think, installed Express. Now that that is done, we can simply start the server. Simply type npm start. So this will start the server on the port 5000, I believe. So as you can see, the server has started. You can simply type in localhost 5000 and that would open up the server. You can see the response. The server has successfully started, so we can be sure that the server has started. Okay, so now we'll head over to the join component and create our landing page for the website whenever the client logs into the website. So we'll open up join and create a new file inside of join, which we'll call join.js. So this is a JavaScript file, and we would be making our landing page inside of this. We're coding our landing page inside of this. First component that we need, the first module that we need actually, is React. So we'll be importing that from the React module, and the second component that we need from the React module is the use state that React provides us. So as we discussed previously in our presentation, if there are a lot of changes required in the states of the components that you would be using within your React application, React provides you with use state to basically implement that. So the package would be React, and close that up. And we also need link from React router. So this would be important for us to redirect the client to various pages. Like say if the client successfully logs into the chat room, The link is what is used to to open up the chat room, basically to open up the chat component. So that is why we're using link. So we are importing this from React router DOM. So once we've done that, we'll simply start the code. So firstly, we need to export. We need to create a function that we will call the sign-in function, I believe. So this will be the function that helps the client sign into the chat room. Once you created that function, we'll create two state variables. Like first one we'll call name. The variable name would be name, and the function associated to it, the state changing function, would be set name. And the default state that we would use for this would be null, because when there's no name provided to us, we'll obviously call it null because the string is empty, and it will be similar for the room. So these are these are basically the two options that the website provides you upon landing onto the joining page. For the set room, for this use state as well, this would be null as well, not space. We'll also be checking if it's null. As you remembered in the users, I believe it was text index.js or users, where we were checking if the string was null, then we weren't actually adding that particular user to any chat room. So here the default state is null. So if the client is giving us an empty input, it wouldn't actually be registered onto the server because we've already made a check-in statement for that, made an if statement for that. So both of these values have to be non-null in nature. So then we'll finally create our JSX element. JSX element would contain something like create an outer container for this. So this is all HTML code. I'll simply be coding this according to your needs. You would basically code it. I want my website structure to be something similar to this. We'll create an inner container as well. Just make these into round brackets first. That's wrong. The return statement should begin with the round bracket. Once that is done, we'll begin with the code. We'll start up an H1 tab inside of this. We'll call this title. So this would display what the page is actually all about. It basically is an H1 tag for what the name of the page is. So we'll simply call it join a chat room. I think that's good. So when that's done, let's create another div inside of this. So every time you create a div, you're basically creating a block of element within that particular JSX code. So we also need something for an input box for our particular name, wherever the user would enter their name. So we need an input box for that. So simply just type in input placeholder. So this is basically one of those things where you have an input box, and within this in translucent text you can see something like name or email, and when you start typing your email, that disappears. So that is what a placeholder is. So this placeholder name, and create a class name for this. We're creating class names for this just in case if we decide to use the CSS for this, we will refer to all of these elements by their class names. And it's kind of different from HTML, because in HTML, if you remember, you only use class. But if you're using JSX within React, you specifically need to write class name instead of class. So these are the little differences that are present in between the syntax of JSX and HTML. So join input, and I'll create the rest of the folder structure as well, the rest of the website structure as well. So this is how the JSX structure would look like once you've coded it according to your needs. So in my case, I've created the title as join chat room. So you'll see that title up top, and then we have the two placeholders for the name and room, where the user would input the name, the username that they want to use, and the room that they want to join or create, and they're starting up the chat room. So these are the two input placeholders for that, and we've added on change. So whenever there is an actual input on it, we will say, and the input is actually registered by clicking on the sign in button or the login button in our case. We are setting the name with the new event target value, which would be the name that the user has input in the placeholder. And similarly, the same goes for the room as well. So we're setting the room with that value as well. So these are the two values that would be set in the string values of this particular name and room variable. So after that, we are adding the sign-in button, the login button that we have over here. So the button name is login, and we're simply checking first if the room is a non-null value and the name is the non-null value as well. So if you remember correctly, on the server's end, we are only checking if after our removal of white spaces, the trailing white spaces, and our conversion of the entire string into a lowercase string, if the string is null or not, that is what we're checking on the server's end. But on the client's end, we have to check that the string in itself is not null before we actually send it to the server, just to save up on some time, save up on some server resources. Like the client shouldn't be able to send an empty string to the server. That should be checked on the client side itself. That is why we're checking if not name and not room, not name or not room, then we will prevent the default. That means the clicking would not actually incur the action. It would not actually redirect us to the chat room, and it will not actually trigger anything on the server's end as well. So the client would actually have to enter a valid username and room number. So after that has been completed, we'll simply set two variables. We'll call this name and room. This would be attached in the link that we're sending. So we would redirect ourselves to the chat JS. So in the folder structure, we have chat question mark, and the two parameters that we're passing to chat are name and room. So those are the two things. So once that has been done, we'll simply create our button for the sign-in, which we're calling login, and then we'll end the link. So this link is a part of React Router DOM. So this actually helps us redirect from one component to the other component. So that's what it's used for. So with that done, we are done with the join JS page. So now that this is done, we will now go to the chat page. So we'll open up a new file inside the chat folder. We'll call it chat.js. Simply close up login after we've saved this. Login the join page has been saved. The login page has been saved. Now go on to the chat page. Now this will be the page. This will be basically the component page that the client would be redirected to once the client is successfully able to log in. So we'll first start this by importing React. We also need the use state and use effect in this, since we'll be using effects, the React effects in this as well. React. Also need query string for this. Also need the IO from socket IO client. So the one that we used on the server end was the socket IO, but there's also a module for the socket IO on the client end as well. We call that socket IO client. So once we imported all of that, we also need to import certain components that we haven't yet created. We'll call this, actually we'll just create them and then we'll implement this. So firstly we'll just create the components for chat. So we'll declare the socket variable and we'll start up the chat function. So whenever this function is called, the chat component would be initiated. The parameter that would be passed to it would be the location. Now we'll also discuss about the location variable in a bit. So we need to create certain state variables for this particular component, like name, create them set name, and simply type in the same for the other variables that you may need. Set room, and simply declare it with null as the default. Similarly, we'll do this for other variables as well. If we want to know all of the users in a particular chat room, we're using the users variable for that. The message that we would want to type into the message box, so that would be stored in message. This would also be null by default, so we have to check if we're not sending empty messages. And finally, the array of messages that is already present in the message box, we'll call this messages. So this would be the log of the messages that is already present in the chat box. We'll call this set messages. This would actually be an array, so not a string value. We'll actually declare it with an array. And then we need to declare our endpoint. So this would be basically where we would be redirected, where the chat application is actually hosted. So in our case, we'll simply use localhost 5000. So this is the actual endpoint that we're trying to access, server location, which is localhost 5000 in our case. And once that's done, we close that up. So all of these variables have been declared. Now we start with the process of actually connecting our endpoints, as in we are connecting the front end to the back end. So we'll use an use effect for that. So this would be essentially sending the variables that are input by the client on the client end, like the name and room, and we'll send it to the server backend. For that, we'll simply create a function. So once we've created a function, we'll simply type in name and room, because these are the two variables that we have to send to the server. And we'll simply get the query string for this. So we'll now create a socket for our endpoint. Simply call this endpoint because that is a variable which stores our localhost 5000 value. We'll set the room for this, as in we'll change the default variable, the default value of the variable to whatever the user has input. So this would be sent to the chat component by the join component of the server itself. So the flow that would be followed is first the join component would send certain details to the server, and the server would give those details to the front end again after the join has redirected essentially to the chat. So all of these things would be retrieved from the server. Socket emit. So we now need to connect to the function that the server houses, which is join. In our case, whenever a new user is trying to join, or an old user as well. So these are the two values that we were passing to that particular function, which were name and room. Also adding error for whenever if there is an error that is given to the server. And this would be given as an alert to the client, because the error would be sent back, it would be called back to the client side, and we could simply print whatever the error is, because the server isn't actually printing the error, the server is just sending the error message. So if the value of error is not null, as if there is an error, simply bring up an alert for that error. So an alert is basically, if you use Google Chrome, it is like pop-up window that appears in the top of your screen telling you that there's an error. So this is an element that you can use in JavaScript React. So once that is done, simply pass on the point search Now we'll create the connect function for sending a particular message. Now that we've created the joining function, the room joining function. Now we'll create a function for message sending. Turn on the socket for a particular message. So this would access the message function present inside the server. As you remember from before, in the index.js file in our server, we had functions like join message, set the stage of the message, set the state of the message, and this would essentially pick up all the messages that are present in the messages, using it as an array. Once we've done that, we also need the room data. If we wanted to get all of the users present inside a particular room, we'll simply type in socket.on room data. Set the users. We'll set it with the array of whatever the user names are, and then we'll close this. So once that is done, simply type in the function for sending a message, start that event. So we also need to ensure right over here that the message is not null, so we'll use a prevent default for that, so that the message is not actually sent if the message is null. So if the value of message is a non-null value, then only we will socket emit it to the server. So we'll call the server function, which is send message, and pass in as the parameter the message that we're trying to send, setting the message state to null, so that after we've sent the message, we can't have that same value in our text box, right? We need to remove it from the text box. Whenever you are texting somebody, the moment you send the message, the text from your text box disappears, so that you can type a new message or wait for the recipient to reply. So we need to set it to null, so that it's back to its original state, and then we simply close this up. After that, we'll simply create the visual element for this, the JSX element for this. So I'll type in the code. So my finished JSX code for chat.js looks something like this. So we've created two divisions in this. One is outer container, the second is inner container, which actually houses our text box, where we'll be texting the chat window basically. And we are basically writing down, like, we've implemented three functions inside of this. And these three functions we would actually be importing from various JavaScript files that we would be creating. The first is info bar, the second is messages. So this would basically display all of the messages that are present inside of that chat box that have been already written down. The third is input, which is the actual element where we would be inputting the message that we are trying to write, and we are passing parameters alongside these functions. Like for info bar, we are passing the room. So the info bar, the task of the info bar is to display the room number or the room name in which we are chatting. The task of messages is to display all of the messages that have been there before, and the task of input function is to basically register the input for this. So we're sending the first value as first parameter for this as message, so the message that we've immediately typed. Then we're actually changing the state of the message, so we're sending the state value for that as well, and we're using the function send message. So now we'll create two more JavaScript files. The first would be called messages.js. Firstly, we'll click on this particular link on the messages folder, and we'll create the new JavaScript file called messages.js. Close these up. Save them, of course. We'll close them up. Once we've created the messages.js, we'll open up the message folder and we'll create another file within the message folder. Actually, firstly, call this message.js. react.js. So, oh, actually, I added a comma over there. Just remove that. So firstly, we would be writing the code for messages.js now that we fixed up the folder structure. So we'll import React for this, and then we'll import something called scroll to bottom. So as you know, in the text services that you use, like Facebook chatting or WhatsApp chatting, so you might have noticed that whenever the messages are the screen is filled with messages, essentially the screen scrolls to the bottom of the latest message that there exists. So that is also a functionality that React offers. So we'll simply import this from React scroll to bottom. So if there isn't, there are certain dependencies that haven't been resolved. We'll simply resolve them when we deploy it on the client's end, and then we'll import message from message folder within message. We close this. So this is actually the subdirectory that we've created inside the messages folder, which we are calling message. So that is the another JavaScript file that we have, which we'll code in a while. So once that is done, we'll simply type in the function for this. So two parameters that we need to pass. First is the actual messages, so that we can see all the messages that are present on the screen. Second is the name. So create a function for this. Use the scroll to bottom function that we've imported from React scroll to bottom. And we create a map with a variable I. I'll tell you what this variable I is in a second. The function would have put a comma over here, which we need to remove, and we'll simply type in a values for this. So we've done that. We can now send in the actual message parameter by using the message function that we've imported. So we'll call this. So the code would look something like this after you've done it, writing it. So basically scrolling to the bottom every time the message window is getting filled up with messages, so that the newer messages are shown at the absolute bottom. And we're calling the message function, passing the two values, message and name, to this, so that the message is the subcomponent of the messages function is able to show all of those messages in a proper bubble format. So now we'll code for the message JavaScript component. So after you finish writing the JSX code, it will look something like this, depending on how you've written it. In my case, I'm checking first if the current message is sent by the current user, and if that message is sent by the current user, we're simply putting it on the right side by using send text PR10. So PR stands for it will be 10 pixels from the right of that particular subcomponent that we're writing this code into, and we're then writing the username for that particular user, whichever the client is, in the case of the message being sent by the current client. Then we're changing the background color of that message box to blue. So if you're the person who has sent that particular message, your message would appear in blue, just like in Facebook chat. But no, if not, the message would appear on the left hand side, because we're using PL10. So stand for left, L stands for left, and it's 10 pixels from the left. In that case, that particular user would appear, whichever user is actually is the author of that particular message, and that message would appear in a background light color. The bubble would appear in a background light color. So just like in the Facebook chat, your messages appear in blue color, while your recipient's messages appear in a light grayish color. So that is what would be implemented here. So once we're done with that, we'll simply export the message function, which we've declared over here with all of these, and we'll get on to writing the info bar. Also, all of these class names would be mapped to a particular CSS value. So we haven't created CSS files for this yet, but we're creating separate names for separate CSS elements, so that if the message box is background light, we can create an element for this particular class name and declare the background as light, while for this we can declare the background as blue. So all of this would be implemented from a visual perspective when we actually write the message.css file and we import it into the message. So that can be done later on after the base code has been written. So we'll now write the code for the info bar. The info bar basically contains which room we are chatting within. Like if you're chatting in a group chat, you would know the group chat's name on the top. So that little bluish bar that you have in your Facebook Messenger at the top, which declares the room name, we're simply implementing that as well. So let's simply import React for this first. Should be a rather small code. React. That should be about it for the imports. We'll create a function infobar for infobar.js. Parameters that we would pass to this would solely be the room, because we only need the room name, and then we can begin with the function. So this would only have to return 2 divisions, I believe. Firstly, we'll create another division which we'll call class name bar. So this would, we can implement the design for this using the CSS style file. Once that is done, we can close this up and start with another division which we'll call class name left inner. We'll close this up, and within this we'll create an, I think, H3. We can create an H2 as well. I think an H3 would be enough size, and we'll simply create a JavaScript curly bracket opening and write in room. So the H3 would contain the room name that has been passed to the info bar value, and then we'll simply export this function, having export default info bar, and we close this up and save it. The last thing we need to implement before we head on over to our app.js and index.js, the code modifications we need to do in those JavaScript files before we can actually deploy this on the client side. We need to create our input.js and couple all of these JavaScript components together, because we haven't coupled them together. So it's essential for us to couple them together before we can get some sort of a structure going. So for input.js as well, we'll import React. Don't need to actually import any of the elements in this. We'll simply start with our function straight away. So this is the actual component that helps us send a particular message to the server. Because we in the previous function for our chat JS, I think we sent this particular parameter send message function as a parameter in that function. So that's what we're implementing right over here. I think if you check our chat.js, we're actually sending the send message right over here as a parameter. So this function is actually sent as a parameter. So that is what we can implement in our function right here. Create a form. We want this class form, and then we're using the input function for this. Simply write in the class name as input. Write any class name you want. The type for this particular input is text. It's not password, it's text. And the placeholder for this, type your message, and we'll add like 3 dots. This is what the placeholder text looks like for when you actually are typing a message. The value that this particular input would contain is the actual message that is stored in that text box. So this has been passed as a parameter as well to input by our chat.js JavaScript file. Change, we will simply make that placeholder contain that value which is contained instead of the placeholder as the target for our input. and we will set the message value, as we had passed the set message state variable as well to our input JS file. I will simply set it as the value that is present within the text box, and we send our messages using the enter key. So we'll also add an on key press parameter to this, so that we don't necessarily have to click. We can also just press enter and the message will be sent. Event, that message would be sent, trigger would be there, the function trigger would be there. So the function that would be availed by this is send message, and the event is already there. So send that. If enter is not pressed, so nothing would be sent, no function would be executed. Simply register that as none, and we close this up. So now that it's closed up, we can also create a button to send our messages, not just by using enter, something that we can click as well. So we'll call this the send button, and simply whenever you're using this, you can simply write on click variable, any variable, dummy variable we can create, and map it to send message E. So this E would be the actual message that is contained in there, and we'll call this button zap, or we can call this send message, depending on what you want to use. So this would be the button which actually sends the message, and then we'll close this up. So once you've corrected the format and everything, and then you will simply export this function so that it's accessible by other components of your ReactJS file structure. So now we can move on to coupling all of these values, all of these components actually. So here we have our chat.js file, which is the primary driver function, the driver component for all of these sub-components. So we've also imported these particular JavaScript files that we had created before, like the info bar, the input, and the messages. And within messages, you can also see that within messages, I've also imported the sub component of messages, which was message from .message. So all of these directories have been particularly imported. Now, since these have been coupled, we can move on to coding our main components, which are the app.js and the index.js, the rendering components, so to speak, for our client side, so that things will appear in the first place. So we'll head on towards that. So head over to your app.js. So after you've opened up your app.js, simply remove everything that there is except for your import React statement, because we would be needing that. So once you've done that, simply couple your previous elements like your chat from dot components slash chat slash chat. So this would be the first element, and second element that you would need is join, because that is the first landing page that appears. So these have already been created. We've created all of these components. Now we can use them as many times as we want, as we had discussed in our presentation. That is the primary benefit of using React. So we've done that. Now we'll import browser router so that we can route depending on the user action. So we'll import browser router as router and route this from React router. So wherever we have to use browser router, we'll simply write router. You can read up on the React ReactDOM documentation a little more in clarity to understand how it works. But for now, you can understand it as something that redirects us to different components present within your web application. Return a statement for this particular app.js. We'll simply use router. And this is basically, we can write browser router instead of this, but since we've imported browser router as router, we can simply write router. So that reduces the time to write, although if you want to write browser router, you can do that as well. And the paths, first path to the join, which is the exact component, which would mean that it is the first page that the user lands to. Second router path would be the route path actually, and this would be the slash chat. So if the person ever inputs into the URL slash chat, they would be redirected to this component, which is chat. So also discuss where this was actually implemented in our code. Now that we've done that, we'll simply export default app. So that would be about it for the app.js. Close this up. I think that is fine. So yeah, we have route paths slash chat over here. So if you remember correctly, if I just open up my chat.js, I believe, no, actually not chat.js, join.js, we have something like the link that it has been redirected to is slash chat question mark name and the name variable in JavaScript, room, the room variable in JavaScript. So this is basically what you see when you type in a particular request to a website. This is the actual format that is actually implemented. So when there is slash chat question mark, we are basically routing that particular value, this chat question mark, this chat essentially, to our chat component. So that is what the router is doing. It's basically taking up a component and it's routing it to a component that we've declared, taking up a name in the URL and routing it to a component. Like if the path is slash chat, it will route to this particular component. If the path is default, as in if the person just enters the local host 3000, wherever the port we want to launch our client side is, it will simply, the exact component that it would route to is the join, which is the first landing page for our website. So these are the two essential components that we need, which contain all the sub components that would constitute for our client side chat application. So now that that is done, we can move on to editing our index.js. So we've opened up our index.js file. So the first thing we would do is remove all of this except for our React and maybe our ReactDOM. So we don't need all of that, the things that are available other than that. So simply import your app from your .app. I think that is the directory here. So once you've done that, you can simply render your React page. So we use ReactDOM render for that. Simply type in app, the name of the function that you're using, that you're basically rendering, and document get element by ID, and we'll put this as root. So that would correlate to the public HTML that we have for this, which is the HTML that would actually render all of these components of React. That is one of the key points, the key advantages of React. It's at the end of it, it's rendered as an HTML, but you can do all of these logic-based things with it using JavaScript. So that is how we implement logic in the front end using ReactJS. So once that is done, we are pretty much about done. Save that. Now the next thing we need to do is add a certain number of dependencies. To resolve those dependencies, we need to install certain packages. So we'll first install npm install query string. So because we're using query string, so we need to install it in our modules. We'll do that. So once that is done, we can CLS first, and then we can install npm install actually our ReactDOM if it's not actually installed. ReactDOM is actually installed. If you are creating a boilerplate React code, that's already installed, so you don't need to worry about that. The next dependency that we will check for is React Router DOM. So clear the screen, and now we will add React scroll to bottom by writing npm install React scroll to bottom. Okay, so once we've added that, we can add the socket.io client and simply type npm install socket.io client. That will install our socket.io client side modules. So all of these things are done. So all of our dependencies essentially are resolved. Now we can go on to implement the deployment of the client side code. Now that our code logic has been implemented, we'll simply add in the style files for this, the CSS files, so that things would actually appear on screen in a much more organized and structured format. Because if we start our front end right now by simply typing npm start, it does not actually show anything because a lot of elements aren't being able to render because we haven't implemented the style files yet. So we'll do that. As we can see now, we have added CSS files for all of the components. You can make these CSS files on your own, basically to give some structure and design to these particular components that you have, and simply type in import and the address of that particular CSS in the import statements. And then all of these class names would be referred to that particular CS, and then you can basically implement all of the CS styles. So now we will start our server by typing npm start. So it will open up to something like this. We have our join chat room landing page right here. So this is the first page that will open. If you open the default localhost 3000 that is set for the client side, and now we will type in something like Intellipaat as the username, and the number or the room name would be 1. Once we log in, we're inside room 1. Simply type in localhost 3000 again to open another instance, and we can create another user called the Intellipaat 2 and room number 1, so they will join in the same room again. So when the first person, we switch back to the first instance, so we'll see Intellipaat 2 has joined. So we'll simply type in hello from Intellipaat 1. It will display over here, and when we go here, we have these messages. So the admin, which we had hard coded into the chat box, it says Intellipaat 1, and that person, the other user. So, and we can similarly create a user. Simply typing localhost 3000 and all this Intellipaat 3 and room 1. So the room has to be the same. We can actually try Intellipaat 2 so that we get that error message because Intellipaat 2 already exists. We'll simply click on login and it says username is taken. We get that alert. We cannot actually log in. So we're not actually in that chat room. So we'll go back again and we'll type in something different. 3000, we'll type Intellipaat 3 and 1. Now we're able to log in. Type in hello. We're able to see it from here that Intellipaat 3 has typed hello. We're able to see it from here. Intellipaat 3 has typed hello. Similarly, we can add as many users as we want, and we can make this website live as well to implement it on the grand scale.
So let's begin this ReactJS interview questions with one of the very important questions that is mostly asked in all of these interviews. So to begin with, we have the question which states differentiate between virtual DOM and real DOM. So DOM, as you already might know it, is the document object model, and there is a specific working with respect to React on virtual DOM and the usage of real DOM as well. So more on that in the next couple of questions. But then the answer for this question, the way you're supposed to approach this is very simple. Just give them the concise difference between the virtual DOM and the real DOM. For example, when you consider working with virtual DOM, it is actually a little bit easier in terms of usability rather than real DOM. And then there's a lot of memory wastage which happens whenever you work with JavaScript objects. And here, when you're making use of virtual DOM, memory is not wasted as much as it would in the case of real DOM as well. And then when we talk about the JavaScript XML elements, which is also called as the JSX elements, it'll only be updated every time if an element actually exists for it. But then in the real DOM, that's not actually the case. In real DOM, what happens is every time there's a new element that gets updated, right, a new DOM itself is created for it, and then an object is processed and later passed on to JavaScript and then the browser and all of that. So in terms of the backend working efficiency as well, a virtual DOM has a bit of the higher picture here. And then when you talk about the ability for either the virtual DOM or the real DOM to manipulate HTML directly, well, here real DOM might have an advantage because it has the ability to directly manipulate HTML while virtual DOM cannot manipulate HTML directly. And then when you think about compilation and the actual updates being shown, virtual DOM will update faster than the real DOM, and you will understand why in the next couple of questions, as we'll be dealing with virtual DOM a bit later. This brings us to question number 2. Question number 2 states, what is React? Well, React is one of the world's most popular JavaScript library as of now. It was originally launched in 2011. It was created by the developers at Facebook, and it was mostly meant to provide a nice pipeline for very good front-end development, right? So creating front-end elements is not only complex, but at the end of the day, it has to be simplified to a point where you can efficiently work with the tool. Well, React was this particular implementation. It is based on a component based approach where you try to build each components and make sure that the reusability of these components are very high, in a way where you can take these components out and make a lot of things with a lot less, if I have to put it in a very simple way. So React gained a lot of traction since 2011, and no doubt it is one of the number one JavaScript libraries out there. And for this reason, you can develop a lot of complex stuff, be it mobile interfaces, web applications, or even designing anything complex, right? So with React, it makes it all very simple. So when you're asked this question, make sure you mention all of these to add a little bit of value to your answer, rather than just saying that React is a JavaScript library, right? So saying it out this way will add value to your candidature. Now, coming to question number 3, it says, what is the meaning of virtual DOM? As we just discussed in the first question, so to give you more clarity about this, a virtual DOM is nothing but a simple JavaScript object. So a virtual object is an exact copy of a real DOM, where it can be considered as a tree, and it can be considered as a node tree, which has all these things such as elements, it has attributes, it has properties attached, and much more. So if you picture a node tree right now, where each of these branches can branch out into elements and their attributes and the properties, that is what the virtual DOM would look like. And then when you think about React uses something called as the render function, where it actually creates a tree. It updates the tree based on the changes that happen in real time, with respect to the data model, and then present the changes that you have done out to the browser, right? So it is very similar to this, and virtual DOM is in fact used for that as well. And then when you think about all the changes, either performed by the users, or if there is an action which has led to a cause, which changes something, then again the render function is called, the virtual DOM is put into use, the object is used, and then the working of it goes on in an order, as we'll check out in the next couple of questions. Coming to question number 4, it states, what are some of the important features of React? This question can be answered in many ways, because React has so many different features that you can talk about. You can go on 10 minutes with the answer for this particular questions. But then the most simple way I would suggest is to pick out features that'll help you portray the uniqueness of React, right? So I have 3 points on your screen that you can use to add a lot of value. The first thing is, it says React makes use of a single directional data flow model. Again, this is only native to React while its development was, and it is in a league of its own. The single directional data flow model works very effectively. It's very rapid, and it is used to just make the entire process of designing and developing a front-end solution very efficient. And then when we talk about the ability for the front-end development language to have control over server side of things, well, yes, React has the ability to completely control the server side data processing abilities, the handling of it, and then merging it in terms of creating a pipeline where you'll be using it for your front-end requirement as well. And of course, we spoke about virtual DOMs. So React uses virtual DOMs, and this in its own stages has multiple advantages as well. So you can name 3 or 4 points which makes React very unique, in a way where your answer is concise and you keep it precise at the same time. Now this brings us to question number 5, which states, what is the meaning of JSX? JSX, as I just previously told you, is the abbreviation for JavaScript XML. So it's nothing but a very simple file which is used in React to make sure that you hold together this essence of JavaScript and React in a way where there's a lot of advantages of using these together. So, when you think about working with HTML and JavaScript, a JSX file is basically used to bring out the HTML file. Make sure you have the ability to make use of the HTML syntax in a very simple way. And at the end of the day, of course, yes, the syntax is, very readable in a way where you can understand a lot of things even without having to know what it does exactly. And with this comes efficient programming and, of course, good performance to the application. If you have to take a look at an XML file, JavaScript XML file, there's a quick sample on your screen right now. There's a render function we're returning where we're printing the h1 header to be hello Intellipaat learners, right? So this is a very simple XML file, the JavaScript XML file, and in most of the cases it is as readable as this. Even though there's only 3 or 4 lines, even with more lines, a JSX file is very much readable, and you can very much contemplate and understand what's going on there as well. Now with this, we come to question number 6. Question number 6 states, can browsers read a JSX file? The answer you have to begin with very simply is no. Directly, browsers cannot have access and read JSX files, right? So what basically happens is, whenever there's a browser which needs some changes to be portrayed to the screen and it has to be rendered by the JavaScript programming languages, the browser can only read an object, and this object is directly provided by JavaScript. Now, the case comes in a way where if you answer no, then how do you make a browser read a JavaScript file? It will be the follow-up question you will be asked if you say no. So to explain that aspect of it as well, to make a browser actually read a JSX file, it has to be first converted into a JavaScript object using something called as JSX transformers, and only after using JSX transformers can they actually be shown to the browser, and the browser making sense of it as a JavaScript object, and then it'll work further down the pipeline. So unless your browser sees the JavaScript object, it cannot understand JSX files directly, guys. So with this, we come to question number 7. Question number 7 states, why is React so widely used today, right? So from 2011, from the developers of Facebook, it has been seen a lot of traction, and a lot of people are jumping on React, not only for its ability to create very good environments, working environments, easy ability to work with other frameworks or whatever it is. It has created a plethora of job openings, in fact, and that is one of the reasons why everyone wants to get on the React train, because they know this is one of the top development frameworks out there, right? So if you make use of it and if you want to build a career in it, it could be very lucrative at the same time. Now, coming to some of the features of why React is actually widely used, you have to understand that testing is a very, very important part about development frameworks, right? So here as well, with React, making use of testing methodologies for your user interface becomes extremely easy. And the another important thing is that React can talk very easily and work very well with other frameworks such as Angular, Vue.js, and much more. And coming to point number 3, we're talking about readability of code from that time, right? So the ability of you to understand the code as soon as you look at it is very, very high, which makes sure that you can have an easy understanding of what's going on with the code and help you work in an effective way as well. And now when you talk about how React is being used for both front-end and server-side requirements, where it has the ability to, plan, maintain, hold some data and then work with it, well, here is the biggest advantages of why React is being considered today. And at the end of it, of course, with all of these applications comes very good performance, and with all these features, it brings about a sense of efficiency which no other framework has seen before. So this is one of the reasons why React is considered to be as popular as it is today. Now coming to question number 8, this is a common question as well. This question has a very high probability of being asked. If you keep on talking about the advantages of React, the interviewer can ask you about any disadvantages with respect to React as well. No matter the amount of advantages, even though they outweigh the amount of disadvantages directly, there are some limitations when you talk about React. So since we're making use of JavaScript XML here and something called as inline template formatting, what happens is that whenever you're writing code, it tends to become a bit complicated at times. And especially for beginners, it'll be very difficult for you guys, even though the syntax might be very readable, but then this syntax is complex on its own to understand its structure as well. So with respect to that, understanding methodologies, JSX and everything, beginners can find it a little tough to work with these as well. And then we're talking about React contains a huge repository of information where you have to learn a lot before implementing. And of course your implementations are going to be very powerful, but then to get there you really need to have a lot of knowledge and information, right? So that can get a little overwhelming as well. And then we're only talking about learnability, but then when you really have to concentrate about the simplicity of React, yes, it is simple, and this poses as a disadvantage because it is not a complete framework. So you will have to have certain dependencies along with React, and of course if you have to use them together, it means that you have to learn whatever it is required of the dependency and learn React at the same time as well. Even though it sounded like an advantage at the first half, now you get the clear picture of what some of these disadvantages of React are. This brings us to question number 9, which is a very simple question. It says differentiate between Angular and React. Well, both of them are amazing frameworks, right? So when we talk about Angular was actually developed by Google, while React was created by Facebook. The usage of DOM, Angular uses the real DOM and React makes use of the virtual DOM. And then when we're talking about rendering, rendering happens on the client side with respect to Angular and on the server side when we talk about React. The architecture is again a very simple one. Angular provides support for model view controller. The complete MVC support is provided, while React only provides the view aspect of the model view controller. So when you have to talk about data binding, Angular takes a bit of a sidestep here because it only supports unidirectional data binding, while React has the ability to completely support and champion two-way data binding as well. So you really don't have to explain a lot when you're asked about Angular and React, because at the end of the day these two frameworks are meant for their own niche uses, and both of them are really good at what they do. So just make sure you highlight the basic differences, the actual differences that lie in between them, and that should be more than enough to get you on to the next question. And the next question states, what is the meaning of the component based architecture of React? So one very important thing about React you have to understand is that every single entity is considered to be a component, and these components are like the foundations which are used for building user interfaces for web applications. So when you have a component based system, what happens is that every single entity will become completely reusable in a way where so you can move it around, replace it, and once it has the ability to become independent of each other, right? So this is when you are extremely efficient while programming itself, and your application becomes efficient in a way where it can reuse the components rather than having like 10 components in the place of one, which would again cause very high redundancy, which is not good for programming and which is not good for execution as well. And then when you think about rendering the applications with a component based architecture, the rendering becomes very easy and it does not depend on any other components of the same user interface as well. So when you think about it, again, it's completely a huge advantage for React, and it is only because of the component based architecture. So with this, we can move on to question number 11. Question number 11 states, how does rendering work in React? Rendering is a very, very important aspect of React, as you might already know it, as every single component that exists in React, if it has to be seen by the user or by the browser, it has to be rendered. And rendering in React can be done by using a function of the same name, which is the render function. So what actually happens is whenever there's a function that is called, right? So after it is called, it returns an element that actually represents a DOM component. And what happens here is that if you're wondering, can we, have more than one HTML element at a time to be rendered to make sure that it is efficient? Well, yes, it is possible to render more than one HTML element. And how is this done? This is done by taking all the HTML tags, enclosing these tags, and then passing it all to the render function one by one to make sure that they execute concurrently as well. So rendering is a very important aspect, and this is why. So coming to the 12th question, it states, what are the states in React? So states is something which is very important you have to understand about React as well, because it is one of these vital things, because it is the source of data, or it can be considered as the objects which control various aspects such as component behavior, component rendering, and much more. So states, as the name suggests itself, is used to easily create these interactive components that we like in all React applications, and of course to create the dynamic applications as well. So as a serving foundation, states is very vital in the working of React. With this, we can come to question number 13, which states, what are the props? So what are the meaning of props in React? Well, props are actually a short name given for properties in React. So whenever there's properties we talk about in React, all of these are read-only components which are completely immutable in nature. So they cannot be changed as and when you require in real time, right? So whenever there's an application, what actually happens is that, there are properties which have an order that is passed down to them from, let's say, the parent components to the child components, and then these properties are matched to each other and then used. But then if you're wondering, can we have child components which can assign properties to parent components? Well, no, that cannot be done. This is done only to make sure of the concept that we already discussed. It's called as the single directional data flow. So to keep the data flowing only in one direction, even in this case, to keep the data flowing from the parent components to the child components and the properties associated with them, props are very vital to be used in React as well. And then coming to the 14th question, it states, what is the use of an arrow function in React? So you might have used the arrow function, or you might know how to use the arrow function as well. So it is a very simple expression that is used in React in case if you have the requirement where you have to bind certain components manually. The functioning is very simple, it is very direct, and it is very helpful when you're working with something called as higher ordered functions as well. Again, we have another question for higher ordered functions as well, so we'll check that out there. But then coming to the usual example of where you have to manually bind components, you can see my input on change equal to this dot handle change and bind this is how you manually bind it, right? Now there's a fun way if you make use of the arrow function. So instead of directly saying it that way, all you can do is to enclose the function and use the arrow function, as you can see on your screen right here. So this arrow function is another way where you can use it. Here in this example, of course, the syntax is very simple, but then if binding your components can get complex when you're using a large piece of code, this will simplify it to a very good extent. With this, we can come to question number 15. Question number 15 states, what is a higher order component, right? So as we just discussed in the previous question, higher order component is a component, yes, but then when we talk about it in general, it is actually a technique that is put in place for React, where we make use of this entire architecture based on something which we already discussed, right? So it's the component reusability logic. So to apply all of these components, we have something called as the higher order components. And one thing that you should always mention while answering this question is that they are actually not a native part of the React API at all. And what actually happens here is that it will allow the users to reuse whatever piece of code that is required, have some bootstrap abstractions if required, and much more. And it's not only this. With higher order components, what happens is that it will allow for very, very simple sharing of any sort of behaviors between the components in the component structure. And then doing this, again, we will circle back to one very important thing about React, is that it will give way for high efficiency and easy functioning of the applications. Well, with this, we can move on to the 16th question, which states, what is the meaning of create React app in React? Well, the create React app in React itself, it is actually nothing but a very simple CLI. A CLI is a command line interface where you can use it to create React applications where you have no build configuration, and using this is very simple in a way where all of the tools come predefined and pre-configured with the CLI. So doing this is mainly advantageous for you as a developer, because at the end of the day, you will be having the ability to concentrate more on the code, more on the logic, all the dependencies, rather than how you can work with syntax or the complexity of actually building the application and much more, right? So it's a simple CLI, and you can use the syntax shown on your screen to start a very simple project in React as well. It's called create React app space my app. My app is being the name of the simple project that you want to start. So with this, we can come to the next question that states, what are some of the advantages of using create React app in React? So we saw what it is, but then it has certain advantages which make it stand out as well. So, with Create React app, one very important thing is that it has the direct support for JavaScript XML, flow statements, and ES6 statements as well. So with this, what it will do is it will make sure that it is very simple for you to work with without worrying on a large piece of code that happens in the backend. And of course, it will provide you fast interactive testing components and line development servers, which are very, very, very vital when you're working with debugging as well. And you get direct scripts which have the ability to handle JSS, CSS, and any other file that's required as well. And then your CSS is already auto prefix, it is ready, it is built in, and you can use it thoroughly as well. So with these 5 or 6 points that you can mention for the advantages of using the Create React app, and then this will make sure that that you're proving to the interviewer that you do have a concrete understanding of the foundational concepts involved in React as well. Coming to the 18th question. In the 18th question states, what is the meaning of Redux? Redux is again a very important aspect of React in a way where Redux is actually used to store individual states of these applications. So every single application will have a state, and then to keep it very simple, we have to store it in a single entity, and using Redux we do just this. So if you're thinking about, is Redux a JavaScript object by now? The answer is yes. This entity that gets stored into the state of that holds the state of an application is actually a JavaScript object. So changing the states can be done whenever you're pushing out any actions from the applications, or whenever you are writing the corresponding objects for these particular actions, mapping them while you're modifying their states as well. So a simple Redux object to show on your screen: first name is John, last name is Kelly, age is 25. So to retain this first name, last name, age in a state in a single entity, this is where the JavaScript object called Redux comes into the picture. So all of the data that gets retained by the Redux, so sometimes there is another name for it. The interviewer might ask for a store. So well, a Redux store, or it is just called as a store where the data is basically stored. Now with this we come to the 19th question, which states, what is the difference between props and states? Props we already saw, it's as properties. States we already checked out as well. So there are certain simple differences that we can check out in the conditions. See, for example, the ability to perform any changes in child components for the properties, yes, you can change it. With respect to states, you cannot change the child components. Now, can the parent components change values? In the case of props, yes, they can change it for their child components. In the case of states, no. So then what can states do in these conditions that we're talking about, right? So each individual component, can changes be done inside each individual component? So that is where, when you ask that condition, of course with properties you cannot change, because then this defies the entire working architecture of properties and the component object model, right? So in the case of states, yes, changes can be made into the components, and this is one very simple yet elegant difference that you can put out when the interviewer asks you the difference between props and states. Now with this we come to the 20th question. The 20th question states, what are the 3 phases that is involved in the component lifecycle of React? This is a very common question. This is among the first top 10 questions you will always be asked if you're going into a React interview, because it's very simple at the end of the day, and it denotes your understanding of the concept. Because when we talk about the 3 phases of the component lifecycle, it involves initial rendering, updation, and the process of unmounting. With initial rendering, which is the first phase, this is where the entire process actually begins. The component goes to the DOM and all of that. And then when you talk about updations, this is where the component has the ability to be updated, the code to be changed, it has to be rendered again if required, and then it gets added onto the DOM. And the unmounting becomes the third important phase, where this involves the destruction of the component and its removal after it is not being used, after its rendering is done, and after it is no longer in the viewing base or the viewing platform of the user, right? So it has to be removed from the DOM to make sure the application is kept efficient as well. So first we render it, then we update it, and whatever gets updated and re-rendered gets into the DOM, and after which we have a component which we do not use, we remove it. It's pretty simple, guys. It's initial rendering, it's updation, and it's unmounting. So with this, we can check out the 21st question. So the 21st question states, what are events in React? Events are these important things, probably the most important things that happen in the entire React architecture, right? So think about this. Whenever you perform any action, right? So like moving a mouse on the user interface of the application, or let's say pressing a key on the keyboard as well. So what all of these actions pertain to is that they'll trigger something called as an event. An event will then do a certain set of steps. It will perform a certain set of activities in response to these triggers, right? So the triggers are the mouse pressings, the mouse movements, or the key presses on the keyboard. Now, to perform certain activities in response to this is a good example of what events are. And think about the DOM architecture, and then when you think about the working of the DOM architecture, handling an event in React is very, very much similar. It's very much similar to that of the DOM architecture as well. So with this, we can come to question number 22, which states, how are events created in React? Now, it is always advantageous that you answer questions like these with a small snippet of code, right? So ask for a piece of paper, or in case if you have your laptop in front of you, just whip up a tiny piece of code where you can actually show how events are created in React as well. And they are created in a very simple way. First, we have the function where you'll have to put in the logic for the code, and then of course with the render function, the render functions, whatever is in the div that will be rendered, it'll have a. And you have the functionality of the div as well. So on click this dot show click here, so the message click here will be displayed on it, and as soon as you click there, the code basically will go into the segment which is shown as code inside. So there you have to devise and work on the functionality of what response you should provide when a user would click on that button, for example. So with this, we can move on to question number 23. Question number 23 states, how is routing in React different from the conventional routing that takes place in other frameworks? It's very important that you understand the subtle differences that lie in between conventional routing and routing in React in two aspects. One, it's by using pages, where when you think about React, here every single page is actually a new file that gets moved around in conventional routing, in case if you used conventional routing, right? So but then in React this is not the case. Each view is not considered as a new file in an explanation where all of these files become one single HTML entity. So instead of having a new file with the conventional routing methodologies, here we have one single HTML entity that can deal with all of these. So that's with respect to pages. And then when you have to talk about navigation, right? So in the case of conventional routing, users will manually have to move across different web pages to probably view different things. And every time this is done, the view model is basically refreshed, right? So whenever you click on different pages, every time the website gets refreshed, the application gets refreshed. In the case of React, that is not the case. The view will remain the same. The view is not refreshed because of only one important thing, is that the objects are reissued here to create new views, and new objects are not created here, guys. So creation of new objects, updation of the DOM model will create a scenario where the page automatically refreshes when you click on the new website, but in the case of React that does not happen. So this is a very important difference between conventional routing and the routing that happens when you use React. Coming to question number 24, it states, what's the difference between Flux and Redux in React? Well, we're going to check out Flux and React both in detail, but then to answer this question in a very concise way, you can name about 4 or 5 points where, in case if you're talking about Flux, it contains the logic and the state of the applications in the same place, where when we're talking about Redux, that is not the case. The logic and the states are stored in separate places. And then when we talk about states, Flux has mutable state. It can be changed while updation in real time, while with respect to Redux, the states are immutable. And then when we talk about the number of stores, we spoke about stores a bit before. Flux has only one store and Redux has many stores. And then if you're talking about a dispatcher or a handler, Flux does have a dispatcher, while React does not come with dispatchers. And then of course components. Components are connected to Flux in React directly. And then when we talk about Redux, of course, since we're talking about Redux, the container components are directly connected, guys. So, when you think about the basic differences that exist between Flux and React, one is the presence of a dispatcher, the other one is the ability to have multiple stores, the data being mutable, the states being mutable more precisely, and then the separation and the storage of the states and the logic. So these 4-5 points are found to be the foundational differences between Flux and Redux in React. Let's come to question number 25. Question number 25 states, can Ajax be used with React? So the first thing you have to start out with your answer with when you have a question like this is either yes or no. And in this case, the answer is yes, because just like any Ajax library where you have jQuery Ajax, you have Axios, or any of these libraries, you can use this very easily with React. But to do this, you have to remember one very important thing is that every single component has states, and you have to maintain the states here, because properties are again passed down to the parent, to the child components, and to make sure you maintain all these properties and that they are correct. And with React, you will lose the ability to move data in two directions, right? So it's unidirectional. So once the props sent from the parents to the children, then there is no way to send the props back to the parents, right? So this is one thing which is an advantage in terms of workability, and of course in terms of rendering efficiency. It'll have a huge impact whenever we're working with dynamic data. So the answer is yes to this particular question. With this, we can move on to the 26th question that states, what is the meaning of synthetic events in React? We checked out what events are, but then what are synthetic events? What you have to understand about synthetic events are, yes, even they are objects, and the simple thing is that they act as cross-browser wrappers. So what this does is this will allow the users the ability to make use of any of the native events in React alongside this as well. So why is this done? Why do we even require cross-browser wrappers, right? So this is done only to increase compatibility. So by doing this, you can make sure that your API can run across a variety of browsers and that it does not become browser dependent. So if a piece of code or an application works well on, say, Google Chrome, but then if it fails to work on Safari, it really doesn't make sense, right? So to make sure that the ability of React has the outreach of multiple browsers, we use these synthetic events to do that for us in a very, very simple way. Now with this, we come to question number 27 that states, what are stateful components in React? Stateful component, as the name suggests, are entities which have the ability to store any changes that happens to them and hold it in a place of memory. Stateless components will not have any states because they will not have the ability to store the changes that happen or hold them in memory. But then stateful components, yes, they can store all the changes. So whatever change in state, it is stored along with other information, such as what are the changes that happened in the past. There'll be a document for that. What are the current changes that are taking place while the document is being executed and active rendering is taking place, and of course there will be documentation of in case any future changes do occur as well. So stateful components play a very vital role in the working of React. And then this brings us to the 28th question. The 28th question states, what are refs in React? And again, as you might have already known, refs is actually a shorthand for references. So whenever we talk about any sort of references in React, they used to store the reference to either one single React element or store references to a React component. And what and why we do this is to only make sure that we can return it later using the render function to, let's say, if you have any good animations that you have to run, imperative animations that keep running either on a loop or any rapid animations. Then of course, so references are mainly used in case if you have third-party DOM libraries that you have to work with. And of course, one very important use of refs is to make sure you have the ability to manage focus and apply media playback to your web application or on your website for it to render as well. So mostly it is used in the case of media, animation, images and videos. But then one very important thing to mention is that it is also used to join third-party DOM libraries. Well, with this, we can move on to the 29th question that states, what are controlled components in React? We checked out what components are, stateful components are, but what are controlled components, right? So controlled components will always refer to the components that have the ability to maintain their state, same as stateful components. And here the data is actually controlled by a parent component. So this is a child component in the first person's perspective. And when we talk about this, the whatever value is present here is fetched only by making use of the props that it gets from its parent component. So why is this done? This is done only to make sure to quickly notify if there are any new changes that occurs when we're using callback functions while rendering. And this at the end of the day will simplify about 5 or 6 other steps that need to be done in case we do not make use of control components. It makes sure that the code is simple and effective to work with for you as a developer and React as a programming framework as well. Now, when we talk about the 30th question, one very important aspect that we have to cover in this particular interviews questions segment is why is a router required in React? Router is something which is very important, as you'll see, and this is a question which is again very important in a React interview. So when you think about routers, well, routers are extremely efficient components, when we talk about React, because when we add that onto our URL, the user is taken from one particular component, and it's basically like mapping out a route for the components. So once you have a component of framework where you can actually walk through each of these components in a particular order, in a particular route, well, this is why it's got the name router. And there's a simple piece of syntax on your screen right now that denotes the usage of the router library. And of course, since we're using router, the library has to be added in React, and of course it can be done using this syntax. So we have the route exact path, we're defining the path, the component is the home component, then we have another component, new post and post. And as you can see, we are routing it manually from home to new post to post, right? So the router is mainly required for this purpose. Now with this, we come to the 31st question. So the 31st question states, what are the components of Redux in React, right? So one very important thing that you have to keep in mind while answering this question is that Redux comes with 4 very important components. It's action, it's the reducer, it's store, and it's view. So action is an object that actually describes the call. Reducer will actually denote the state change that happens in the storage unit. Store, on the other hand, will denote the state and the object tree storage, while view displays the data that is provided by the store. So the features of the components go very hand in hand with their name. So an action will describe the call, the reducer will show the state change that happens in the storage unit, the store will denote the object tree storage and the states as well, and then the view will display the data provided. You have to remember the components, and in case if you do not know, just recall the names of it, and once you get the names, it is pretty easy to understand what it does and then convey the same to the interviewer as well. With this, we can come to the 32nd question that states, what are the advantages of making use of Redux? Well, there are numerous advantages of making use of Redux, but then to keep it very simple here, we've picked up the top 4 advantages of making use of Redux. One, when you talk about organized approach, right? So Redux requires code that has to be organized, and doing this will make sure that the code is consistent, the code is easy to work with, and it is structured at the same time. So to make use of this, your code has to be organized. And then when we talk about the testability or the testing ability in general, Redux functions are very isolated. They are extremely small to work with, and testing a small piece of code is very much easier, very much quicker than working with a large piece of code and then testing it later. And then when we talk about tools, developers can actually track actions and all of the tools in React by making use of Redux easily, and they do not have to put a lot of effort to do this. And then when we talk about the community aspect of things, Redux has a large community. This is an open source community, both React and Redux. So in case if you do require any help of working with Redux, or if you're stuck with any aspect of it, of course there are users who are out there who are ready to help you, and you can even get libraries built up in case if you do have a niche application as well. So in terms of community as well, there's a very big advantages of using Redux. Now with this, we can come to the 33rd question that states, are there any disadvantages, or what are the disadvantages of making use of the model view controller in React? One thing that we've already discussed is a lot of advantages of React in these 33 questions, but then there are certain tiny problems of making use of MVC as well. When you use model view controller, there's 3 steps: modeling, viewing, and then having the controller model all of these together will make sure that there is a slight bit of memory wastage that you have to consider. And then when you have to work with the DOM architecture, manipulating the DOM will actually take a lot of efficiency, take a lot of time as well. And doing this, the application will actually become very slow. There's a lot of dependencies that is created along with React in the case of MVC, and if you have to combine all of it together and give one big disadvantage is the model complexity will increase a lot. So for a developer, it will increase a lot in terms of workability, and for React as a framework, it will decrease its efficiency, make it very slow, and add a lot of dependencies which basically give you more probability of the application failing or something not going right. So in terms of you as a developer, there are certain disadvantages you have to consider, and then React as a framework again comes with tiny bit of disadvantages, as you can see on your screen. Now we can check out the 34th question that states, what are pure components in React? Pure components we have checked out, stateful components are done. So pure components are similar entities. They're actually singular entities, that are actually written in React. So what happens is that they are fast, they're simple to write, they have the ability to replace any other general component that you might have. And the only important thing is that it has to have a render function attached to it, because if you cannot render a new component, it is deemed useless. So to do this, you might be wondering, okay, can we use the regular component itself? So why do we require pure component at all? Well, a pure component is used only to make sure you keep the application workability high, to keep the efficiency and performance high while keeping the code same. So since these are singular entities, right, so they can be wrapped around in themselves and they can be independently stored, independently worked on, and not have any sort of dependencies outside of the rendering ability as well. So in that particular case, when we talk about simplicity, ease of use, and how good it is for both the developer and the application, pure components wins. So after understanding pure components, we need to check out where HOCs are used. HOCs are higher order components, and we've already discussed this in a previous question. So HOCs are put to use very much whenever there's a requirement for code reusability, or let's say you have to hijack a render method, or if you have to manipulate a state and work with abstraction, and then of course if you have to manipulate properties, or if you have to work with bootstrap abstraction as well. So to be honest with you, there's a lot of applications where HOCs are put into effective use in React, but then you can mention 5 or 6 where they're the most effective and add the most value. And this of course will power up your answer as well. So manipulation of props, state manipulating, render hijacking, code reusability, and where there's a requirement where you have to work with bootstrap abstraction as well. So these are some of the very important tasks that HOCs are put in use for. Coming to the 36th question, it states, what are keys in React? So as the name itself suggests, keys are actually used to keep a track of something here. So what is that something? Well, here we'll be checking all of the items and tracking changes on these particular entities actively. So what happens is that they used to check if an item has been added or if it's been removed in a list or not. So only to check the presence or the absence of these items in the list, we use an entity called as keys. And there's a small simple syntax on your screen which shows the usage of keys in React. So again, just as with any other question that we've been talking about, if there is a situation where you can provide a very simple code snippet or a syntax snippet where you can explain your answer better, please make sure to do that for all the questions as well. So if your question can fit a quick syntax or a quick dirty piece of code, guys, please make sure to do it, as this will add a lot of value to your candidature in that particular company as well. So understanding that, we can move to the 37th question, which states, differentiate between controlled component and an uncontrolled component in React. A controlled component, as the name suggests, is actually a component in which React can do whatever it wants on it. So React has complete control of it, and there is a singular point of data for the forms where you have to perform state changes, get it re-rendered, and all of that. When we talk about uncontrolled components, here it's very important difference is that the data gets handled by the DOM and not the React component itself. So React does not have complete control over this component. And how is this done? This is done by making use of refs in React, as we already checked out, right? So if you have to implement and handle third-party DOMs, if you remember, that was point number 4, I think. Yeah, so this is where it's used. And an uncontrolled components, while being handled by a DOM and not React, has its own advantages and disadvantages. Now, coming to the 38th question, it states, how can you tell React to build in the production mode, right? So what is the simple way of you conveying to React to move to the production mode? So you can actually directly code in production mode, but then to do it, you have to set one very, very simple variable. It's called as the environment variable, and then it's process.env.node_env, and you have to set this variable to production. And one very important thing that you do have to note is that once React is put into production, right? So if there is any other developmental features that you have, or let's say if there are any warnings, all of these are not shown in the production mode. So this is something which is very important for you to mention in the interviews as well. So it's as simple as setting an environment variable. Now with this, we'll come to question number 39 that states, what is the difference between clone element and create element in React? So what is the clone element and what is the create element, right? So clone element, again, since React is highly readable, you can already tell by its name, it is used to clone an element and pass it to new properties directly. With create element is an entity where all the JavaScript XML files get converted and gets compiled and converted into a format where it is understandable by the browser, and then this is also used to create elements inside React itself. So create elements will help in the actual creation of elements in React, and of course to help in JSX files getting compiled as well. And clone elements clones the element and then passes it on directly to new props. So guys, with this we come to the 40th question that states, what is the use of the second argument that is passed on to set state? So we have something called a set state and we have a second argument that goes to it. So is this second argument optional or not? Well, the answer to it is that, whenever set state is actually finished, there is a callback function that gets invoked, and then all of the components here gets re-rendered in React to make sure that, the latest render is shown to the user. So with this, when we make use of set state, we have a second argument there. So the interviewer is trying to ask you if it's an optional argument that you pass. The answer is yes. Since set state is actually an asynchronous function, what it does is that it takes in just another callback function and works normally. So, even though it seems very simple to directly do this, a clever programming practice, a standard good governance programming practice will always tell you to make sure to use another lifecycle method instead of directly passing it via the optional argument as well. I mean, there are multiple reasons to do this, but then they are not in the scope of this answer. So when you asked about if it's optional or not, make sure you answer yes. And why is it optional? Because it is asynchronous and it can handle the same thing in another callback function as well. So with this, guys, we come to question number 41. So the 41st question states, is there any way to avoid the requirement of making use of binding whenever we make use of React? The simple answer to this is yes, we can actually avoid binding when we're making use of React, and it is done in two ways. One is that you can define an event handler as an inline arrow function, the arrow function that we discussed in the previous couple of questions, and then secondly, you can make use of a function component and use it with hooks to make sure that you do not have to bind any component to each other and work with it as well. So either making use of the arrow function or by making use of hooks, you can avoid the need of binding in React. So moving on to the next question, it states, what is the strict mode component that is used in React? So whenever we talk about strict mode component, one major thing that you have to know is its advantage and why is it used. So, whenever we create any new code bases where you have to understand what components are being used there, right? The strict mode components are immensely beneficial for this. Whenever we talk about in terms of debuggability, there it will help as well, because if we can solve the problem faster whenever we wrap it with any other component, it will of course solve it quicker, because that would be the one causing the problem, and we've just wrapped it with another component and then worked with it, right? So the strict mode component is used for two things: one, in the creation of new code bases, and second, to be wrapped around other components to provide easy debuggability. So make sure that you mention these 2 points. With this, we can come to question number 43 that states, what would you do if your React application is rendering slowly? Again, this is a question which is very, very, very commonly asked, and then guys, pay attention on this one. So why do you think, rendering is slow in React, right? So the most simple answer to why rendering is slow in React can be answered in the way where, because there are so many re-rendering operations that are being done. Sometimes they're necessary, of course, if you have a very large applications, but then most of the time these re-renderings can be unnecessary and redundant. So there are two main tools that React will give you where you can check this and fix this. One is react.memo function, where you can prevent all of the unnecessary re-renderings that takes place, and whatever the function components does, you can actually find what is the rendering that is not required to be done and then remove it as well. And then you have the pure components. Of course, pure components is put into place to make sure that you remove all of the unnecessary rendering in any of the class components. So in both the ways, with respect to function components and class components, React does provide a way for users to make sure to remove redundancy in terms of re-rendering, as you can see on your screen. So make sure to mention react.memo and its usage for function components and pure components in a way where we're talking about removing redundancy with respect to class components. So with this, we move on to question number 44 that states, can you conditionally add attributes to components in React? The answer is yes, you can add attributes to React whenever there are certain conditions that are met. One thing you have to know is that React has the ability to completely omit an attribute if the value is passed to it is not true, right? I mean, logically speaking, this is supposed to be done, this is supposed to be done automatically, but then many of the programming frameworks does not do this, and React has advantages in this way as well. It can completely omit an attribute if the value that is passed over it at the end of the day is not true at all. Now check out the simple example that's given on your screen to see how you can conditionally add attributes to components, right? So we have var condition equal to 2, var component, we have the div value is foo, and then we've easily added an attribute to the component there to further make use of it, right? So if the condition is met, then yes, you can add attributes to it, and that is shown in the example on your screen. Coming to question number 45, why is props passed to the super function in React? So when we talk about properties, again, all the properties are passed on to the super functions if and only if the user wants to make use of this.props. So if the user has a requirement to make use of this.props in the constructor, only then will the props get passed on to the super function. So it can be shown on the screen in the example that you're seeing right now. So when you talk about the constructor there, we're extending the React component and we have the constructor of props. So once you've made use of the constructor there, we're going to use this.props, right? So once you have to use it and once it is passed to the super function to have access to this.props, we make use of the super function, guys. So coming to question number 46. Question number 46 states, what is the difference between the get initial state and the constructors in React? You have to understand that whenever we make use of ES6, right? So users have to actually manually initialize the state in the constructor, and then to do this, to manually initialize the state, we have the get initial state function. This method is actually defined by the user and worked on as well. So this is done very, very easily, as shown in the example on your screen, guys. So check it out. So we have the constructor props, you have the super function, and instead of calling this.state, so we have manually defined the state, right? So this dot state, and we have given a comment there calling it initial state. So if you want the ability to go on to do this, you will have to use get initial states instead of direct constructors as shown here. And then when we come to question number 47, it talks about the predefined prop types that are present in React. You do not have to explain all of the prop types that are present here, the properties. In fact, you can mention them and then be good with it. So there are actually 5 very important properties, predefined property types in React as shown on your screen. One is the bool, one is the functions, the other one is the nodes. We have number and string. Of course, react.proptypes.bool, func, node, number and string are the predefined prop types that are present in React. Again, all of these properties are used for their own niche applications, but at the end of the day, it is very important that you know this and you show the interviewer that you know that there are these predefined prop types that exist in React. So with this, we can move on to the 48th question, which states, what is React Fiber? Well, React Fiber is a new engine in React. So it is actually the re-implementation core algorithm that comes along with React 16. So one of the main important goals of React Fiber is to make sure that there are incremental rendering facilities given for the virtual DOM itself. Why is this done? Again, the primary talk here is about efficiency as well. So whenever you have to render, let's say, any gestures, animations or anything of that sort, this will make sure that it will help in giving the right priority to what updates need to happen at what point of time. So again, this way there is no delay or there is no latency in terms of the gap that exists between multiple renders that happen for the DOM as well. So this is why React Fiber is a very important aspect of this. And then we already spoke about hooks. coming on to what hooks actually are. So question number 49 discusses about what are hooks in React. So hooks again are entities that are used to make use of a state and any other features in one very important condition where you do not have to write a class for them. So hook is actually a new implementation. It came along with the React version 16.8, and here one very important thing is that the stateful logic can be extracted from any component very easily while testing it, while reusing it, repackaging it, and whatever you need without having to write a class specific for it. That is the advantage of hooks. And then this actually implicates that you can do all of these changes to the component hierarchy and all of these actually implicate that, anything can be done here or whatever we mentioned without having to change anything in the component hierarchy as well. So there, re-rendering, re-objectification, all of that is again removed, again working on efficiency, working on easy to use feature that the React framework provides for the users as well. So coming to the last question, the 50th question, we discuss about certifications. So, the question states, have you earned any sort of certification to improve your learning and implementation process in React? Guys, know this. A certification program is not only a bragging right where you say that you're a certified developer, but it'll give you so many advantages in terms of career advancements where, it'll show the interviewer that you're very serious about understanding React, implementing React, and working with it. And if you've picked up a certification program on your own, you're trained on it, it'll also show that you're an effective learner who has the ability to grasp new concepts and learn them effectively and master them at the same time as well. So this either you can be a beginner who's interested in React, who has absolutely no idea of how React works, or if you're a person who's switching from another framework or say a programming language like Python or something and you want to master React, well, of course, yes, that'll add more value to your candidature. So one important thing is that do not get lost in mentioning the certifications that you have or talking about that in detail, but then what importance is given to the answer here is to make sure what you learned from them. So the importance that you have to give here is to talk about the applications or whatever you learned from the program rather than the program itself, right? Because at the end of the day, you learned a program to implement something. Do talk about that implementation. Do talk about the projects and how it has helped you on your journey into understanding and making use of React, be it in the learning environment, be it in an actual project use case or a production environment. A certification program will give you all the training and the structured learning that is required to make you proficient in React. And of course, it is not only that, there are multiple advantages of having certifications as well, and I'm sure you guys already know this. So with that, we come to the end of this very important top 50 interview questions for React, and I take this opportunity to wish you all the best of luck for your React interviews. I'm sure you can use this guide in a way where you understand the questions thoroughly and find ways to answer these questions in an effective way. We hope this comprehensively put together React.js full course video was of complete use to you guys. Well, if you have any suggestions, any comments, any feedbacks, make sure to head down to the comment section and do let us know there. We'll be more than happy to help you out. On that note, I hope all of you are keeping safe, keeping your learning up. So I wish you well, and I'll see you on the next one.